Testing. 1, 2, 3. Oh, I love it. Started in 1 minute. Already 10 o'clock. 1 minute. I have LH1 and LH4 for the microphones. I have LH1 and LH4. All right, testing 1, 2, 3. Ooh, I sound booming voice. I love that. Very good. Okay. You guys, everybody here, you have literally weathered the storm. Welcome to Handmade Seattle 2024. Come hell or high water, I am doing this conference. You guys have put your trust in me and my staff and in Seattle Center to put together a lovely conference, even if there's a storm literally raging around the corner. And you've made it. You did it. This is great. And I hope you spend a few minutes with me. We have amazing presentations today and tomorrow. We have amazing speakers and talks and demos and never before seen demos and podcasts. If you're on the online track, you know, when lunch hour comes in and you're like, oh no, people are having lunch and I feel FOMO and I'm missing out. And don't worry, we have an exclusive podcast for you guys during lunch hour while people go have lunch here in person. So as you know, this is a fully hybrid conference, and we're 100% independent. And because we're independent and we have no sponsors, we have no companies to announce, I'm going to subject you to my Jimmy Wales Wikipedia speech, okay, of why I'm indie. That's a little bit of an inside baseball of how this works. And then we'll actually get started, okay? So just bear with me here. With Handmade, we care about many things, but I think a big thing is software quality. And many of you, like I said, you've even in the weather, you've made it here because you also, I believe, care about software quality. And we might have arguments and debates, maybe on the chat, maybe here in person, about what we mean by quality. Some of you here are hardcore. It's like, well, quality means everything from the ground up. We're going to use, you know, just assembly like Roller Coaster Tycoon, right? Maybe a sprinkle of C here and there, right? But to some of you, it might mean, no, I'm going to use Unreal Engine. I'm going to use Unity. I'm going to use giant frameworks, but I'm going to care about every single part of the building process. And if something seems too heavy and too slow, I'll replace it, right? And I'll do something else. And I care about the craft, whether I'm up there in the stack or down low, right? And I would love to see conversations about that, like a little bickering fight about what that means. But you care, and that's what I want. you do care about software quality, you care about the user experience. And we've seen how software has gotten worse over time, not just with the way it feels to use every day, but what it's being put to use for. Many software is also being used for things that include mass spying on people, mass advertising, and all kinds of shenanigans that you wouldn't even believe if you've never heard the term like data broker, for example. I've learned a lot about that this year. It's insane. Lots of people who have no idea how much they are being violated in terms of their privacy, right? So I think at Handmade, not only do we care about the craft of building good software, we respect the user too, or we try to. We do our best to do that. So thank you for making it. All the presentations here come from speakers who can be as spicy as they want. They can be as honest as they want. When I'm indie, that just means that if you leave trash on the floor, that bill goes to me for the extra janitor work. Right? But why am I doing that? Why am I going through the trouble of, forking everything, just like surviving just on ticket sales, for example, and things like that? It's because I want my speakers to not have any nervousness when it comes to talking about something, right? If one of our speakers today, for example, one of our openers is going to be Andrew Kelley, the creator of the Zig programming language. Thank you for being here, Andrew. I'm glad you made it. If he wants to say fuck Microsoft and curse a little bit, I'm going to allow that. You know what I mean? Like this is also the 10-year anniversary of the Handmade community, of the Handmade movement. 10 years, can you believe it? And my God, I started in my 30s. My God, I've been here for 10 years. And it's not just me, obviously we have a whole, we're gonna talk about that very soon, about the history of Handmade. So, but before we do, my staff, specifically my editor, Devon, prepared a little video. You're gonna see Abner throughout the years, never before seen footage, like after some conferences, including all the way back to when I started running this at 2019. So I'm a little scared of this video, Devon. I'm trusting you. I'm kidding. Whatever's there, I think I'm gonna be having a good time with it. So let's celebrate the 10-year anniversary with some comments and some history from yours truly, and then we'll begin our presentations. Cue, roll the tape.
How do you think it went?
As I was saying earlier to some of the audience, I think it was a bit of a stumbling success.
Yeah.
So there were some good things that happened in general. I think the organization was solid.
Yeah.
But the problem is there's some things that even if you prepared for them just went awry.
Yeah.
So we're talking about technical glitches, having to interrupt one of the speakers was very uncomfortable.
Yeah.
Because we lost the screen projector being recorded, and that we don't want to lose recording. So it was a tough call to make, because we also had a thing where timing's running out for the crew to come in and create the layout for the afternoon. So I had to make some tough calls, how do you interrupt, how do you do things? But other than those kind of technical glitches that I think almost all conferences have, it was generally okay. It was a lot of fun.
Yeah. How do you think the talks went?
The talks were great. There were deep technical dives into each of the person's expertise. Yeah. So if you look at Tom Forsyth, somebody who actually worked and invented a lot of instructions for the ISAs for the Intel chips, and AVX 512, which is a very popular thing among low-level programmers, he contributed to that. So that's an amazing experience for us to hear the man himself discuss those things, for instructions that we take for granted or take advantage of all the time as programmers.
And that's a weird thing to think about, because consider, why didn't turn-log-op exist before? No real reason. So the provoking thing was that microcode sucked on the chip we were using. Cool. I mean, I can, because I invented it. I actually have the, okay. I have the little plaque, so I'm not saying who knows what the guy was thinking? I know what I was thinking. I was trying to solve this problem.
Why did you decide to write a custom C parser / compiler instead of using GCC or Clang and just hooking the exports as is usually done for language bindings?
I like to control our own destiny. And controlling our whole tool chain as sometimes, why don't you use this other thing? Because my experience when using that other thing is we can't get any support from them. So when it doesn't work, instead of fixing the problem, I have to develop workarounds for it. And I just don't like that. I like to control our whole tool chain and the customer experience from front to back.
How do you think this year went?
Oh my God. Best year ever.
Yeah.
At least in terms of like my personal day-to-day time here, like I actually felt relaxed.
Yeah.
I actually felt like I could sleep at night. I actually felt that there was a process in place. It was almost like an autopilot.
Yeah.
Right?
Yeah.
I still had to set some parameters, right? Set some directives and instructions because I am in charge. But for the most part, like with the new staff that I have, and with also the audience understanding how this goes, right? Just the formula is polished. And now I feel like I can enjoy this.
Yeah.
For the first time, and for the first time ever, I could actually walk around the crowd.
Yeah.
So in the past, it was more like somebody tries to stop me and says like, "Oh, hey, I know how you." I'm like, "Hi, I gotta go." "Hi, I gotta go."
Yeah, you're
right?
just being pulled in every direction. Yeah.
Pulled in every direction, running all the time with my hair on fire, and it's a lot of hair, so it's dangerous. Okay? So finally, for the first time, I could just walk around and enjoy everything. Thanks to the staff, thanks to the audience, also just knowing how this works. So, yeah.
What are your goals for next conferences? Are there any other places that you're looking at?
Right, so as you know, it's no longer Handmade Seattle. It's now Handmade Cities, because I'm crazy that way.
Yeah.
And I want to expand, because there's a message here at Handmade that we need to preach, and it can't just happen in Handmade Seattle. So Handmade Boston, as you know, people know, I did my first one ever this year. And the goal for next year is polish, though. So I'm going to stay with Handmade Seattle and Handmade Boston. Handmade Boston needs a lot of polish because it was my first time ever. It's an alien format compared to Handmade Seattle. So I need the time to make sure that's good. But we also have this idea of meetups, and basically meetups.com but handmade. I did spin that up this year so that handmade folks can meet all year round. I give people hosting meetups once a month in their city access to my newsletter, which at this point this conference newsletter is very big. So hopefully they can have access to that to send invites for their meetups, and that way we start to have more in-person hangouts. That is not just conferences. So next year I'm going to say polish for Handmade Boston, and then the meetups initiative to just have handmade folks meeting all year round. That's going to be like my focus for now.
Yeah.
The meetups thing, that's true. You know, given this year, as you guys know, I'm honest about these things. You know, it wasn't a good year for many people. You know, it was tough. And those who have been having a good time this year, feel grateful, feel lucky. Don't feel, you know, guilty about that. And even in this conference, as you know, like we've been growing and growing and growing, and then this year it's like, oh my God, like a mass layoff apocalypse. And ticket sales drying up, donations drying up, right? But something happened throughout the year. I was getting lots of people who are thankfully doing okay. They're like, Abner, whatever you need. Donations, no strings attached. I'll buy tickets on your behalf, like whatever you need. And because there was such a mountain of love and support, some of these people are right here today. We were able to keep the conference running and to keep the business going. So even if you feel like, oh my God, like there's not so much attendance this year, or like it feels a little smaller this year, it actually is not, right? The conference is alive, it's strong, it's kicking. I survived when so many other conferences have shut down, okay? So with the meetups happening this year, you know, in Seattle, it's one of our largest meetups, but there's like the host of New York is right here. The host of the meetups for DC is right here. I think there's some others too. France, for example, came all the way from France to be here. So Vienna, Austria, Tokyo has started recently, et cetera, et cetera. You saw the link to the website for the meetups. Every time there's something bad, the conference comes out stronger. Like COVID happened, remember COVID? I went fully online, and then all of a sudden, fully hybrid after that. Right? Fully hybrid. Like now we have online setups, live streaming, new staff to help me with that I pay. I love it after COVID. And now this year, what's the lesson? Honestly, in-person connection. The fact that we want to just hang out with people more in real life, outside of just work. Outside of just work. Regular, repeatable exposure with people who share the same likes as you. In this case, we care about building good software. So we've made it. Like I said, we're here. And our first presentation, before we begin with Andrew Kelley, like I said, we're going to have a little bit of a conversation because it's our anniversary. It's our anniversary. So my other half, my partner in crime, is Ben Business. Some of you know him, right? Can you raise your hand if you know who Ben Business is? I love it. I love that. He is the lead of the Handmade Network. For those of you watching online, you might be a newcomer. These conferences take a lot of my time. This is what I do full time. It's like in-person stuff. We have an online community, huge Discord, right? Huge jams, huge web, everything. And like online, I can't do that anymore. So Ben is the lead of that online community, so I can focus on the in-person stuff. And he's currently a WebAssembly engineer at Mozilla, for example, and he accredits Handmade and the community for learning in good part to become a WebAssembly engineer too. And like he's gone through the ringer from the beginning of the community to all the way where he is now. And he's also a close friend and, like I said, partner in crime. So please give a round of applause to Ben Business. Please. Take that seat. See if the button is on the way up.
Check. All right.
Check, check, check. This is awesome.
Yeah.
Okay, so for those of you who might or may not, I don't know if you have access to the chat server. This is Revolt, okay, guys? We have started the conference officially, so make sure you have access to Revolt, because if you do, I'll be able to look at your comments on the general channel. On the general channel, if you want to comment on what Ben is saying, what I am saying, right? Or later on when Andrew Kelley is speaking and you have questions to ask, do it on the chat server, okay? And when we can get started here. So, Ben, you made it just fine?
Yes, I made it great.
Okay,
I got in just before the storm by the looks of it. So, very glad for that.
Yeah, I hope we see more people tomorrow. I know that I got a lot of emails saying, like, you know, my flight got delayed, but I will come here no matter what. Okay, so handmade history, oh my God.
Yeah, I mean, 10 years is crazy to look back on. I got into the community in 2016 or so, I believe, from looking back at, you know, old Discord messages and that kind of thing. Not quite as early to the community as others here. Obviously, you were there day one. People like Asaf were there day one. I came in just a little bit later, but I've been really pleased to be a part of this community for like 8 of these 10 years of Handmade's existence. I definitely want to take the chance to look back on this 10 years and what Handmade has meant to both of us personally, but also to all the other people that we know in this community who've been around for this past decade.
Yes. Personally, what do you want to know that's personal?
Well, so you know, you saw this video just a little bit ago, looking back at the history of these conferences.
Terrible hair.
But it goes back much farther than just 2019, right? Handmade Cities, I suppose, started about halfway through the lifetime of this broader handmade movement. But could you tell me a bit about what it was like in just those very earliest days, how this handmade thing started, why it's called Handmade, what this network is like? Because Abner said I'm the lead of the network, but Abner's the one who founded the network. And I feel like, you know, you should talk about that and explain kind of what the motivation was.
Yes, so back when I was at NASA, my God, I was born and raised in Puerto Rico, okay? But I was obsessed with computers. My dad, I was a military brat. My dad brought mainframe computers on the house, and like was like 5 years old. Oh my God, look at all these. Back then, those mainframes were giant. You know what I mean, guys? And there was like gigantic computers, especially in the military. And it's like, wow. And I was obsessed with it ever since. And then as I was growing older, starting my teenage years, my rebellious phase was I wanted to be a hacker, right? And you look at the hacker movies and you're like, how does that look cooler than command.exe? Like, what is this guy using on the movie? Because I'm not seeing it on Windows. And that's when I search on Google, no, not even Google. I'm showing my age. Ask Jeeves or Yahoo. Those were better search engines than what Google is today, by the way, anyway. So, and I'm like, wow, Linux is a thing. And apparently Linux can have cooler terminals, like the movies. And so I'm learning as a teenager like how to partition these machines, family machines, which got my family angry, but I got Linux installed and I learned how to write programs in C for terminals, and amazing. And then college, they started to show me to not use C anymore. It's an outdated, archaic language. where's your knowledge of best practices? Where's your knowledge of don't repeat yourself? Where's the clean code principles? All of these things beat into my head. At that time, though, my history of Linux forums, because I was posting as a teenager on Linux forums, and I applied for different internships, and then NASA directly reached out to me and said, we need people who know C, and we need people who know low level. And so I got to leave Puerto Rico, make it to NASA. And then at NASA, I was asking my coworkers and my mentors, oh my God, like this file seems like it needs to be broken up. It's too long. Like these members need to be private. Where's the idea of scope here? And I was having debates about Python versus C, language wars. I was really in on Vim versus Emacs, all the classics, all the classic hits. And my mentor, I remember at NASA, poker face, and then no, they didn't slap me, but but like saying like, what are you doing? Like everything you're learning in school seems to be not working for you here. Like you don't need. It's better what you learned like in a ragtag way and when you were 13 about writing terminal programs. I prefer that knowledge than what you learned at school. I'm not even kidding, right? It's like, oh, what? At least universities in the US, programming school seems to be a problem. Not necessarily everywhere, but it happens a lot. Many of you, I'm actually want to know, like, if you feel like, for sure, yeah. And go ahead.
I actually had a pretty similar experience. Maybe not, the childhood aspect of it exactly, but college and my first job were, I was constantly bumping into things that didn't make sense to me, and where the best practices that were being taught to me didn't make sense. In college, I was arguing with my professors about getters and setters in Java. Like, why do I have to do this? Why can't I just make the field public if I have a getter that just returns the field and a setter that just sets the field? How is this any different? And they would tell me it was because of encapsulation. I'm like, but it literally works exactly the same. Like, why are you telling me this? And I would encounter that at school. I would encounter that at my job. I would be told to use this pattern. It's like, oh, you should make that into a service. I'm like, what does that mean? And it's like, well, it sort of groups the thing and it, encapsulates the, it's a good idea. And I, at the time, was trying my best to, respect the, the expertise of these people who were teaching me and trying to navigate that and trying to understand, trying to trust that, maybe I'll understand it as I gain more experience. But then I encountered Handmade, and that was the first place where people actually acknowledged these kinds of issues, where they would say, yeah, the dumb getter and dumb setter are not actually any different from the public field, or organizing things in this way doesn't actually have any impact on the way that your program runs. And I was shocked to find a community of people who understood that. And it sounds like it was similar for you. What was it about Handmade Hero, though, that really pulled you in then? Because this was after you had started at NASA, after
Yes.
you had started to have this experience?
Yes. So in the middle of my internship, I got nerd rage over what my mentor said. My mentor was correct, that a lot of what I learned in programming school and university was not helping. But they still gave me a shot, and I was able to. But I was like, I remember Googling, this time Google was a thing now, so I'm like, okay, I'm Googling, is software engineering going down a cliff? I think that's what I searched for, something like that. And then I saw some articles and some rants from Casey Muratori, right? Like some posts. This is the creator of Handmade Hero, right?
Yeah.
And from day one, I'm like, I like this. I like what this guy's talking about. Like, I'm not seeing it anywhere else. And then he started streaming, as you know, on Twitch. And his first ever stream, even before Handmade Hero was the official name, he was doing some intro to C series. The first Q&A ever was me. Like, you can still find it. If you go to the Handmade Hero page, look at the streams, the very first one ever, my name is, I'm the first question. And I'm like, I want what Casey's doing. And then Casey starts Handmade Hero, blows up like crazy. Apparently people in the industry feel the same way we were feeling.
Yeah, that was the amazing thing. And you were the one who was actually there for that part of it. I came in a little bit later, also found it via Casey's article, I think, about compression-oriented programming.
Yeah, semantic compression.
Which is an absolutely incredible read that fundamentally, changed a lot of the way that I approached programming. It must have been this incredible hunger across the whole software industry because of
we were not alone.
Yeah, how immediately it gained so much popularity and so much traction with people. So it's incredible to think that there would be that kind of unfilled void across the industry of just somebody sitting down to write something from scratch and to teach people and to reject this idea that, you know, you're too stupid to understand these levels and I'm just going to show you how everything works. So, I mean, what were those first years like for you? Those first months of Handmade Hero, those first, you know, streams?
I was caught in a storm for sure with the, you know, Casey's Twitch blowing up and then Twitter blowing up, and because I was there from day one, and Casey saw, oh, like Abner seems like a smart dude, like young guy, he's a NASA, all these things. Like, he also seems to like people more than I do, and he's really open about this, by the way. I'm not like spilling any secrets. Like Casey's openly like.
Does his Twitter bio still say highly misanthropic?
His Twitter has said highly misanthropic in the past, so it's like great programmer, great friend.
Oh, absolutely.
But when it comes to interfacing with the larger online community, I can understand why he might not want that. So he's like, oh, Abner, like you're a social butterfly and you understand what I'm talking about. You're a low-level guy too. So like, why don't you help organize the community? And that's how I got my start. It's like, help organize Handmade Heroes community. But then I was noticing people writing projects outside of just games. Like people were making their own text editors. People were making their own attempts at replacing Photoshop. Or
their own operating systems.
Literally their own operating system. And I was like, this is amazing. We should have a place to collect all of it. Our network, you know, one of the community members, D7, recommended this name, the network. I'm like, I like this. But I'm the one, I pitched the idea. Let's do this community. Casey's like, all in, let's do it. And those first years was crazy because there was so much momentum. I didn't want to lose the momentum. So I was like, like we could make a website from scratch because that'd be handmade. But it's gonna take forever. So I remember like I got my team members at the time, Jeroen and Chrono Dragon, like, yeah, let's use Django. And like, let's use big frameworks. You know what? It's okay. Because we want a website up and running to capture momentum, to capture people. And then we can replace and improve the website, make it more handmade over time, thanks to you.
Yeah, let me tell you, Asif and I love the Django site. We love writing Python. We love doing all this and that. And we loved it so much that we rewrote the entire site a few years ago.
I'm so sorry. Twitter was I'm no longer on Twitter, by the way, but like when I was on Twitter, like that was also really important to get the word out there. And I always made sure we captured our own place for it though, like website, newsletter, like don't just stay on social media, let's have our own home. Let's have our own home.
Actually, can you put up, I think we have a slide that shows like a screenshot from the early days of the network. I think there's something like that, just to give people a,
oh my God.
Well, there are these, we'll get there. We'll get there. But yeah, just a taste from the Internet Archive of some of the early content on the website, showing the kinds of things that used to be present there.
Yes.
Because this is what I found when I joined the community, was these forums and these projects. You know, there's a projects link at the top that would take you to things like Handmade Hero and Essence, and there were so many early projects. A lot of them.
Milton,
yeah, absolutely. There were so many of those projects that were around from the early days that had a home here on the Handmade Network website.
Yep.
And I mean, how shocking is it to join this programming community and find operating system from scratch? It's, Essence is still one of those things that blew my mind, still blows my mind, how much Noxt was able to do.
On his own.
Yeah.
On his own.
I mean, it's incredible.
That's another thing. Although I encourage people to work together in groups and to collaborate on projects, there's a lot of like indie people. It's like, I just made my own thing from scratch and it's better than what's out there. It's better than what I see in the competition. Like, it's just crazy. Like, same thing with editors, same thing with, one example that I want to think about here is when the network started to flesh out, right? And we started to get a lot more momentum and a lot more people. There was this sense that we were attacked by saying, like, don't reinvent the wheel. Like, if you look at outside of Handmade, people are saying, you guys are just reinventing the wheel. You're never going to make a better Photoshop. You're never going to make a better text editor. You're never going to make a better operating system. Operating systems takes billions of dollars in Microsoft. How do you think you can do it on your own? Like, there's no way. Like, so much of that has happened. Recently, though, we had, once the conferences started, right, we had a demo of another operating system, not just Essence. There's another one called Serenity OS. I'm kind of curious if people here know about Serenity OS. Please raise your hand. Look at that. Look at the audience. I love that. Serenity OS demoed at the conference right here. And #1 on Hacker News, right? Just like blew up for like 2 days. And his project on the operating system, there was one called Ladybird, which is a browser. So he also wrote his own browser with his community, and it just got a $1 million funding round from like a GitHub co-founder. GitHub co-founder said, I love Ladybird, I love that you built everything from scratch, you know, I love that you demoed this at the conference, and like, let's make a nonprofit for this, and I'll donate the first $1 million, and like, we have more examples like that, by the way. Like, even though Handmade might feel like a small community sometimes, when you compare it to like GDC or like whatever, like lots of important things are happening. And I don't know when you're ready to talk about those pictures, but
we'll get to the pictures.
Okay.
I just wanted to linger a little bit on that because it is so amazing what programmers can accomplish when they aren't afraid to reinvent the wheel, when they believe that mere mortals created all of these things that we depend on, and that mere mortals can make new ones again. You see these operating systems being created, or browsers being created, or editors, or languages being created, or drawing tools, or literally anything, right? All of these things that people assume must be outside of the realm of normal expertise, you know, impossible to attain, and they're just not. I see it every single time we put on a jam, every single time someone new comes into the community with one of these projects. It's just absolutely amazing. And it's been so inspiring for me. And like, you know, how could I not get involved in a community where people are so enthusiastic and so fearless about building these things?
Sometimes bearing ridicule and mockery. That happens outside of the community too. It's like, what the fuck are you doing? Like what? Yeah.
Well, we host a wheel reinvention jam now, so we embrace and we own that.
You literally call it Wheel Reinvention Jam.
Yep,
I love that.
And we're going to stick with the name because like we want people to reinvent the wheel. We want people to be encouraged to take these things on. How else are we supposed to get improvements on the status quo if people aren't willing to reinvent the wheel?
I love that. I want to ask you a question now, because you asked me some interesting personal stuff. When you joined the Handmade Network and you became kind of like a lead eventually, like what was your desire there, your thought process to make things more active and engage more people, right? Because there was a time when I did leave the network. You know, there's a little bit of a history here where I did leave the network to work under Jonathan Blow. Yep. For example, I did work on Jonathan, and that took a lot of my time and energy. I couldn't.
No, Abner gave us a Django site and peaced out.
That's the entirety of my contribution.
No. Obviously, there's so much more to it than that. But at the time that I joined the community, I wasn't necessarily like thinking about getting involved in leading it. I was just really thirsty for knowledge and for experience and to grow.
So you were like any other community member, right? Just like
the way that I actually got involved, if you recall, was the old education initiative that you and the previous admin team were trying to run, and I signed up to be a beta tester. And then,
but education is hard, right?
It's really hard, and now I
was way in over my head to try and educate people about anything when it came to courses.
Yeah, and then I did the exact same thing. Later, we had our own education initiative later that fizzled in a similar way. It is really hard to do any kind of structured educational initiative, but that is how I got into the community. Was just trying to learn more and just trying to get involved in building up those initiatives for learning. And after then, you handed ownership of the site off to Ryan and Asaf and myself. Ownership of the community, right? Because Ryan was made the lead. It took us some time to find our footing, for sure. You know, we were given a remarkably large and active community, and I at least felt quite new to it and was just sort of trying to contribute to, I'll help with the website and I'll try to make sure that things keep running. But it definitely took us some time. We actually, in those years when the previous admin team went to work on other things, Abner going to work for Jonathan Blow and so on, there were a couple of years that I refer to as the handmade dark ages, just because the Discord, the community tone of discussion was kind of deteriorating. There was a fracture between the things that you saw on the website and the discussion that you saw on the Discord. There was a lot of, we were sort of in a moderation spiral where we were frustrated with a lot of the content, which, to be fair, we had a politics channel on the Discord at the time, so that was probably part of our problem. But
Yeah.
there was politics, philosophy, religion. Like, I don't know. I think you must have created these things for Ginger Bill back in the day, and then we were left.
Hi, Ginger. I know you're in the chat.
we were left to moderate this, but what eventually turned it around was we started talking with a lot of the people who had been around since the beginning, and getting a sense of what mattered most to them, and getting ideas from them about what to do in the future. And we started doing these fishbowl conversations. We started doing the Handmade Network podcast. Ryan did an amazing job hosting that. We started deliberately sort of feeding back into the community the kinds of things that we wanted to see. That's when we started doing jams. That's when we started doing these other initiatives. And it has made such a difference, just because one of the things that I've learned about leading this community over the years is that you don't have to do very much as the leader of a community to bring out the best in people. You just have to provide them an opportunity to speak, an opportunity to show off their work. And so many incredible people come out of nowhere. Every time we do a jam, I'm introduced to so many new people who say, hello, I've been lurking for 2 or 3 years, never said anything.
That
but here's
happens
this
all the
incredible
time.
project.
Yeah.
And
yeah, we have lurkers here too. I know.
yeah.
Yes.
But, at this point, the jams are my favorite thing that we do, just because of how it brings out the best in people. All you have to do is give them a little bit of a prompt, and you get this amazing result. I think that's what you did early on with the projects on the network. You gave people an opportunity to share their work, and Casey gave people the motivation to go build their own thing in whatever domain it was. And it led to this flourishing. And so now, as the lead of the community, I want to just continue doing that, keep fostering that creativity, keep giving people a voice, keep giving people a platform to share what they're working on, share their knowledge with each other, and do this amazing work that we think is going to change the software industry.
I gotta wonder why by the way, beautifully said. I gotta wonder why there's so many lurkers. I try to be so kind and so welcoming. At a Handmade meetup this year, I'm like hanging out with people, and I'm talking to them about stories about, like I said, I'm very blunt, and I don't have any sponsors, so I can say whatever. So I'm at a meetup being like, fuck Uber, fuck Lyft, and like startups, and like this and that, and like they're harming society, VC funded capital, right? And then at the end, somebody was questioning me about, do you know what the CEO did here? And I'm like, oh, of course I do. Like and I'm just like talking, and this guy's questioning me, right? Like just having drinks after the meetup, questioning me about how much I know about startups and the damage they're doing that I think they're doing to society sometimes, often. And he goes like, you know what, Abner? You're at the very end when I'm done ranting, like, you're right. I'm a founding engineer for Uber. I'm like, and you kept that quiet? Like, all the way on the presentations, coffee, meetup, drinks, at the very, very end, that's when you say that. And same thing, people were asking me, because I wrote my own Ticketmaster, by the way, replacement for the conferences. You guys don't ever have to be spied on by Ticketmaster or Eventbrite when you come to this conference. Like, I wrote my own damn software for that. And this guy's asking me all these questions about my Stripe integrations and PayPal integrations, and I questioning my knowledge of programming. At the very end, he said, by the way, I'm an early Stripe employee, and I think what you're doing is awesome. I'm like, guys, don't bury the lead. So I'm just saying, even people high up are lurkers, and like they're shy. I hope you feel comfortable with, as you can. The way we're comfortable, I hope you feel comfortable. And today, because you've weathered, like I said, you've weathered this storm. Take advantage of socializing, okay? I want you to break open your shell. I think a lot of what happens with software quality going down a cliff is that the people in charge are often not programmers themselves. Or they put programmers in like silos and corporations, like, it's like you're kind of like separated out, and then you're not out, and you might be shy yourself, which I completely understand. It can be hard to put yourself out there. I completely get it. I love machines just as much as humans, and I think machines are easier to deal with, right? But the more we do this, the more we do conferences, the more we do meetups, the more we do this, I do think all of a sudden managers, high ups, executives, like they have to listen to us, because we're now collectively kind of like talking about how bad things are, and we start to speak up in numbers, in greater numbers, and then think like, revolution. I'm sorry. Yeah, continue. Sorry, Ben. That was the meander.
Let's start talking about the fish pictures and so on.
Oh no. Okay. But where's the first fish picture? Oh my God. Okay, you cooked that, so we caught a fish. This was this year, by the way. This is the title of this presentation is The Next 10 Years. So we want to talk about what we're going to do for Handmade for you guys for the next 10 years.
Yes.
And I visited your cabin,
Yep.
your family cabin, this summer. Yes.
Yeah, so Abner and I got together this summer, as we've done for a couple years now, to have a little leadership summit to discuss what we want to do with the handmade community and what direction we want it to go in, and what we can do to encourage it over the next, and in this case, over the next 10 years, right? We knew as we were going into this conference season that it was the 10-year anniversary of Handmade. We knew that we wanted to do something special. And let's see, go to the slide with the boat, because we went on a boat ride, which was very, well, yes, he caught that. That was, we ate that one too. It's all great.
Yeah.
Next slide.
It was my first time ever catching a fish.
I can see it
by the
over
way.
here.
I was terrified.
So, highly recommend boats as a way of fostering ideas. So, as we go into the next 10 years of Handmade, we want to take everything that's been built up so far, this community of programmers who are doing such amazing work. What we've never really achieved so far is the impact on the software industry that we've wanted to make from the beginning. I mean, I remember, from the very first days that I came in to that I saw the manifesto and that I saw what you were talking about, and there's this goal of changing the way that software is made fundamentally. And we've done an amazing job as this community, I think, building up individual programmers, building up expertise, building these projects that, to me, feel like sort of proofs of concept of where software can go.
And there's a hunger for it too.
There is.
There's a hunger. Like last year, one of the demos that we're gonna see some demos this year as well. I promise. We're gonna have talks and demos. There's gonna be, last year there was this one about a file explorer. Mm-hmm. Somebody wrote a file explorer for Windows. Some of you guys have seen it, right? You've seen a file explorer. I'm gonna keep it quiet. You guys are gonna see the situation later. And last year, it got the most applause in this conference. The most applause and the most enthusiasm. I was like, a file explorer, huh?
It's the most mundane sounding thing you could possibly imagine. And yet it's the most electrifying piece of software that's been demoed at this conference, maybe ever. And it's astonishing, there is that hunger for better software, for software that responds as fast as we know computers actually can.
Yep.
And especially because it exposes what our computers are actually capable of. When you see even one program like that, it blows you away because it makes you realize, hold on, my computer was capable of this? My computer wasn't just that slow, actually, it's actually this fast? What's wrong with all the other software?
The creator joins me on a podcast. That's the treat for the online track. The podcast is going to be just with him, this creator, and I'm going to dive deep into how he made the File Explorer. And it's interesting that he mentions he's basically a protege or student of Handmade. He's just he went through the ringer, right? But he feels a little lost sometimes. I'm sorry for putting you out there like that, but he might feel a little not lost. He's just the idea of marketing. The idea of business, the idea of having to put yourself out there. He loves programming. I'm not sure how much he loves everything else in order to succeed.
Yeah. Well, if you want to go the route of actually selling your software and making a living off it, there's so much more involved than just programming. And that makes it really hard. We've seen a lot of great projects that get a small following and get a few sales, but don't really take off the way that you'd like it to. And we really want that to change, right? We want more programmers and more handmade projects to be able to succeed. So can I announce now what it is that we're doing? So the big milestone that we are excited to publicly unveil finally, we've talked about it with a few people, and it's been in the works for a remarkably long time now at this point. We officially are starting a nonprofit 501c6 called the Handmade Software Foundation. And our mission is to boost handmade software, boost handmade programmers, not just the projects that they create, and to start putting real resources toward making a difference in the software industry. And Abner and I have been discussing this for a while. You wanted, I believe, to talk about the sort of archetypes of programmers that we're trying to support. Yeah. And it's something that I think we truly couldn't do without this 10 years of hindsight on the handmade community.
Yeah.
And on all the different kinds of programmers that we have. The thing that makes Handmade so interesting as a community to me is that it isn't centered around a specific technology, and yet it still has a really strong mission. Most communities are built around a programming language or a game engine or some library or some tool. And there's lots of wonderful programmers in those communities, but Handmade is unique in that it doesn't have any central technology. But I think that sets us up well then to make a nonprofit organization that can really support a wider variety of programmers and really tackle the software industry at large more than just a specific niche, whether that was game development or tool development or operating system development and so on.
Yes, and for example, helping with marketing would also be interesting, and with website design. Like, for example, the guy who made the File Explorer, just by being in this conference, there's a little bit of marketing there. Like, he only had 100 newsletter signups when he had the File Explorer demo. After it came on the conference, he went to 5,000 signups, and now he's doubled it. So like he has over 10,000 like non-spammy real people kind of like waiting for him to ship this File Explorer. And that's like with minimal work. Imagine if we had a nonprofit with support for him, with like, let's market, let's help you out with branding, let's help you out with promotion, let's help you out with licensing key. Oh my God, I can't imagine selling software has to be rough with the licensing keys and servers and all of that stuff. So it sounds like you want to be able to support with all those kinds of things.
Yeah, so Vyacheslav the creator, are we really just not going to name, are we waiting for the podcast?
We should name his name, yeah. Vyacheslav, hello Vyacheslav, yes. He's going to be at the podcast.
There's a rebrand happening, which is why we're being dodgy about the name.
Yeah, he's so, rebranded, yeah.
Anyway, but Vyacheslav, the creator of apparently unnamed tool, is the perfect example of what we consider the entrepreneurs in the Handmade community. Yeah. These programmers who want to put out a tangible product into the world, a real piece of software that people can download and use. Maybe not all of them will be paid, maybe some of them will be free, but even so, it's like a real artifact that they want to create and publish that is faster, that is better than anything else that's out there.
Yeah, and just to clarify, when we were at the cabin this year, we were like I'm looking back at 10 years worth of people on the community, on the Discord, on the emails, on the conferences, like what kind of buckets do programmers tend to fall into? It's not like we're trying to box you in or anything, obviously, but like we're thinking, and one archetype was the entrepreneur, people who was like, I want to build my own software project from scratch, and I want to sell it. I want to make money. I make my own software shop. Yeah. I'll be kind of curious later. I'm going to get a show of hands at anybody who's an entrepreneur, but
yeah. Well, and that was originally when we started nonprofit discussions. That was really the main type of programmer that we were thinking about supporting.
Yes.
But as we've developed it and as we've looked back on the past decade, there are a couple other archetypes of programmer that we think are really important to support too. Another one is what we call the researcher. There are people in the community who aren't necessarily as interested in shipping a tangible product, but they are interested in diving really, really low level on any particular topic, in learning how systems
Hi, Negate.
work.
Hello, yeah, sir. Yeah.
People like Negate, people like Alan Webster, people like Martin Fiel, who maybe straddles some of the boundaries of entrepreneur and researcher. But these are people who, they're not necessarily looking to sell a product, but they are often changing the way that we think about programming and exposing new possibilities to us, and they need support as well.
So that's entrepreneur, that's one bucket. We have three archetypes: entrepreneur, researcher, craftspeople. So those who love the craft. And I think there's one guy here. There's many of you, but I'm just off the top of my head, like Ruben. Can you raise your hand, Ruben? Are you in the? Hey, so Ruben works with Martin on Orca, and as far as I know, you're not that in love with the limelight or the spotlight, but you love to contribute. You care about just the process of helping make a project succeed. You love the craft, and that's all you care about. We'd love to still support craftspeople in whatever way we can as well. Like, what are some of those ways?
The craftspeople in the community are often the ones who contribute the most tangible, direct work to so many different projects.
Yes.
There are so many people involved in the Odin project, for example, the Odin programming language. There's so many people contributing to Orca who are testing out the different APIs and systems that we're building, or people like Ruben working on the build system and the libc implementation and all of this really critical work. And they do it to such an incredible level of competence and quality. We have some incredible systems programmers in the community, and we want to make sure that they have a home too, even if they're not interested in playing the marketing game and selling a product and that sort of thing.
Yes, and I want to say that this journey to make this nonprofit, because in the future, long term, we'd love to have, we're going to have funding and ways to support you directly, like, maybe a craftsperson who we trust is like doing really good work. It's like, if we have the way to support you, like whether it's funding or like whatever it might be, like we want to be able to do that eventually. We also want to be able to, like I said, say, like you did this for me, for example. I was the first customer of this nonprofit, I suppose, like for the conference. My website, how many of you know that my old website was a clunky, old as fuck, brittle WordPress? I'm so sorry, those who are raising their hands, because I am not a website designer, so I just went with WordPress. But it's like a handmade conference with a WordPress site that is too slow to load. You're waiting 10 seconds to create an image. So this year,
I still don't understand how your server was that slow. I've never been able to figure it out.
We'll do a postmortem. We have to do a postmortem on that.
Yeah. We'll boot up the WordPress site again, we'll profile it, and we'll figure out what on earth was actually happening there.
But if the audience goes to handmadecities.com right now, beautiful website. Which, by the way, we're finally getting, after 10 years, we're getting some interesting non-programmers in the community. Like we had Jess, who couldn't be with us today again, whether it's weather or the work or the economy. But like Jess helped, she's a UI UX designer. And she did the logos for the new website. She did the website redesign, everything. And yeah, like, for example, that's the new logo, for example. Yeah, applause for...
Yeah. Jess is amazing. She also contributed the design for the new Handmade Network site, which it's so much better in every way. And like, it's not
because it's not programmer art.
Not just for visual design, but also for the organization of the site and the information that we prioritize. That designer perspective has been so valuable.
Yes.
I'm very glad to have worked with her.
And she said the reason she came to Handmade was because, for Handmade Boston, I had a speaker, Freya Homer, who's also going to be presenting tomorrow, one of the demos. She's like, oh, Freya's there. I love Freya. And like, Freya's also a more artistic-oriented person, she calls herself, I believe it's the perfect title, shader sorceress. She knows all about building beautiful things with shaders and math as well. And Jess came in for that. So like, thanks to Freya and Jess, like we have a much more handmade software is getting sexier and handmade websites are getting sexier. So I love that. Sorry for kind of cut you off there, but I was mentioning this because it wasn't just the design and the new logos. You and your nonprofit, so to speak, helped me build out the website, like with Asaf's help, for example. So I would imagine that you want to do that for other people in the community with the nonprofit in the future. Be like,
yes,
if you're making an awesome software and you hate websites, come talk to Ben, kind of thing, right?
Right. So with these three archetypes that we want to support, the entrepreneur and the researcher and the craftsperson, entrepreneurs, we think, just need a lot of tangible support with sort of putting their product out into the world. Just because you have incredible technical expertise on building a file explorer or building an operating system, that doesn't necessarily mean that you have expertise in web development or that you even want to spend your time putting together like the payment system and the licensing system and so on. And all these projects might have different needs, but we think that we can come alongside them and provide that support. And the key thing that we want to differentiate ourselves from other services is that the owner of the project always gets to stay in control. We want to develop for them the kind of software that they are comfortable working with themselves. Yeah. That if in the future they wanted to go off on their own and hire their own people and run it all themselves, they can just sort of take the code and run, and that'll be absolutely fine. We don't want to lock anyone in. We want to support them, because one of the interesting paradoxes of trying to build a foundation to support handmade programmers is this handmade value of self-sufficiency is often at odds, at least in people's minds, with having other people do this work for you, right? It's like, how can I be confident in my own website, my own payment system, if I don't write it myself? I need to know how that works. But we still think that we can provide that expertise directly, and we're not locking you in, right? Nope. We will make it as simple and high quality as we know how, and we will give you all the tools you need to run it. We won't have any insane technical dependencies and lock-ins, so you can just like take it and put the files or put the binary on your own server and run it, and that's just fine.
All the contributions you and your nonprofit team did for me, for my website redesign, it all happened on my server. Like you did it there, and like, I never felt like you were overbearing or anything like that. You just want to move us along. Yeah, for sure.
So there are many things beyond websites. It is something that Asaf and I, in particular, have some direct experience with, and obviously with people like Jess on board, the design aspect of it also lends itself well to web design and to marketing and so on. But it goes beyond that for if you look at how we want to support researchers too. Researchers don't necessarily need the marketing because they're not trying to sell a product, but we think we can still support them in their work by giving them resources, giving them publicity, right? Researchers need to have their work actually published into the world. And we think that a lot of the time they could use some help with sort of the message and the angle that they take on something, right? How can we take this research and make it compelling to a general audience, make it compelling to the rest of the software industry, help them see the potential in this work? And ultimately, we would like them to attract more funding from other sources, whether that's grants or whether that's individual donations.
Yes.
Just because you spend all your time doing research, again, doesn't mean that you want to spend all your time seeking out grants or
right. We're interested in the funding
work.
equation too. We want to help with that funding because I know that's really hard, especially for programmers who again don't want to deal with all the morass of salespeople. I always say that a lot of me running this conference is just being on the phone. I'm sorry to say, with boomer salesmen, like trying to make sure that everything is. I can afford everything that I can do, or I can get the money, or whatever. Like that happens with programmers too. It's like I need to find grants, I need to find funding, I need help, and I don't want to deal with all this telephone games or things like that. That's where the nonprofit could come in. And I also hope one of your first clients is Negate. So, because this is a young man, Negate, who is literally trying to replace LLVM. It's legit. Like this guy's so. Some of you have met him at the co-working sessions, and like you hear him talk like he's just barely started his 20s, and it's like, whoa. It's like you're awesome, right? But it's all buried in like long threads on Discord in a hidden channel. Like it's like, we want to be, I hope he's one of your clients so we can put him out there more.
I hope so too. We'll have to talk with a lot of people and figure out what resources we have. But yes, of course, he was high on the list of people that we wanted the foundation to be able to support when we were brainstorming on the boat up at the cabin.
What's your timeline for this? Because I know that you've been talking to lawyers. We're dead serious about this stuff. You've been talking to lawyers to form this nonprofit. Even you got rejected at the first time, and part of it because I believe
there's a funny history there, a painfully long history. We started trying to put this together in 2022, and we submitted our 501c3 application in early 2023. And then it took the IRS an entire year to reject our application for a 501c3.
And you were still paying lawyers throughout the process.
And we had to go back to the drawing board. But it turns out it's really good that we did. We had to alter our vision and our mission for the nonprofit quite a lot in order to fit the requirements of a 501c3. And I mentioned earlier when I announced it that we're doing a 501c6 this time, which turns out to be actually a much better fit, but one that we weren't aware of at the time because we were following in the footsteps of the Zig Software Foundation, for example, these other software 501c3s.
I heard a lot of rumors that what happened is that OpenAI in some degree has poisoned the waters for new software-based 501c3s.
Who can blame the IRS in this case? Because you honestly, you look at so much of what the software 501c3s in the world do, and you look at their donors, and you see these large, these huge tech giants paying tens of thousands of dollars to these nonprofits to develop software that's mission critical for their business. And that's charitable.
That's for the public benefit. That's for the public good.
I don't blame the IRS for thinking that perhaps a tech giant paying for critical business software is not actually a charity.
With an exclusive license for like a new model.
And it is a shame because there are aspects of it that we do think fit the model of charitable, scientific, educational, but the 501c6 designation is explicitly business focused. And with our mission of trying to impact the software
industry, you can actually support commercial projects and like indie devs.
We want to impact the software industry. It is sort of a business a business thing. Yeah. We want to be able to do that directly. So in the end, it ended up working out well, and we are able to pursue really much more of the original vision, and we've gotten a better perspective of what we want the nonprofit to support beyond just business since we started it.
I'm grateful that, so we're just about to start with our first speaker for the day, but just before I let you go, I want to know what the timeline is so far.
Yeah.
So I know you had to go through
The
this.
timeline is that we have officially submitted for the 501c6 designation to the IRS. We don't know how long it will take. Hopefully it'll be relatively quick. We are probably going to ramp up our foundation efforts in early 2025. Even if the 501c6 designation hasn't come in yet, that doesn't mean we can't start doing these activities right away. And we're really excited to get that going. We're planning to run it something like a Patreon. There will be different tiers that people can contribute to, and we want to, we'll have a small portfolio to start of projects that we support, and we'll be working out with those project authors what that actually looks like, what the best ways are. We have a little bit of a framework, but the details will be worked out soon. But we just recently got that 501c6 application put in, and if you want to hear more about it, you can subscribe to the Handmade Network newsletter. And if you go to handmade.network, I just this morning published a news post co-authored with Abner about all the things that we've talked about today, and talking in more detail about what we want this foundation to do. And there's a newsletter sign-up link there. You can find that if you're interested. We're really, really excited to get this going because we really want to make that serious difference in the software industry. And it's going to take real resources to do it. But with the 10 years of expertise and of understanding and of community that we've built up, we think that we're finally in a really good position to actually start putting real resources toward this challenge.
100%. And so you guys have two tasks that I'm going to give you if you're so inclined. If you feel that I feel like I'm an entrepreneur or a researcher or a craftsperson, I love working on handmade things. I'd love some support in the future. I'd love some whatever the nonprofit might do in lines of marketing support, website support, design support, funding support, all of these things, right? Think about it. And then show your support by going to handmade.network. You have the latest newsletter talking about this. And you can subscribe to that newsletter. That's the best way. The newsletter is the best way to find out news of what's next, right?
Absolutely.
And you're also on the chat server.
Yes. Anybody here can talk to me at any time about this. I'm really excited to finally be able to talk freely and publicly about it, instead of just these little tastes that I've been giving people in voice calls or other prior
You're taking this very
things.
seriously. I've seen you throughout the very beginning, through the rejections, paying lawyers, trying to submit it again, and you've made it, basically.
Yeah,
and
we're really committed to making this happen, and I'm more excited than ever about the possibilities that we have, and really excited to see the real action on this initiative that we've talked about for so long.
Please harass Ben on the chat server at
Absolutely.
bbusiness, okay?
bbusiness.
At bbusiness. Send him a friend request, send him a DM, like, I want to be part of the foundation, or I want to help, or I want to be a client, or like whatever it might be. Start doing it now, because not first come, first serve.
No, that's not how it's going to work.
Sorry. But yeah, reach out. A round of applause for Ben here. That was so much fun. Oh, hug. Okay, so as Andrew Kelley sits down on the front row closer before I call him out, I want to mention here that this is going to be our first speaker for the conference. And I appreciate you guys, especially newcomers who've never heard of Handmade before. Thank you for joining us in this little inside baseball kind of like story. If you ever do need the bathroom, please make sure that the door opens quietly so you can go to the bathroom and then come back. We have a water fountain as well. It's going to be to your right, the bathroom and stuff like that. Okay. So yes, the creator of the Zig programming language, also a close friend. I can actually say I visit him every so often at his house in Portland. I take the Amtrak, it's a great time. And Andrew Kelley is, I call him also senpai, because you're farther along, only probably a couple of years older than me, that's it, who is running his own organization, is the president of his own organization. I'm running my own business here, so I always get a lot of advice from him about handmade stuff. And what he's done with Zig, this programming language, is just staggering. How many of you here use Zig as a language, for projects and for work and things like that? Look at that. A lot of people. That's awesome. And Andrew's given famous talks here before, like the practical data-oriented design. It's a good talk. I would love it if somebody on the chat server can maybe link to that talk, practical data-oriented design, so you can see that. And yeah, and now he's coming back. It's called, the title of his talk, In Defense of the Free Software Movement. And I know that you also talk about a little bit, I'm not going to spoil it too much, but you do talk about the Handmade Manifesto as well. I would love it if also in the chat anybody can link to the Handmade Manifesto. That is the rallying call for this community, how much we care about software quality, right? We have it written down in the manifesto. And you have some hot takes on everything. You have some hot takes on everything. And I don't care what you say. I trust that this is an indie conference and we can be spicy and we can have fun. I really want people here to be ruthlessly scrutinizing engineering, ruthlessly scrutinizing software, offering strong opinions, honest opinions, as long as you always at the same time respect the people next to you. You know what I mean? Be like, here's an example. Fuck Linus. Versus, oh, Linux kind of, I don't like Linux. I think it sucks. And here's all these reasons, right? You attacked a person or you attacked a project. You know what I mean? See what I mean? Okay, so with all those hot takes, by the way, we're gonna have fun. This is gonna be awesome. I hope I primed you up to listen to this interesting conversation with Andrew Kelley, the creator of the Zig programming language. Round of applause. A little refresher, so those are the slides right there. There's your notes.
Oh, this is just the clicker, and now you hold this?
Exactly.
Okay.
Big,
Yeah.
green button.
I remember
you
now.
can also use this if you want to.
Okay, we're good. Thanks, Abner. Well, hello, everyone. Welcome to my talk. My name is Andrew Kelley, and this is In Defense of the Free Software Movement. I fucking love computers. I fucking love them. Who has the self-confidence to raise their hand and admit that they also love computers? Okay, that's almost everyone. Pretty good. But shy people, it's okay. You can relax. We got enough people with energy here that you can just chill. It's all good. I know you love computers, though. You can't tell me you bought a $300 ticket and dragged your ass to Seattle out of spite for computers. Personally, I've been obsessed with computers since I was 12. Well, that's just when I started programming. I think maybe the obsession started the first time I stomped my first Goomba at an older kid's house on his Nintendo Entertainment System. I think an average of 4 hours per day programming or studying related materials is a conservative estimate for my lifetime. Doing the math, that comes out to 25% of my waking hours, effectively building a shrine to the concept of computing. And I don't think I'm alone. Is anyone else willing to say that an average of 4 hours per day programming over your entire life is a fair lower bound estimate for you? Okay, I mean, that's like 24 people. But why? Why would you do that? That's an insane amount of life to give up. What could possibly be worth such an enormous amount of our precious time on Earth? Think of all the other things we could have spent our time doing. Exploring nature, traveling, skateboarding, Nihongo o benkyou shiteru, making music, playing games, baking, just relaxing and enjoying life. But yet, here we are, 100 sweaty introverts concentrated in a stuffy theater, trying to hone our craft even more. We're virtual monks living in a digital monastery. Like, what is so damn compelling about computers? I think I know the answer. We sense the unlimited potential value that computers represent. Think back to the first time in your life you watched a computer execute your own code that you just wrote. In that magical moment, we realized that we could have typed anything in that text box, and full comprehension of Turing completeness just surged through our entire body like a bolt of lightning. For most of human history, the law of conservation of energy governed our society. One person spends the effort to make one sandwich. That was a sandwich emoji on my computer. And one person gets to eat that sandwich. But the Industrial Revolution changed the equation. It brought us sandwich factories, and now one worker can operate a sandwich machine while 10 people get to eat the sandwiches. That's already pretty sweet, but the digital revolution takes things to the next level. One person makes a digital sandwich, and everyone on the fucking planet can have a copy for such an insignificant cost, it may as well be free. When the Motion Picture Association of America found out about this, they freaked out. and immediately began a propaganda campaign to convince everyone that calling memcopy is equivalent to Grand Theft Auto. And if you forgot, I got a little reel for you. Anyone remember this? Phil's got my back. And with that ad, everyone who had never tried pirating tried it that same day. But really, it's eerily similar to the motor vehicles industry's wildly successful propaganda campaign to convince pedestrians to surrender dominion of the streets to 3,000-pound rolling death machines. Oh, you didn't know? Look up this article called The Forgotten History of How Automakers Invented the Crime of Jaywalking. But I digress. My point is, computers are inherently naughty. They break the rules. You write the code once, and then the machine operates indefinitely, producing wealth limited only by the imagination, while consuming nearly zero resources. It's the perfect machine. We know this intuitively, and like the hippies before us, we seek to harness this power for the good of humanity by writing applications that delight users with snappy performance and robust logic. Unfortunately, MBA grads have now caught wind of the smell of cash. Our founding hippies subscribed to ideologies like this. Access to computers should be unlimited and total. All information should be free. Mistrust authority, promote decentralization. You can create art and beauty on a computer. Computers can change your life for the better. Lately, it's more like this. It should be illegal to repair your own devices. Walled gardens. Log into Facebook to see your friends' party details. And trust 99% of our IT to exactly 5 companies. You are a consumer. Slow and buggy software is a key frustration in your life. We see companies defending discrimination with the excuse that their own proprietary algorithm is too complex to understand. We get software updates shoved down our throats for what is obviously a marketing push. This is a TV, for Christ's sake. If I install this, I know things will either be the same or get worse. Oh, it's my lucky day today. Sorry I'm late to the meeting, everyone. I had to install the Discord update so I could look at this World of Warcraft ad. Excuse me? Is my SMS application commanding me to participate in Google's latest marketing campaign? We're being treated like fucking puppets. Get started or not now. These modal dialogue options only make sense in an abusive relationship. All right, how many people, show of hands, how many people have received a 500 internal server error when you click unsubscribe from a spam email? Do you see what's happening yet? I'm going to play a 3-minute segment from a George Carlin routine.
But there's a reason. There's a reason. There's a reason for this. There's a reason education sucks, and it's the same reason that it will never, ever, ever be fixed. It's never going to get any better. Don't look for it. Be happy with what you got. Because the owners of this country don't want that. I'm talking about the real owners now. The real owners, the big wealthy business interests that control things and make all the important decisions. Forget the politicians. The politicians are put there to give you the idea that you have freedom of choice. You don't. You have no choice. You have owners. They own you. They own everything. They own all the important land. They own and control the corporations. They've long since bought and paid for the Senate, the Congress, the state houses, the city halls. They got the judges in their back pockets. And they own all the big media companies, so they control just about all of the news and information you get to hear. They got you by the balls. They spend billions of dollars every year lobbying to get what they want. Well, we know what they want. They want more for themselves and less for everybody else. But I'll tell you what they don't want. They don't want a population of citizens capable of critical thinking. They don't want well-informed, well-educated people capable of critical thinking. They're not interested in that. That doesn't help them. That's against their interest. That's right. They don't want people who are smart enough to sit around the kitchen table and figure out how badly they're getting fucked by a system that threw them overboard 30 fucking years ago. They don't want that. You know what they want? They want obedient workers. Obedient workers. People who are just smart enough to run the machines and do the paperwork and just dumb enough to passively accept all these increasingly shittier jobs with the lower pay, the longer hours, the reduced benefits, the end of overtime, and the vanishing pension that disappears the minute you go to collect it. And now they're coming for your Social Security money. They want your fucking retirement money. They want it back so they can give it to their criminal friends on Wall Street. And you know something? They'll get it. They'll get it all from you sooner or later because they own this fucking place. It's a big club, and you ain't in it. You and I are not in the big club. And by the way, it's the same big club they used to beat you over the head with all day long when they tell you what to believe. All day long, beating you over the head in their media, telling you what to believe, what to think, and what to buy. The table is tilted, folks. The game is rigged. And nobody seems to notice. Nobody seems to care. Good, honest, hard-working people, white collar, blue collar, doesn't matter what color shirt you have on. Good, honest, hard-working people continue. These are people of modest means. Continue to elect these rich cocksuckers who don't give a fuck about them. They don't give a fuck about you. They don't give a fuck about you. They don't care about you at all. At all. At all. Yeah. You know? And nobody seems to notice, nobody seems to care. That's what the owners count on, the fact that Americans will probably remain willfully ignorant of the big red, white, and blue dick that's being jammed up their assholes every day. Because the owners of this country know the truth. It's called the American dream, because you have to be asleep to believe it.
Rest in peace. Well, I'll spell it out for you, and I'll tie this into computers. Humans are hoarders. Just like my grandpa hoards boxes of broken junk in his garage, humans hoard wealth. Machines create wealth. Like children who haven't yet learned to share, humans fight over the wealth coming out of the machine. We already know how this plays out. Raise your hand if you learned about the Ludlow massacre in the American school system, American public school system. Okay, I see 2 hands up. I don't blame you. I didn't either. What's important to understand is, 1, that our own military brutally massacred civilians for not going to work. And 2, this was not an isolated incident. The Wikipedia page for a list of worker deaths in United States labor disputes is 64 pages printed and, quote, does not include killings of enslaved persons. There's a scene from the Japanese anime Attack on Titan that I want to share with you. Pixies asks Erwin if there will ever be a time when humans will stop fighting one another. And he says, humans will continue to fight each other until the day that there's one human or less. Like George Carlin, Erwin understands the innate desire of humans to dominate and oppress. His hopeless rhetoric acknowledges mankind's unlimited thirst for wealth and power, our unwillingness to share resources, even to the point of self-destruction. But Pixies was not satisfied with that answer. I'll further translate this from Japanese for you. He said, fuck off with that black pill take. I'm here today to offer you a better answer. It doesn't have to be this way, because while we humans are subject to dark urges deep within our nature, we are also equipped with gigantic ass heads that made our mothers scream in agony during childbirth. And you know what's inside this gigantic ass heads that we have? That's right, gigantic ass brains. And we can use those gigantic ass brains to perform systems thinking. Something that we've been practicing our entire lives by worshiping computers. The Handmade Manifesto asks the question, why is software so terrible? It then offers an explanation, which I'll read to you. We made it terrible. We programmers have made it terrible through our thoughtless behavior. We rewrite our apps in new languages, and rather than measure anything, we just assume it would be better. We ship thousands of dependencies to our users to save ourselves a few minutes of effort. We build towers of abstractions, forget how they work, and then build new ones on top. This is all beautifully worded as well as true, but I think the why question needs to be asked a second time. Why are we not thinking about these things more? Why do we not take the time to measure anything? Why do we feel the desperate need to save even a few minutes of effort? Why do we build towers of abstractions and forget how they work? I know from personal experience that when I try to spend more time as an employee doing any of these handmade principles, I receive pushback to prioritize developer time over product quality. Please allow me to read the solution offered by our manifesto. You can break out of this cycle. You can learn how computers actually work so you can unleash the full potential of modern systems. You can dig deep into the tech stack and learn what others take for granted. When you run into a wall rather than stop, you can dig under it. This is our mission. You don't have to be a genius to make your software better. You just have to be willing to learn and willing to go against conventions. We're here to teach you, to inspire you, to help you break free from the mess of modern software development and make software the handmade way. Once again, I think this is on point. But my sweet, beautiful nerds, I have a news flash for you. All of these things are labor. My friends, we are a labor movement. You want to spend time learning how computers actually work? Great. Are you going to do that on the clock or moonlight it? You want to take the time to work on your tech stack instead of the latest superficial product gimmick that's coming down from your manager? How are you going to convince your boss to allocate dev time for it? Are you going to ask for forgiveness rather than permission? We enjoyed a few decades of being on the favorable end of the supply and demand scale, while the hippies slowly became wolves. This is the blue box designed and built by Steve Wozniak and sold by Steve Jobs before they founded Apple. Basically exploited a poorly designed phone signaling system, allowing you to make pirated calls. Pretty edgy and rebellious, huh? Now these guys are responsible for a monopolistic empire that enforces DRM, charges a 30% commission on digital sales, stifling innovation, and keeps as much of their OS closed source as they can get away with, despite being a fork of BSD. The modern economy has caught up with the newly emerged market of computer programming. Now the scale's flipped. We're seeing mass tech layoffs, and the bargaining power we had over our own labor is weakening. Oh, you work at CrowdStrike and you want to dig deep into the tech stack? You think it shouldn't be doing all this logic in kernel space? Fuck you. Rush our next marketing campaign out the door. Don't even bother doing basic QA to find out if it will cause mass outages in hospitals, banks, and airports. You disagree? Don't let the door hit your ass on the way out. And good luck finding healthcare insurance. By the way, in 2024, CrowdStrike's total revenue was $3.06 billion, a 36% increase, and it spent a good chunk of that money not only lobbying our government to avoid meaningful consequences for its disastrous shortcomings, but also to ensure that its ubiquity and profits will only increase in the coming years. The industry needs to change, and we're going to lead the way. Damn right, but we're not going to do it merely by coding harder. We're not going to do it by convincing our coworkers to spend their nights and weekends staring at a screen instead of spending time with their families. We're going to do it by using our big-ass brains to think critically about the system that is our global IT economy, exploiting weaknesses to favor the outcomes we desire, and creating incentives to reshape the industry in our image. In this talk, I have several concrete proposals to offer. I already hinted at the first one. We need to join forces with the other programmers in our companies and across companies, forming an agreement to follow a Handmade Manifesto-esque code of ethics, so that we can threaten to all stop doing the programming at the same time if the company tries to make us ship abusive crapware. Yeah, it's time to form labor unions. If we're lucky, we don't even have to go on strike. The mere existence of the union rebalances the negotiation power to the side of the workers. This is why we have such a bloody history of illegal union-busting practices. Business owners recognize that power and wealth are truly at stake, so much so that they're willing to gamble against the law. All right, that was part one. I'm gonna tie this into open source, and then in part three, we'll draw these strings together. So let's get into part two. I've been in, out, and around open source projects for as long as I can remember. I've been on every side of the spectrum. I've been unwilling to share my source. I've been a clueless user filing low-quality bug reports. I've been a clue-full user filing high-quality bug reports that nobody reads. An outside contributor trying to get more involved. A drive-by contributor, a forker, a forkee, an active creator, an inactive creator, a succeeding maintainer, an abdicating maintainer. I've sent contributions that went ignored for years until they bit rotted into obscurity. I've been annoyed by low-quality contributions and lazy questions on the issue tracker. I've been harassed, stalked, and trolled. I've seen it all. In this talk, I will make an appeal for why it's still worth it after all, But first, I want to offer a steelman representation of just how frustrating and soul-crushing open source software projects can be. This section will be interactive, so I'm about to cover all the problems that I can think of, but after that, I will call on you, the audience, for an airing of grievances. So start thinking about some gripes about dealing with open source projects. And if you can't think of one, maybe read someone's from the chat. All right, so getting started, I would say the biggest one is just dealing with the riffraff. First, there's just the people who fail to RTFM. You know, if the project were closed source, there would be no dealing with trivial questions that would have been answered if the beginner spent 5 minutes reading the documentation. Then there's the people who are talking shit on the internet. We've all heard the advice, don't read the comments. Like, really? You expect us to bust our asses on our project weeks and months on end, and then the one moment the project shines on our work, you think we don't want to milk our 15 minutes of fame? Get real. Finally, the people talking over each other on the issue tracker. Endless, pointless arguing about nothing that I'm never going to read. I already have a secret shadow ban list that exists only in my head. People who I automatically skip over everything they say, and everyone in these inane squabbles is already in it. The worst is people who are generally polite. They don't use mean language, and they never break the code of conduct. By contrast, I love the 4chan Nazis. Yeah. They arrive, they talk shit, I ban them instantly. Everyone moves on. Situation resolved. I got 99 problematic users, but a Coomer ain't one. It's true, the most difficult of all are people who genuinely mean well. They do their best, but ultimately they just make subpar contributions that suck up the project's efforts and fail to be merged. Personally, I take psychic damage when this happens because nobody wanted that outcome. Everyone's time is wasted, everyone feels crummy, and no lessons are learned. It's a real tragedy. Moving on, we have the premature debut. So naturally, game developers fear this one the most. Although modern practices such as early access are starting to challenge this belief, there's the sense that you only get one chance per player to evaluate your game, and it has to be perfect, or at least completed, before anyone sees it. All right, so here's a little exercise. Consider these two scenarios. Scenario A, scenario B. Show of hands, who thinks scenario A is better? Okay, yeah, I got some people, yeah. Scenario B? Oh, okay, everyone's in favor of B. Congratulations, your opinion is exactly as helpful to me as it would be if I replaced these with actual examples. Software is incremental. You have to code the features in a particular order. However, no matter which order you pick, people will judge the project for what's not done yet. Ultimately, this comes down to onlookers thinking that they know better than you what your own priorities should be for your own project. It's maddening. Mitchell Hashimoto, the creator of Ghosty terminal emulator. Does anyone use this? Private, yeah, okay, 1, 2, 3, 4, yeah, like a dozen. Anyway, he chose to keep this project in private beta for 2 years before transitioning to open source, which is scheduled for December 31st. He writes, my motivation for the extensive private beta testing was principally selfish. I had my first child, and I wanted to prioritize my time with my family over external pressures to build features or fix bugs. In theory, I could have ignored the noise, but in practice, I know myself well enough to know that I would have been distracted and it would have been mentally taxing. Fair enough. Moving on, we have thankless work. This is a screenshot from when I declared pull request bankruptcy on Zig. At this time, I was unable to keep up with all the contributions, and I closed a large number of them for no reason other than bit rot. This sucks for both parties. I feel like I'm doing thankless work because no matter how much I help people land their changes and then maintain that code forevermore, more contributions pile up in the queue. I just can't get on top of it. They feel like they're doing thankless work because they spend all that time making a patch and then it gets closed without even a quick glance. Not to mention all this work and nobody's even getting paid for it. Next up, we have quality. Pretty simple one. Has anyone ever been recommended to use a particular open source library or application, and then when you tried it, you found its interface offensive and its implementation appalling? Okay, that's like pretty much everyone. Next up, we have support. So with proprietary software, you can dial a call center, you can wait for hours on hold, get hung up on, wait another hour on hold, talk to someone who can barely understand, who knows next to nothing about the product. Oh, wait, never mind. I think open source actually wins this one. Okay, so before we move on, did anyone think of something that I didn't cover? Time is good. Yeah, raise your hand, speak succinctly, and I'll repeat your point into the mic. We could spend up to 5 minutes on this part if the audience has enough things to say. And if you can't think of something, maybe try to read something from chat. Yeah. Oh, that's a good one. Yeah. So not only doing a bunch of work and not getting paid, but then someone does get paid for your work, and it's a fucking corporation. Yeah, that's incredibly maddening. Yeah. Oh, fragmentation. Fragmentation. So yeah, you kind of get the paralysis of choice, and then you're worried that you might pick the lower quality one, or you pick the one that doesn't interop with the other ones. That's a good one. Yeah. Over here. Abandoned open source projects. It's actually working pretty well. It's solving your problem, but then it just can't continue. Yep, that's a good one. Yeah. In the middle over here. Hostile forks? Can you elaborate? Oh, yes, I'm a victim of that as well, actually. So, yeah, something where the license technically allows someone to fork it, close source it, start charging money, but it's still an asshole thing to do. Yeah, that's a good one. Over here.
Bringing constructive criticism or recommendations for improvement as a non-technical user and being told it's open source, just make it yourself.
Oh, that's a good one. Okay, so yeah, this one is you're trying to participate in the open source project. You don't have the programming skills, but you still care about the feature set or bugs, and you're told that you basically can't participate because you can only participate through programming.
On my microphone for LH1, thank you. We have one question from the chat, or one comment. Jay Calabro, open source projects that get relicensed.
Oh, relicensing. I'm gonna not talk about that one yet because I actually go over that later in the talk.
Okay, cool. Do you want to do a few more minutes, or are you done?
I can do 2 more.
Anybody?
Yeah, we're here in the middle.
Fixing compilation issues on everyone's combinatoric explosion.
Right, so yeah, the statement was fixing combinational explosion of compilation issues, which I'll interpret as, I don't know, user-based fragmentation, trying to support, as the project maintainer, you just have a lot of diverse users, and then it requires a lot of support to accomplish that. Yeah, that's a good one.
And we can do one more from chat, I think.
Sure, yeah.
Open source projects that decide they're not profiting enough from their work and change their license on the latest release. See Redis, Terraform.
Oh, that's part 3. Don't worry, we're gonna get there. Yeah. Okay, thank you for that participation.
Thank you, everyone.
That was exactly what I wanted. I appreciate that. Okay, so moving on. Now we'll go into part 3, and we'll get to those foreshadowed questions. This part is called the user agent. Is everyone familiar with this HTTP header? User agents? Yeah, okay. I hope the person who works at Mozilla is familiar with it. Do you know why it's called that? Rhetorical question. Because when this hippie coined the name in the 90s, he had a core belief that machine code running on a user's computer was obviously going to represent the interests of that user. In 2017, as W3C director, he went on to approve the encrypted media extensions proposal into the formal HTML specification, which makes web browsers partially closed source. The EME code in our browsers represents a small way in which we no longer own our own computers. While that code is executing, the MPA owns our computer. The key concept here is ownership. Everybody wants to be a landlord. Before 1776, Brits, sorry Matthew, sat on their fat asses collecting rent payments from American colonists 4,000 miles across the Atlantic Ocean. Before 1863, those same revolutionaries turned around and built an entire economy based on slave labor so they could sit at home and jerk off while black people broke their backs in the fields. Since then, human nature has not changed. We all have the desire within us to own something and collect income without earning it. This isn't the Marvel universe. It's not about heroes and villains. Brits are not evil, white people are not evil. There's no enemy to defeat that will grant us a happy ending. We all have exploitable lizard brains that will compulsively reach for power when it's offered to us. It is the system that needs to be attacked and reconfigured. Our strongest weapon is free and open source software. Without it, we have a system where the owner of the code is not the user of the code. The more we entrust our world to proprietary software, the more vulnerable we are to companies changing the terms of service to extract more and more value from us. We get unsolicited advertisements telling us to buy shit we don't need to fix problems we don't have. Prices go up, products are discontinued, family and friends are held hostage. Instead of software acting as the user's agent, the user becomes the company's agent, controlled by software they cannot access or modify. But free software has a few key mechanics that defend against these dark patterns. First, we have the fork. And this is the example that the chat was asking about. And I want to look at Redis for a recent example. So this project was originally created by Salvatore Sanfilippo, who released it under an open source license. Around 2018, he started to lose interest in the project to pursue a science fiction career and gave stewardship of the project to Redis Labs. In March of this year, the company went down the typical startup path of trying to squeeze more profits out while providing less value. Problem is, in order to do that, they needed to own the code running on other people's machines. So, in a widely unpopular and ultimately self-destructive move, they changed the license. Actual GitHub issue there. Now, some people get confused about what a license change means. Don't overthink it. It's really simple. There's no takesies backsies. All the code that already exists is and always will be available under the old license, which means you can fork it from just before the license change and it's business as usual. And that's exactly what happened. So there's two open source forks that are alive and well, Redict and Valkey. And if your company depended on Redis and you didn't switch to one of these two, your CTO is a dumbass and should be fired. However, even companies with dumbass CTOs benefit from the fork. You know why? Because free software projects create a low watermark, a baseline standard of quality. Due to the existence of these forks, Redis, the company, formerly Redis Labs, has no choice but to make a product offering that is at least as good as those open source alternatives. They're forced to compete on merits. They don't have the option to collect digital rent. Another example, there's a ton of money to be made in databases. Every company in the world needs at least one. So there's plenty of database companies trying to capture some of this immense market value. But they all compete on merits, and most of them are open source. Do you know why? Shout it out if you know why. One word, 4 syllables. PostgreSQL. All right. It's damn good. The watermark is really high on this one. And we have more examples. We have Linux, Blender, GCC, Clang. In all of these instances, the amount to which for-profit closed-source alternatives can trap users and milk them is limited by how good the free software offering is. This compiler one is particularly relevant to me. Let me ask you a rhetorical question. Do you think Jonathan Blow wants to give away his compiler for free? Do you think he wants to let you have the source code? Hello world, no. He wants to treat his language like a video game. But he can't. He can't charge money for his compiler, and he has to make the source code available. He probably won't even get away without an open source license. He knows that Jai is dead on arrival if he doesn't do these things, because they've become table stakes due to the existence of GCC, Clang, Rust, Zig, Odin, and all the other free and open source software development tools in between. We've raised the stakes for compiler toolchains so high that users will laugh you out of the room for trying to own the code that they run on their own machines. Now, some people will say this is a shame. As programmers, we want to get paid to write code. Writing and maintaining code is labor deserving of compensation, so what gives? I mean, I would categorize this as progress. What I find so inspiring about free software development is that we can build a magnificent Tower of Babel that reaches towards the heavens, and in doing so, become godlike. Working together, we can create interoperable components that prioritize the needs of end users, slowly saturating society with robust, high-performing user agents. Free software acts like a ratchet. Once it reaches a certain level of quality, it's difficult to claw back. But it does leave us with the problem of funding. How do we pay for free software development? And you know what I find ironic about this is that it's the same problem faced by the big media companies and their hatred of memcopy. Pirating doesn't directly harm anyone. The actual problem is it just costs money to fund the creation of music and movies. And until now, they've been using distribution of physical media as the method of accomplishing this. It's pretty comparable, actually. A typical movie budget might be $10 million, which would be roughly equivalent to a total comp for a team of 10 software engineers working on a project for 5 years. Anyway, while the MPA tries to legislate our rights away, let's brainstorm alternative ways to fund creativity that don't require demonizing people or the basic functionality of computers. First, we have the VC-funded startup. If you take investor money, they're going to want a return on that investment. So for a few years, it'll be peaceful, and you can spend that money wooing customers. But at some point, you'll have to reel them in like fish caught on a line. From a customer perspective, we should understand that all startups have an exit plan, which is basically their pump and dump scheme to get rich. But the neat thing about free software is that even under these harsh conditions, the fork and the low watermark can be used to spend VC money on software development while escaping with the free software intact as the startup folds. I'm sorry, my board of investors, your highnesses. We had to make our software free and open source because the other competitors in the space also do that, and now we can't change it, otherwise the community would fork. Got him. All right, next we have the privately owned business. For this one, let's play a game. I'll name the company, and you all shout out who it was bought by. Let's start with a warm-up. GitHub. Microsoft. All right. Shout-outs to Phil for using LibreOffice so I can get a GIF in there. Mojang. Also Microsoft. Don't worry, this isn't the bit you think it is. All right, next up, Bandcamp. Yeah, that's right, Epic Games. Next up, Rad Game Tools. Also Epic. Okay, how about Whole Foods? Amazon.com. Yeah, okay. Next up, Figma. Oh, trick question. Yeah, they agreed to be acquired by Adobe, but then they were blocked by anti-monopoly regulation. All right, next up, Wikipedia. Oh, wait, no, yeah, that's actually a nonprofit. Yeah, just kidding. If it's a nonprofit, and this goes for 501c6 as well, correct me if I'm wrong, Ben, that means it has no owners, only a mission statement. And Wikipedia is still great after all these years. Sometimes you have to scroll past a banner asking for donations, but that's totally harmless. All the great content's still there, and it never tries to sneak product placements into the encyclopedia pages. Oh, God. By contrast, what I hope I just demonstrated to you with our little game there is that a privately held company often starts out great, but there's always the temptation for the owner to sell. Maybe they get old and they want to retire. Maybe they need money for their kids to go to college. Maybe Microsoft just offers them a fucking insane amount of money and they don't have the willpower to say no. Notch. Maybe they get actually blackmailed, like literally, and we didn't find out about it. Well, the difference is that the nonprofit has made an Ulysses Pact. Is anyone familiar with this concept? Yeah, okay, about half, like a third, yeah. Okay, so this is a Greek myth. In this Greek myth, there's this deadly patch of ocean that they have to sail through. And in these waters, these sirens, doesn't look like sirens to me, but I don't know. They sing beautiful songs that hypnotize the crew, making them jump overboard and drown. After a few lost ships, the sailors figured out, that's fine, we can pass safely, we just have to put wax in our ears so we can't hear the songs. Okay, but the captain of the ship, Ulysses, he wanted to hear the song. But he knew that if he heard the song, he would be unable to control himself. So he made a pact with his crew. Tie me to the mast, he said, and until we pass the sirens, do not untie me no matter what I say. Knowing that his decision-making would be later compromised, he made arrangements early on to ensure the desired outcome. With a nonprofit, there's never the option to sell, even if you get blackmailed. All the revenue must go towards the mission. If the organization dissolves, the bank balance must be distributed among other nonprofits. From an entrepreneur's perspective, they tend to function similar to bootstrap private company, but with less personal gains to be made in the end. From a consumer perspective, personally, I find dealing with nonprofits to be the most stable and predictable because they don't have this profit motive or the incentive to sell. Like Wikipedia, they tend to just keep chugging along, doing their mission without major disruptions. All right, next up we have a public benefit corporation. Let's contrast that. These are actually the same as a regular corporation, except they are permitted to additionally spend the revenue on public benefit. Profit is still the point. They're still owners. In fact, those owners have a conflict of interest with the public benefit, because if they spend the money on the public, then they don't get to keep the money. So as far as I'm concerned, these are equivalent to regular companies because there's no Ulysses Pact in play. So that leaves us with the elephant in the room. Where are my coggy hippies at? Thank you. 1, 2, 3, 4. Oh, we got like 5 of you. Great. Your product is great. I love it. I started using it last week. I expect it to remain great for a few years, and then I expect those sirens to start singing. And I don't see wax in your ears, and I don't see you tied to a mast. So at that time, I expect you to drown in cash because you sold out. And I'll be happy for you, but then I'm going to have to find a new search engine. All right, moving on, we have crowdfunding or direct donations. The winning formula here is to have a small team and a ton of users. So this way you achieve sustainability with even a tiny fraction of your user base subscribing. It's a bit of a monkey's paw though, because if you have any kind of labor that scales with the user base, that will start sucking up all your time. So for example, the bug tracker. Which leads me to an idea that I've heard of recently, and I've discussed with a few people already during this conference, paid issue tracker. I have no experience with this. I would love to see some more data points. I would love to hear people trying this out. I like the idea because it puts the money next to the inefficient, non-recurring labor. The recurring labor. I can think of some problems though. There's a bit of a perverse incentives for there to be more bugs and for scope creep. And it doesn't really help at all during the early stages of the project when it's less popular. But I would love to chat about this idea with more people. It seems intriguing. Moving on, we have independent wealth. So maybe you have some rich family members or a sugar daddy, sugar mama. If so, congratulations. Maybe you've got some prior entrepreneurship success. Maybe you do part-time work and you can do open source as a hobby. Maybe we get some basic income legislation in 50 years from now. Maybe you're retired. You just got to the end of your career. Or just nights and weekends. This has traditionally been the bread and butter of free and open source software, hobby development. And while it's not ideal for most people, I do think it's beautiful that software in general is so labor efficient that this is even possible at all. Finally, we have the support contract. So one trick you can do to get money is that businesses want to de-risk their supply chain. Ironically, sometimes you have a better chance of getting your free software adopted at a company by offering it to them along with an expensive support contract. This is something we actually did at Zig Software Foundation with Uber. So by paying us a sum of money that was small to them and big to us, their reliance on the software is de-risked because they can get help with bugs if something goes wrong, bugs that we want to fix anyway. And finally, I want to revisit part 2, the part where I threw the users of open source software under the bus. I think if you look at free software as a bastion of our labor movement, you might look at some of these interactions under a new light. All these entitled people on the issue tracker, yeah, they're feeling empowered by the belief that software is a user agent operating on their behalf because you liberated them. All these annoying users who didn't read the fucking manual, most of them are immature youths who are having some of their first informative experiences in the world of computing. Yeah, it's a pain in the ass, but this is an opportunity to mentor the next generation of programmers in the spirit of the Handmade Manifesto. These open source woes are worthy problems to focus on. They're problems, but they're worthy problems. Instead of shying away, we should meet them head on, because even just one talented programmer can meaningfully contribute to society's resistance against digital landlords. But collaborating, we can even overcome network effects, fight vendor lock-in, and seize the means of computation. Together, we serve the users.
And we have some minutes for questions, actually. If you would like to sit down right here with me, we can do a little fireside chat. We have 10 minutes before lunchtime. I'm going to give you a nice long lunch, I promise. In the chat, I'm going to give priority to the chat. If you have access to the chat, that'd be great if you can type those questions in so I can treat my online audience as first-class citizens when it comes to asking questions to Andrew. Please try to use the chat. But if I find that the chat's no longer asking questions, for example, then I can go to you guys here in the audience and get you guys to ask questions, okay? That's how we try to make this work for this conference. I was laughing at not laughing, but like smiling at this last part of the talk because as you and I discuss this often, like I said, we're friends, we text and whatever, and like you're telling me, Abner, my conferences, by the way, these conferences specifically are an indie business for me. Like it's a small business, I'm in charge. It's a very mom and pop shop vibe. Like I sell tickets, I make money. You know, do you get angry if your favorite bakery shop greets you as a neighbor and be like, hey, I have a promotion running, like, you know, go by? It's usually like not too bad. So I think you have like a totem pole of like what's better and what's worse. So like you put like nonprofit at the top there. My indie business is better than some corporation. It's better than some of the stuff that we say. Is that still like you're thinking about that, or?
I'd like to reframe it a little bit because
go for it.
I think that what I hope I managed to communicate, and I want to clarify now, is that it's not about morality. It's not about, doing this kind of business is more moral. And I'm not trying to throw Kagi under the bus and say you guys are doing something immoral. It's not at all what I'm saying. What I'm trying to say is, as a consumer, I'm just trying to predict where I should spend money on and where I should put my data. And I'm just having a prediction of which companies will be there for me in 10 years and which ones won't. And that's it. That's all it comes down to.
The first question, this is a sign of the times. What unions do you have experience with?
My wife is in a teaching union. I have never been in a union. I work at a nonprofit with 5 people. So I won't be joining a union. But I want everyone else to.
Well, the questions keep trickling, and thank you for those who add like a little Q colon on the chat. I love that because that helps me parse the questions a lot better. Feel free to ask anything, by the way. Agreements, disagreements, strong opinions, honest opinions. That's the point of an indie conference, right? But I wanted to make an observation that this year, one of the reasons I had so much trouble putting together this conference in the first place, you saw it on the chat, those who are in the chat in the introduction channel. I didn't ask them to do this, but there were a handful of people saying like, thanks to Abner for helping me find a job, or like I was unemployed for a very long time, like this mass layoff, endless layoff situation. I was almost destitute, literally. I'm like, you're such a competent programmer. And like you're coming to me to try and help you find a job. Like that's weird, right? So I spent a lot of my time this year, even though like it's not like, they weren't like demanding it from me or anything like that, but it's like these are friends or these are community members or like the most vulnerable and who were like months and months and months without being able to find any kind of employment whatsoever. They were like the best or in the best teams, and then all of a sudden they're gone, right? And so I spent a lot of my time trying to connect them and help find jobs. And I understand why there's so much interest right now in these conversations, including unions, including like meetups, including ways to, you know, and there's gonna be people who agree with that approach, people who disagree with that approach, but I do welcome all these conversations, right? Because I saw so much suffering this year, I just don't know, right? Okay, I gave enough time for people to ask questions, haha, you see, I'm a good rambler. Okay, from Amin, thank you for your question. Do overly broad software patents, for example, patents over like user-facing software features, do those patents represent a major threat to free software?
I guess the question is, should you be worried about consequences of some kind if your free software work is overlapping with a patent? Personally, I don't spend a lot of time worrying about this. I think if you put out free software, you're just not gonna get in trouble for it ever. I'm not sure I understand that question. I'm sorry.
And you're free to write it again. Looks like I did miss a question from McCoy. Hello, McCoy. I'm glad to see someone in Handmade advocating for true free software. Many influential programmers in Handmade, such as Jonathan Blow and Casey Muratori, are anti-open source and frequently criticize the free software movement. Most projects on Handmade Network are closed source. This is true. John Carmack, by contrast, is a shining example. He released the full source code to the Doom and Quake series pre-ZeniMax. This is still essentially unmatched in the game industry. I hope Handmade programmers can see the benefits to the user that free software has. Don't just optimize for frame rate, also optimize for user freedom. We can make it work, and it is worth doing. Any reactions to that? I don't think it's an actual question, but it's a good, interesting
Yeah, I
statement.
understand the hesitance, especially from game developers, where you have the debut and then you have the game's lifetime. I think a nice baby step for a game developer would be open source your game after a year or two. I think that would be pretty harmless to your bottom line, and it would be a nice little practice, you know. But the bigger point here is that it really comes down to ownership. So if we've enjoyed as the gaming community right now the fact that Valve has been decent stewards over Steam. And consider, what is their percent? Is it 20, 30? 30? That's a fucking insane amount of money for them to take from you. But we're actually pretty happy to give it for the most part, from what I've heard from people, because they are providing a service. But how long do you think that's going to last, right? Valve is a privately held company. The people who started are aging. If they wanted to sell that company, they would be able to sell it for an insane amount of money. I think that's just a matter of time. And then what's going to happen then? You got all these gamers who are hooked on this fucking heroin of Steam. They're going to be locked into that platform. It's going to be a nightmare, right? And the solution is free software. Like we're going to pay the cost of the fact that we're on someone else's platform renting their land from them, where we could have been on a communal space this whole time that has problems that we have to work through, but that won't get bought and sold and milked by these capitalists who don't give a fuck about you.
How does the fact of open source dev as labor, how does that play into the fork defense, the defense of fork? Okay, if almost all dev is done by corporate overseers of projects, how can the free forks succeed?
Can you just repeat that one more time?
Yes. If almost all of development is done by some corporate overseer of that project, how can the free forks succeed?
Right, okay. Right, so the key point here is which group of humans is capable of maintaining the project? So if the code base is free and open source software, and it's important, in other words, it's used by a lot of users, companies and otherwise, that means that if that company tries to exert that control, there's enough interested parties that they can then fork it. They do have enough people with the ability to break into the code, understand it, start maintaining it, and take it in a different direction. In some cases, you could have an example where, it was open source, but now only one person understood the whole code and they decided to close source it. And it's like, well, no one else wants to touch that code. But in reality, if it's an important project, that won't be the case. If it's an important project, you're going to have more than one person who's able to be a steward of it. And so if a company tries to pull those shenanigans, you can fork it. You will have the effort behind you to carry the torch.
What advice would you give to folks just starting in their journey through computation in light of all this chaos?
Don't lose joy. Try to seek the spark that got you into it in the first place.
Keeping the joy. It's true. There is a question from Scott. Hello. Sorry, sometimes I don't say their names. I apologize for that. What about games? The average game takes a lot of effort to make. Is it okay to charge money and be a privately owned company in that regard?
Yeah, again, I'm not telling anyone what you're doing is not okay. Everything's fine. You got to make money.
I can sell tickets.
You can sell tickets. You can sell your company to Microsoft and cash in, and I'm seriously happy for you, like as a friend, right? But just as a user, I'm like, okay, but now I need to move my data. That's all I'm saying, right? And with games, I do think it's less important. Like I play a game for a while and then I stop playing it. It's as dead to me as it is to the developer, right? For some games. For other games, I mean, I would have loved to see Minecraft be open source. I mean, for example, like Notch said he was going to open source it, and then he didn't, and that made me mad.
We have a couple of famous Minecraft modders in this community, by the way, who obviously has to be reverse engineer and yeah.
Yeah, one of them's me, by the way.
Yeah.
But sorry, to wrap up the actual question, is it immoral to make money in games? No, of course not. Make your game, do whatever you feel comfortable with. Just ask yourself, I think it's more important for non-games, but ask yourself about, I don't have a good answer to this. I don't care about games, honestly. I think the other stuff's more important for open source.
Any thoughts on cooperatives, whether they're owned by workers or customers, as an alternative to traditional businesses?
I'm interested. I don't have anything smart to say about it. There's a co-op grocery store near me that I go to sometimes. It's fine.
Thank you, Rhino, for your question. This one's from Mary. Hi, Mary. What are your thoughts about models of mentorship and education in a context of free and open source software?
Well, yeah, I think that one's tough because mentorship is always competing with other kinds of time expenditure. So speaking from personal experience, a lot of people in the Zig community are seeking mentorship. That's actually just the main thing that they want. And I want to give that, but also I'm trying to build the project. Like I'm trying to work on the compiler and I'm trying to deliver a thing, and it's just a lot of work. And so, yeah, I guess my thoughts are it's a tricky problem to figure out how much time you want to spend on mentorship and how much time you want to spend on just getting stuff done. And sometimes those things are at odds. So, and they're kind of entwined. And I don't know, I think it's a very human, messy, sloppy thing, and you just have to kind of use your feelings and your intuition to work through it.
I know I'm cutting a couple of minutes into our lunch hour, but you're still going to get the full lunch. Don't worry about that. Yeah, let's do a couple of more questions. If there's any others, I think you have access to the chat. It'd be cool that
I do.
For you can answer them in the chat if necessary, because you got a plethora of questions in limited time. So let's do two more though. One from Anne. Hi, Anne. Is this a licensing issue or a values issue? In your view, can programmers still make software that respects users even if it's not open source?
In my opinion, no, because it's about the ownership. So if the point is that if it's closed source software, then the owner of the code can change. They can sell. It can be hostile. And then now all of a sudden, all those consumers who only have the binary have no choice. They can't fork it. They just have to either use the old bit-rotted version that maybe has DRM in it, so you actually can't even do that. Or they just have to use the new thing that has new stuff injected into it that they don't even know what it is. It's hidden. So I think that absolutely comes down to whether or not the fork is available. That's the key. Can you do the fork? That to me answers the question.
Final question. I know there's more. Andrew Kelley will be in the chat and we'll answer them when he can. From James Duraning. Sorry. What do you think about open source projects that charge money for compiled code, like Sprite did before switching to closed source?
Oh, they switched to closed source?
I had no idea either. That's fascinating. I'd love to read more about that.
I mean, I think that's fine because, again, the fork exists, right? And the fact that I'm speculating a bit because I didn't know that. The fact that they went from open to closed and didn't get forked, in my opinion, means that it just wasn't that important of a project. And so that's just kind of fine, you know?
I would like to echo one of the comments. Again, you're getting lots of questions. They're really good. I want to echo one real quick that says, you really wore your heart on your sleeve today. Would you like a hug?
I would like a hug. And I want to, thank you for that question. I want to reiterate that I'm not saying that anyone's committing any unethical or immoral acts. I'm seriously not saying that. I really want to emphasize that I'm saying that as a user, we should try to build a society where we just own the code that we run on our own computers, and that will just be better for us. That's all I'm saying.
Round of applause for Andrew Kelley. our keynote speaker for Handmade Seattle.
You did want a hug. I'll give you a hug.
And for those who love the nitty-gritty, low-level programming talks, that's going to be happening this afternoon, by the way. We had to open in a very interesting way this year, given the nature of the year. All right, we have a 90-minute lunch break, people. That's 90 minutes. And before you leave, I want to raise hands, a couple of people here. Where's Taylor Robbins? Do you mind? Guys, turn your head on the back there. He's like on the top row right there. Taylor Robbins, he's one person who's going to be going to a nice little restaurant. So if you don't know where to go for lunch, follow Taylor. Maybe you can wait right at the entrance for people to find you. And then Ben, everybody knows Ben Business, is going to be heading to the Armory that is from walking distance. This is the Seattle Center, people. Lots and lots of places in walking distance. So Ben will also be going to the Armory. You can follow him as well. If you want to go do your own thing, obviously you can do that. But please, network, have fun, socialize, agree, disagree. And I'll see you in 90 minutes. So that would be, let's say 1:35, okay? Please don't be later than 1:35 here. See you this afternoon for more presentations. And then for the online track, I'm talking to the online track now, the people who are not here in person. The people who are not here in person. Because I don't want you to feel bad, I want you to get your money's worth with your ticket. We are going to premiere an exclusive podcast with the creator of the File Explorer we've been talking about. I believe Yakoslav is on the chat, so Yakoslav can say hello on the chat, so people know who the creator is. I think his artist is also there, so the artist's mother can say hello there. And we have a nice hour plus exclusive conversation with how he made this amazing File Explorer. Let's roll the tape, enjoy lunch, and enjoy this exclusive podcast premiere. Beyond the folders, inside File Pilot. Hello, Internet, and welcome to yet another Handmade Seattle podcast. These kinds of podcasts are rare. They literally happen at a conference once a year, so I know that there's a lot of anticipation for what this podcast is going to be about. And if you didn't know, we're going to be talking today with the creator of a software project called File Pilot, formerly known as Disk Voyager. And we have Yakoslav right here with us. Hello, Yakoslav.
Hello. Thanks for having me.
Absolutely. It's a pleasure. And just for the benefit of the audience who have never heard of Disk Voyager, now officially called File Pilot, he did do a conference demo video last year, which kind of explains what it's all about.
Just so people know, this demo got the most applause at the conference. It got the most attention at the conference. I want to say definitively this was probably the #1 demo in terms of popular reaction and feedback and enthusiasm. I have so many questions after that demo happened, and Yakoslav has been working on it ever since, a lot more than he already has. And the first thing I want to say to you, Yakoslav, is that you've rebranded. It's no longer Disk Voyager, right? As I was saying, it's now called File Pilot. So why don't you tell the audience maybe the decision behind renaming Disk Voyager to File Pilot now?
Yeah, sure. So when I started this project, I knew from the beginning that I wanted to have some spacey and modern branding. So like many of us, I've always had space association with feelings of amazement and awe, something that represents exploration and the desire to venture into the unknown. And so I even named my company Voidstar, which actually has its origins in the C programming language. It refers to a pointer to nothing. It's just a way of creating morphic structures in C. But I liked how that name invoked images of a planet or a black hole. So I wanted to find a really cool and a space-themed name for the File Explorer too. For the first 3 years of development, it was just codenamed Disk Voyager. But after a while, I started feeling that Disk Voyager might not be the best name from the branding perspective, because the word Voyager had strong associations with the TV series and the actual NASA program. So I thought it would create a confusion among users. And there were actually quite a few people that told me this. And also the name was fairly long, and the word disk didn't feel ideal. It reminded me of old hard disks. And I was also not too happy with the logo because it was way too complex and it didn't scale for things like the taskbar, for example. So yeah, around the time of the first closed alpha build, an artist from Croatia, Ivan Šantić, reached out to me about rebranding. And yeah, so we started brainstorming together. And actually, after a couple of months of research, we decided on the name File Pilot. And just a few reasons why we called it File Pilot is, first of all, it's shorter. I like the word file more because it's specific to file managers. It sounds more long-term, while disk sounds more like something towards disk utilities. Something, not so great. I also liked how the word pilot conveys the idea of control and guidance. Also, another cool thing about the word pilot is that it's the same or very similar on many languages, and that's a bonus if you ask me. And yeah, it's just more unique. Googling anything Voyager related results in too much space related stuff. And also another great thing was that all domains were available, and it's hard to find nowadays a good name that also have all domains available. It's really hard to find that. So yeah, and the great thing about the word pilot is that it can be associated with many types of aircraft, including spacecraft. So I was able to brand it in the direction of the space team. Yeah, and so the logo is a result of that. The logo is a small spaceship that somewhat resembles an X-Wing from Star Wars, and it looks way more modern and simple, and it scales perfectly to both high and low resolutions. And that logo, as well the font that's called Geom, they were designed and selected by the same person, by Ivan Šantić.
Oh, okay. For the audience, I got really privileged to have a copy of F-Pilot with the logo and everything. I gotta say, it's gorgeous. And you mentioned the closed alpha that you've been doing. Like I said, I was part of the alpha. You've invited people that you trust into this closed alpha. And I guess that's my next question for you, that I'm pretty sure the audience is probably wondering right now when they can get their hands on the open beta. Where's your timeline there?
Yeah, and I will give the same answer as I always do soon, because I think that the project is now feature complete. I just released a new alpha build a couple of days ago, and that build included a tons of features that people have been asking for and a lot of optimizations. And so at this stage, I'm mostly focused on ironing out the bugs and preparing marketing materials for the release. So I think we are just a few weeks away. I'm aiming to have it ready by the end of November or probably early December.
That's quite the Christmas gift for people potentially. That's awesome. And we should also
some of the people on Discord channel have been waiting for it for a year now, and I really think I should give them to them.
Yes, I'm on that Discord and I can see the palpable excitement for File Pilots. That's exciting. And I would imagine this starts for Windows first. I guess that's been your priority. Is there ever going to be cross-platform builds in the future for people who are on Mac and on Linux?
Yes, so I'm definitely interested in those, but they are not top priority right now, like you said, because my main focus right now is creating a stable, rock-solid Windows version. And that even includes adding more features that I just couldn't fit into this initial version. When and if the project becomes financially sustainable, ports will definitely happen. And I'm pretty confident that I won't run into too much trouble with them because I tried to keep most of the Windows-specific platform code separated from the general program logic. And yeah, so I know that each platform has its quirks, but I've heard actually from a couple of people now that Windows is probably the most complex to deal with. So I believe that if I manage to handle its challenges, that macOS and Linux should be easier in comparison, but I don't know. We'll see. But I'm definitely interested in those. It's just not priority right now.
I think what they've told you about that with Windows being the hardest, I think I'm going to have to agree, as I'm the author of a terminal emulator and it has a built-in file explorer and it does work for Windows and Mac and Linux. And I've always struggled with Windows the most when it came to file explorers, for sure. Speaking of file explorers specifically, this is the whole conversation really, it's about file explorers. Why the interest in it though? Like, how did it come about that you, Yakoslav, and you're a systems programmer, in my opinion, you're really good at what you do. Why did your interest just go so hard on file explorers in the first place? Like, what's the backstory? Let's rewind the clock of how you landed into making File Pilot in the first place. I'm very curious.
Yeah, actually, I wouldn't even consider myself a system developer. My original background was a game development because even as a kid, I was sinking way too much time into games. And I knew I wanted to become a game developer when I grew up. I ended up founding a company with my friends while I was still in college. And I ran that company for, I don't know, maybe 10 years. And then I left for personal reasons. And this just left me deciding what to do next. And I remember at the time I had only one project that I've been working on in my free time. And this was just some kind of file explorer alternative, my experimentation. And it started mostly as an educational experiment because it was inspired by following Handmade Hero. But for the file explorer as an idea, it started a few years before that when we were visiting Croteam office here in Zagreb. And they told us that the whole office was using Total Commander. And this was the first time I realized that file explorer alternatives exist. I never bothered to look. Since then, I just started investigating this domain. I tried a lot of them. I used a Total Commander for my work for a few years because it was really good. When you look at some of the major players in this field, at least on Windows, so that would be Total Commander, XY Explorer, and Directory Opus. They are all pretty old. Like I'm talking 20 plus year old, and they look like that. They look like that. They are faster than File Explorer in most cases because File Explorer is slow, but they are not nearly as fast as they could be. And this is probably because they were developed at the time when SSDs and multi-core processors weren't that dominant. Yeah. So this was one of the main reasons why I found File Explorer to be interesting idea to maybe start doing. Just look like there's a gap in the market for something new, something fresh, something fast, and yeah, I just went with it.
There's definitely a gap in the market because the popular response to File Pilot's conference demo last year, that was staggering. Are you surprised that it's become so popular? Because you would consider File Explorers to maybe be something niche. The mainstream industry on YouTube, for example, will be talking about. Maybe they'll talk about, like you said, you were a game dev yourself. So I would imagine some indie game could become extremely hit the right chord for some reason, like the right time, and it just blows up, right? Because people are really interested in this indie game. But to hear the same effect for a file explorer is just, like I said, it's staggering, it's unusual. And I guess, are you surprised that it's become so popular? And then do you have any inklings, any thoughts, any conversations you've had with fans as to why people are so interested in a file explorer in the first place like this?
What I would say here is I'm probably surprised and not surprised because I've been a Windows user for a long time, and I think that most of us who deals with computers every day for work have noticed the trend of things becoming slower and buggier over time. And I think this is especially true for File Explorer. It's gotten more sluggish and less usable with each new Windows version. And actually, when I was thinking about which program should I develop, one of the benefits I thought it would be for File Explorer is because it's a general purpose program. So pretty much everyone who's using computer has to use some kind of file management utility. So this was one of the reasons why I think it was a huge market gap, because it's so general purpose program that if you've made something that stands above all other programs, it just be great, right? But yeah, I'm not entirely sure why everything's so slow these days. It's probably a lot of factors. In the case of huge corporations like Microsoft, it's likely the case of Conway's law. And another reason might be that texts are just too complex. But I know that a lot of low-level components and libraries were written in early 80s and 90s, and that a lot of programmers today are afraid to write something from scratch. I just want to change it. I know that computers are insanely fast and powerful. Unfortunately, when you start building something by importing tons of libraries and frameworks and engines, you have uploaded software to begin with. Also, you're not in control. If something is not working in one of those components, you're out of luck. I made a decision to write everything from scratch. By that, I get to make decisions how to use modern hardware to my advantage, multi-core processor, SSDs, fast memory, fast individuals memory, and stuff like that. I truly believe if people wrote software today, like the Spartan way, like old programmers did in 80s, by now we would probably have flying cars. But instead we have people arguing about the latest JS framework or stuff like that. It makes me sad. But I hope to change that, at least with the file explorers.
For the people in the alpha who are using it already, it's already a game changer for us. And I want to say that the code size and your memory footprint is also tiny in a way that I'm shocked as well. Was it a priority? I guess it's a question that just came to me. Was it a priority to keep the footprint so small? Because again, for those who don't know, like this file explorer is only 1 megabyte executable. And if I remember correctly, the RAM is also correspondingly tiny. Was that a priority, or did it just happen naturally that as you were writing this from scratch and being, I guess, just careful, it just happened to be that small as a result? Or did you actually make intentional efforts to make sure it stayed small? Like, how did that work out?
I would say probably both. I knew I wanted to make something compact, and that was just one of the design decision. But I knew that if I wrote everything from scratch, that would just be the result of it. Because at the moment, I don't even include C standard library, and that might come as a surprise to some people. But actually, I didn't use it. A lot of stuff from the C standard library is very old, and it was written for the time when hardware was completely different. And so I just didn't use any of that stuff, and I threw it away. So yeah, small size is just a result of writing everything from scratch. Yeah.
You mentioned your inspiration was Handmade Hero to a large degree. And I guess I was going to ask you how Handmade enters the picture here. How you got aligned with the Handmade ethos and the Handmade values, and your sources of inspiration for not just wanting to program in this way, but also I'm sure there are techniques that you employ to write this file explorer. You might be considering memory management techniques, optimization techniques, and like just a philosophy around engineering and things like that. Like, how much of an influence Handmade have on your day-to-day programming of this project? And did you have any sources of inspiration, blog posts or people or things that just helped you create a file pilot? Anything you can tell us about that?
Yeah, I think it comes as no surprise that my main motivation came from Handmade Hero. And for those who don't know, it's an online series that was hosted by Casey Muratori. It completely changed the way I looked at software development. Even at my old company, I remember that even though we mostly work with engines like Unity, we were applying a lot of those lessons learned from the Handmade Hero to our great benefit. And yeah, so when I started working on File Pilot, I knew that I wanted to make it the Handmade way, because this was the only project that would allow me to create something that's so blazingly fast and truly unique. I wanted to have full control over every aspect of the project. And by writing everything from scratch, that's exactly what I got. And it's also incredibly rewarding in terms of learning and becoming a better programmer. So yeah, over time, I discovered the Handmade Network. I joined the community there, and it's been great exchanging experiences with other developers there and getting help with need from people like Martins and people like that. But yeah, Handmade Hero is probably the main motivations. There are others like Ryan Fleury has great blog posts. I can't think of anyone else on top of my head, but yeah, Casey Muratori and Handmade Hero is probably the main motivation.
You mentioned Martin's Mosaico, for example, on the Handmade Network. So I would imagine that you also had a lot of osmosis, like you're just hanging out on the Handmade Network Discord and reading through interesting commentary on programming.
Yeah, Martins plays a huge role there. And I think that you can just learn a lot about programming if you go to the help section in Handmade Network and read his answers to most of his questions. It's truly great, yeah.
How long have you been working on File Pilot so far? Can you give us a timeline of a few months, a few years?
A few years, yeah. I started working on that project full time, I believe it was February 2022, and I've been fully committed to it ever since. I was actually fortunate enough to have some savings to sustain myself, allowing me to focus entirely on this project without any side projects. And that was really great. By the end of that year, I had completed a lot of technical work and I posted a demo video on YouTube. And at that time, it picked up a couple of thousand of views, which I considered a huge success for me anyway. Then in 2023, I primarily focused on improving the UI rendering and the technical aspects of UI rendering. And this was mostly inspired by Ryan's Flurry series on UI. And the second half of that year was dedicated to finishing the first alpha build. And I released that in December. And the response was overwhelmingly positive. I remember that just within a few weeks, I received over 5,000 applications for alpha access. And I can now say that level of exposure was overwhelming. I wasn't prepared for it. And so I decided to keep the alpha closed and private. And I was inviting new testers occasionally. But since then, maybe around 100 people have been testing it. And for this year, it's been mostly about polishing the program, adding new features, modernizing its look, making it even faster and more. This has been all in response to user feedback. And I can say that with confidence that none of that would be possible at this pace if I hadn't built my own tech stack beforehand. So it took some time to bootstrap myself, writing everything from scratch, but after a certain threshold, it's just easier because you own the whole stack and everything you want you can add and there's no friction in that. So around 3 years timeline, around 3 years, yeah.
When you had your initial over 5,000 applications, my understanding is when we talked recently is that it's more than doubled since then. It's just something that is, like I said earlier, it's a niche project in theory, but the way the response has been for the public, it's just, like I said, it's wild and it's exciting. You've mentioned a little bit of how you've built this from the ground up, how you've owned the tech stack, and how you've given priority to performance and presentation and polish. So let's start to go into the technical breakdown a little bit of this. It wouldn't be a Handmade conference if we didn't go into some low-level details here. So yeah. I'm curious, what's one of the trickiest parts to program a file explorer correctly? Like when it comes to building a file explorer from scratch, can you give me an idea of like maybe one obstacle, two obstacles or challenges that you've had to overcome that you felt like, oh, I'm trying to program this file explorer, like this part of programming is just feels really tricky or slippery, or like, I don't know how to get it robust, like that you have to like really fight with in order to nail it down properly. Can you tell us some stories? What are your battle scars, your war stories when it comes to programming?
Yeah, sure. It's hard to pinpoint exactly just one thing, but if I had to choose in the context of Windows, right? So it would probably be some parts of Windows API, and to be more specific, the parts that are connected to COM. So that stands for Component Object Model. That's the area that I've had the most trouble with. The old Win API is much, much simpler in comparison. You just call a function with the parameters and you've done. Maybe just a couple of examples, like things like retrieving right-click context menu items from Windows, or maybe drag and drop. Those two examples, like they gave me some serious headaches. And even to this day, I still have some bugs open related to those APIs. But other than that, I don't think there's anything specific to File Explorer. It's probably just the sheer magnitude of writing everything from scratch, like from more efficient memory and string processing, threading, rendering, UI framework, everything. There's just been a lot of groundwork to cover. But anyway, I've enjoyed every part of it.
I'm surprised that you mentioned COM here, actually, because when I think of writing something on Windows involving file management, I might think of, yes, the Win32 API with, what is it? There's some function calls here about like, find the first file, change notification, and then you go from there and then you iterate over changes. Or it's just classic Win32C function calls. And you mentioned COM, and my heart sank. I got really nervous.
Yeah.
So was it, you mentioned the right-click context menu and something else that gave you trouble?
Items, yeah.
Oh, yes, drag and drop. So are those features require COM, or is COM for something else? What was COM needed for?
No, they require COM. You can't do it without it. So you mentioned like the very basic Win API for iterating the files on the disk. And that's true for regular files. But as the time progressed, they've added new stuff like virtual folders, like maybe recycle bin. So you can't get recycle bin contents using old Win API. You have to use COM. That's just hard-coded. Right-click context menu items, same. Drag and drop, same. Some of the stuff on fetching thumbnails, com. I don't know. A lot of stuff is com, unfortunately, and I'm really not fond of it. And probably another point of frustration for me is because I'm writing in C, and most of that API is written in C. And so I have another step of converting all that code to C, and it's not pretty, but you write it once and you're just done.
I'm going to announce to the audience here that I'm going to drop Windows support for my terminal emulator now that I know COM is required. I don't. Okay, so that's interesting. You've clearly become a better programmer in this process, and you've come away with maybe insights or like wisdom during development. Oh my gosh, I have a lot of questions in this regard. So I'm very curious about how you set it up to program this, because I don't know how much the workflow matters here to be productive. Your choice of editor or IDE or compiler and maybe continuous integration or GitHub or whatever it is. Like, how much did that come into the process? Did you change your workflow as you kept working on this to become a better, more productive programmer? And also, did you learn any lessons about I can't believe that I did this part of programming that I had to completely cast away and start over because I made a mistake, and now you're better for next time for your next project or something like that. So I guess I'm sorry, it's a meandering question here. I'm sorry, but tell me about your workflow in building this. Like, what changes did you make to your workflow, if any, and your development environment, if any, in order to become more productive? And also, what lessons did you learn that you feel like these are hard lessons that I know that for maybe my next project, I won't make these mistakes again?
Yeah, I think I have actually conservative, very simple setup. So I just have a regular text editor. I use Vim, but any text editor would be fine. I'm not a fond of complex IDEs. For the most time, I used Remedy BG as a debugger. Nowadays, I use both Remedy BG and Red debugger, and that's pretty much it. I write code, I compile it in command line, and that's it. It's that simple, yeah. I keep my notes, since I'm one-man team, I keep simple notes in Obsidian, and yeah, that's it about my workflow. It's not anything too complicated. And on the topic of things that make me more productive, probably one of the best advice I could give is turn off the internet. I know if I come to work that day, if I turn off the internet and just don't plug it in for the whole day, I will be a lot more productive. It's not easy to do, especially once you have some community, you need to communicate with them. It's not that easy anymore, but it's definitely one of the things that makes me a lot more productive. And I think I learned that from the Casey too. He mentioned it in one of his streams. Yeah.
Once again, back to the programming, I'm interested about, for those, again, who haven't seen File Pilot or have had the privilege to use it themselves, there is staggering performance here. Like, it is just blazing fast. I was calling it in your Discord recently before this podcast that is basically, you have NASCAR performance. It's like a Formula One racing car. It has that handmade magic sauce that I love from handmade projects. Like, for example, you've mentioned Remedy BG is a good debugger. The RAD debugger also shares some of the handmade values. It's just, it feels like it's moving faster than I can even think when I'm using this software, which should be all software, right? You were mentioning at the beginning of this podcast how you're shocked how every software is so slow when it doesn't have to be at all, right? Like, you're one person making a file explorer that trounces the competition, and that trounces, in my opinion, the default file explorer on Windows. And Windows has a full-time fleet of Microsoft engineers that can make this file explorer better if they wanted to. And yet here you go, one indie dev like yourself making this so blazing fast. And I guess I'm curious, can you tell us a little bit how much you're comfortable sharing here about what you've done to achieve that kind of performance? Tell us about the caching that did you introduce caching recently to make this faster? How you manage memory? Do you use any compiler intrinsics? Are there any SIMD extensions like auto vectorization? Can you maybe give us a bit of an overview of what you've done in terms of optimization and performance?
Yeah, sure. So again, this might come as a surprise to many, but I truly believe that the main source of a really solid performance for File Pilot is probably what Casey called writing non-pessimized code. It just means, since I wrote everything for myself, all code, excluding the Windows specific parts, most of it is focused solely on the actual problems that a file explorer needs to solve. There aren't a lot of heavy abstractions because there's no need for them. And the demands of the program I was building dictated which parts of the code needed to be written. Also, you mentioned a huge part of it was probably the way I manage memory. And this is somewhat well known in these handmade circles. So I batch most of my allocations into large pools. I use memory arenas and static allocations when pooling. So that memory management model, it dictated how everything else was built on top of it. So example would be efficient string storage and processing. So yeah, I think that that the thinking in terms of group lifetimes instead of individual objects was probably one of the most liberating lessons that I picked up from Handmade Hero. I truly believe that. Casey called this N+1 stage, something like that, yeah. When it comes to optimizations, it might come as a surprise to some, but I've only made a very basic step so far. Hopefully, I'll have more time to focus on this in the future, but essentially, I ran a profiler and looked for the areas where the code was slow. And to my surprise, there weren't that many of those. I didn't even use many hard code optimizations. For example, I only use vectorized code in a few places for now. However, I do rely heavily on multi-threading to improve performance. And you mentioned caches. Yeah, I use a lot of caching with various hash maps. Again, a canonical example would be icons and thumbnails. So instead of going through the Vin API each time, I just cache the allocated textures for them, and I'll then use some kind of eviction scheme. So there's just a lot of caches on top of Vin API that makes it fast.
That's an interesting observation to make. And because I'm assuming that if you're doing this project in a handmade way, you might also be adopting a pretty popular philosophy, which is that you're a game developer, so you do sometimes think of, I'm running this at 60 frames per second, or I'm recomputing this entire UI tree, or I'm recomputing this entire data structure like once per frame. Is that accurate? Do you do it that way?
Yeah. When I started it, I was actually using the VSync. But then nowadays, the current version is built without that. So if your computer is fast, it can render it in, 500 frames per second. So each time it's built in the way that it only responds to the events. So when you move a mouse or you click something or some file changed on the disk, it will refresh everything it has to, and it will go to sleep again. But it will do that in the fastest way it can. So the idea is any change happens, re-render everything from scratch, but do it fast. And it works great.
Okay, that's awesome. Because I was always worried, again, for my terminal emulator, and I'm trying to relate my experience with yours so I can understand how you did it, where it's, if I'm moving between folders and files, or I'm typing a command on the command line, I do also use the recompute on every frame philosophy. But I was afraid because if I am doing something file related or related to the file disk, the file system, if I'm recomputing the UI tree and I'm recomputing all operations once per frame, I was really afraid that I'm thrashing the person's operating system because I'm just touching the Win32 API all the time. Or on Linux or Mac, I'm just like touching the file API every frame, and that feels like a bad idea. I think I do use a hash map in order to say, okay, somebody's navigating this folder and I'm just gonna use a hash map to cache in all the contents of it. And then if they rewrite a command, or if they do some behavior like clicking something or whatever it is, or some change notification happen, like a disk change happen, then I go back and touch the Win32 API again. Is that how you do it for almost all parts that have to do with the API, including COM and everything? It's just you have caches on top of the Windows API at all times, and you only invoke the API when necessary, right?
Yeah, it's not only caches. You mentioned indexing the files, right?
Yes.
So it's not like every time a frame needs to be re-rendered, it's not like I query the Vin API for all the files again. So when you open the file, when the user opens the folder, it will just index all files in it and it will store them. So I have the index of that directory in the memory. But other stuff like thumbnails or file metadata, like how big the file is and stuff like that, that is cached in a way that, so you can imagine if you are viewing a folder with 10,000 items, which is possible. You don't want to compute every information for all 10,000 items at the same time, right? So you want to, as you scroll the view, you want to put some work in the separate threads that will retrieve that information for you, and then you store it in a cache. And that's pretty much how a lot of stuff works, because and I think that if you download some of the other file explorers, it's pretty obvious that what they do is exactly what I described, but in the opposite way. So if you open some big folder, you can see how they are locked in the main UI thread, probably loading all the possible data they can for all 10,000 items, and it's the UI thread is just stuck for 10 seconds or something like that, which is not what you want to do, right? So you want to load only the stuff on the screen and stream the new stuff as you go.
When it comes to the multi-threading, I had that on my mind too, because I haven't done multi-threading on my project yet. What kind of work can you do on the File Explorer that can be parallelized and turned into threads? Is it just, I'm assuming File Pilot supports many tabs and it supports the ability to have independent operations happening in the background or something like that, like copy paste operations on one tab while you're doing something else on another tab. Like, I don't know what kind of work can you separate out into serialized, parallelized way that can take advantage of multi-threading?
Pretty much everything that can take some time. So it's not even always about what type of code can be parallelized. So if I know, so for all operations, I imagine what would be like if user loaded a folder with 1 million files. So that's just constrained on my design. I can't just sort all the files on the main thread, because if the folder is too big, that would stuck the main UI thread. So pretty much every operation that can take some time is pushed into separate threads. And then in the main UI thread, you just merge the results as you go. So that's true for sorting, for filtering, for fetching thumbnails, for indexing folders, for loading metadata, pretty much everything. So the only thing that's in the main thread is building the UI. Everything else is in the separate thread.
And I'm curious, how early did you decide to start multi-threading? Because I don't know how much of the architecture, like the foundational architecture of the code base, if I can say it that way, has to change when you introduce multi-threaded work.
I think I've added it right from the start, because I knew, I anticipated that I would need them if I wanted to scale to like big folders. So I just said, okay, I will include them from the start so I can know when I write new code, I have that in mind. It was just one of my decision. I don't know if this was the right decision, but that's just how I did it. Yeah. So maybe after a couple of months of basic work on my engine, I just plugged in the thread system and went full on with it.
Was this your first time doing multi-threaded work, or did you already have experience with that in previous projects?
In C and C++, yes. I've done it in C# and .NET and stuff like that in Unity. But even there, not so much, because when you use something like Unity, most of the heavy work is already multi-threaded inside the engine. The code you write will most likely not be multi-threaded. But when you do everything from scratch for yourself, you need to think about stuff like that. So, yeah.
Did the memory management become more complicated when threads were introduced? Because you mentioned memory management and how you've done it in the popular Handmade way of thinking of arena and group lifetimes and just doing N+1, like doing things in large batches. That's also part of the data-oriented thinking too, right? But when you introduce threads, that complicate matters, so that it stays simple for you when it comes to memory management?
Actually, not that much. I think that probably one of the main lessons I learned here, and I think I also picked that from Casey, like many of good stuff, is probably the best rule for multi-threading is not how good your synchronization mechanisms are, but you should have the least amount of synchronization possible. And one of the way you can achieve that is when you need to do some work in separate thread, you just allocate separate memory in that thread for it, copy the data you need to work on, and then that thread can work in its space, in its memory space, and it doesn't have to think about other threads and main thread. It just works as an isolated unit. And when it's done, the main thread just copies the result, merges them back into the main memory. And this is one of the techniques that I think really simplified the architecture I used. And that's why I say I don't think that multi-threading complicated stuff that much. But I don't think that most of the people write the code in this way. Most of the people thinking, okay, I have a separate thread, and now both threads or tens of threads, now they have to think on which part of the memory they can touch. Do they have to request a mutex for it and stuff like that? And I think it's something similar to how people think about individual objects versus batched lifetimes. It's very similar problem. Like I truly think that people overthink problems like this.
Also, it's important to note that you are using a way of programming that is honestly, like I'm saying this honest, I'm not just saying this because I'm running a handmade conference and I'm trying to sound cool, but like it is a rare way of programming. If you look at the articles on online or blog posts or even university classes and all of these things, and what you learn in university, what you learn in blog posts, what you learn in companies is very alien and foreign to the way we do it in handmade. Like it's just a strange way to them for you to do it this way. And yet we see the benefits of you doing it this way. But I guess one challenge could be, and I'm curious your thoughts on this, like when you encounter roadblocks and you're going to feel same way a novelist maybe has writer's block, right? It's like, oh, I don't know how to move forward with this. You mentioned blog posts like Ryan Fleury. People in this community know about Alan Webster's Mr. Fourth series too. So there's a little bit of help that we get, but not that much compared to the vast treasure trove of the internet.
Yeah, I got that feeling. And as you said, it's not only that there isn't a lot of handmade type of information out there, it's also when someone tries to post stuff like that, information like that, it's usually comes with bad comments. And so I think that even people who might be encouraged in the first place to push their experience outwards to other people, they're usually not motivated enough because everything they write, they will just be filled with bad comments. I've hit that roadblock a couple of times, and luckily I've been in these local handmade communities for quite some time. I think I'm safe in that manner, but when I'm stuck with something, I will just ask on Handmade Network or on Molly Rocket Discord, and people will answer. But yeah.
Yes, if it wasn't for the community of people that like to program the way that you like to program, then you would be pretty much stuck because it's online. You don't see that much out there. That's interesting.
Yeah.
You are also one of the rare handmade projects that is not only blazing fast, like I said, like NASCAR performance, but it looks, in my opinion, gorgeous too. It's just the presentation and the polish. And I don't mean to dismiss any other handmade projects. There are handmade projects out there that are beautiful, but it is rare because in the handmade, at least so far, at the time of this recording, many people in the handmade community have made it themselves. Like they're not artists, they're not designers. And so when they do make their blazing fast, buttery smooth, and snappy handmade project, it's amazing to use, but sometimes it just doesn't look in a way that maybe would motivate normies, let's say, like people who are not hardcore low-level programmers like to use it because it just doesn't look as pretty. But like File Pilot, your File Explorer, is both the presentation and the polish is, in my opinion, gorgeous and at the same time blazing fast in the handmade way that we like it. So I guess I'm wondering, how did you achieve that? How much of a priority did you give it from the beginning? And are you an artist yourself? I guess you mentioned an artist from Croatia at the very beginning of the podcast. Like, how much were they involved in this? Sorry, I'm rambling again.
Yeah. First of all, thanks for that. I'm not an artist, but I believe I'm really good at leading a project from start to finish. And I think that's an important quality to have. I have a sense for when something is off or could be improved. For example, if you compare the first version I gave to people when the closed alpha was released, and you compare that with the latest version, you'll notice that the basic structure is almost the same. But there has been a lot of work that has been put into it. There was a lot of trial and error. I experimented with many UI designs, and a lot of that was discarded. So what you see right now is really just the filtered result of many such attempts. But honestly, if you ask me, one of the reasons why File Pilot was a good project fit for me, because I'm a one-man team, is that it doesn't have a lot of UI actually. If you do it in a smart and compact way, it doesn't have a lot of UI. Most of what you see on the screen is actual content, and that's intentional. It's a very simple UI by design. However, the part that I struggled the most was the UX. For example, how various parts interact with each other, default actions, hotkeys, and things like that. But the UI part, I don't think it was just not that big part of this project. It was more like how to emphasize the content in the most direct way, and just moving a lot of UI that's not needed. One of the way I achieved that was, instead of using complicated menus, top menus that traditionally application had, I use something like command palette. And this is something that I first discovered in, I believe it was Sublime Text in 2012, something like that. So almost 10 years ago. If you need to find some command or some functionality in File Pilot, you just raise the command palette and you can find it. I find that and way more functional approach than a lot of menus on top of program. So that's one of the way I achieved that. Yeah. Other than that, I don't know. You've seen the program. It really doesn't have a lot of UI. It has a sidebar. It has a regular panel listing, which lists all of your files.
It has context menu.
That's pretty much it. But yeah, when you open the first time file palette, it's just so simple by design. Simplicity was one of the core design goals for this program. Yeah.
I also want to mention that I'm right-clicking right now on the context menu, and I just noticed that it has a search function in the context menu. That's really cool. That is to search for.
Yeah,
Go ahead.
Yeah, I just knew that from the start that since this is a file explorer, and I've already mentioned command palette, and similar thing is applied to context menu. Also, there's a window called Go To, which you can open, and it lists all the recently accessed paths, and it also lists all the contents of some of the well-known folders, like home folders, downloads folders, and stuff like that. But yeah, I just knew that I want to have this searchability at every step that you can use, and that includes filtering the contents of the panel, includes searching for the commands, includes searching for the paths, includes searching for files in the drop-down menu when you click on the path on the top, and everything that you invoke and where you can see some content, it's pretty much searchable. And I just wanted it to be that way.
I'm curious about, once again, when I'm searching for something, I am never left waiting for results to be sorted and to be presented to me. File Explorer on Windows definitely makes me wait. If I search for a folder, especially if you're a game developer, they work on game studios or on Unreal Engine, Unity with hundreds of thousands of files inside a single folder, or they're searching through millions at the end of the day. It's just large code bases with lots of file structure and stuff. And I'm sorry, guys, I'm going to keep raving over this project because it really deserves it. I'm searching for something and it's just, I don't have to wait. I just don't have to wait. It's just right there. And I'm curious, from a technical point of view, once again, in this low-level handmade way of talking, did you use, for example, like this is other program that people in the community like to use. I don't know if you've ever heard of that one. It's
yeah, of course I have, yeah.
From Void Tools. For those who don't know in the audience, definitely use any search engine that you like to search for this. It's everything by the company. I think it's called Void Tools. And you do have to give it permission to do this, but they have a master file pointer coming from the NTFS file system that lets you index the whole database of your file system in order to then quickly scan and search through things. I guess I'm wondering, did you use that for File Palette? I don't think so. If I can predict, I don't think so.
No, I haven't used that. I've written code for that very early in the project, and I still have it in my code base. One of the reasons why I didn't want it to be the main way of indexing the files is because it requires admin privileges. Second, it's not officially exposed API. It was reverse engineered by some engineers, so I didn't feel comfortable use that as the default indexing mechanism. And third, it's only applicable to NTFS and FAT32. So you would have to write other types of partitions anyway. But I will probably include it in the file pilot at some point, but it will be something like option that you can tick on as an optimization path. So it will not be included by default, but for users that have admin privileges and want to use it, they can use it. So that's my philosophy on that, yeah.
Oh my God, that's interesting. So you didn't want to shackle yourself to doing it using this trick that everything, okay, that's interesting. And what about that? To me, that makes it even more interesting because I was like, oh, how did he achieve some of these ways to sort through files so quickly and to search through things so quickly and to deliver those results to people? I thought of the NTFS file pointer thing, but you're not even using that. So that's really
I think that people are not actually aware how fast their PCs are. Like when you look at the specs for the modern CPUs and the memory, and it's just blazingly fast. And if you write a code that doesn't do 10 things, that it doesn't have anything to do with the indexing files, you just achieve results that are fast. It's really just that. The main functions that index files are maybe 200 or 300 lines of code. That's it. They are multi-threaded, but that's pretty much it. When you write the simple, straightforward code to index the disk, that's it. You get these results. But when you go through tons of abstractions just to load a file from the disk, you get sluggish behavior. And yeah.
Do you feel like if you said you're a one-man team, if somebody does ever join your project, let's say I want to hire somebody from the community, like a contractor or like somebody to help me out, do you feel that they would be able to follow your code base, or anybody would be able to follow your code base and like contribute right away? Or maybe you have to filter just for handmade people because of the way your program is so specific. How would that look like?
Yeah, probably something you mentioned. There would probably be some filter like handmade filter with the people who are at least know something about the handmade hero or circle in these circles. So it's hard to find people that are not aware of these techniques and expect for them to just follow my code. That would probably not happen easily. But it's not like I'm writing some science fiction code. It's just straightforward procedural code. There's a lot of it, but I'm not doing anything special. I would say probably something that's very specific to me, and it's just something that I've picked up from my original company, is I'm not too fond of splitting code into too many files. So in this project, I think I have maybe 7 C files. I have a lot of headers, but I have 7 main C files, and the main C file which hosts the main logic is somewhere around 50,000 lines of code, something like that. Because most of the time I just navigate by symbols and it doesn't matter. Yeah.
Oh, that's so cool. I think I'm curious about, because this is just straight up procedural vanilla C code, let's say, or C style. I know that a very classic argument against using C these days is that we've learned all these lessons around memory management and how hard and tricky it can be to get right in a language like C. Did you encounter memory bugs and memory errors that you felt were a lot of friction and very annoying that you would have avoided if you used another language? Or did you just feel like, no, I didn't have any issues at all? Tell me more about that.
Yeah, with respect to C, it's not like I'm a fan of it. I'm not the person that goes around and tells people you should use C because I used it or something like that. I know it's an old language, but the thing is, it just gives me everything I need to write the stuff I need to. I think that a lot of people don't realize how much they're giving up when they're jumping on the trains of new programming languages. I have nothing against people who design them and work on them, but there's so much stuff that's been developed against C in the last 50 years. It's just like all the API that I use from Windows is written in C or C. If I were to use like any other higher level languages, I would have to write wrappers for it anyway. So I'm just writing code twice. And it's just, I don't think people actually think about stuff like that. As to memory management, yeah, when people say we've been doing this for years and we know how nasty these bugs can be and stuff like that, I don't think that people realize how we don't know everything about memory management and how the programming language that are developed nowadays actually solve for the problems that are not the problems that I have, because I just don't write the memory management in that style. So I mentioned at the beginning that I batch a lot of my allocations, and when you do that, it's 99% of the bugs that you would usually encounter if you were calling malloc or new for every object in the system. I just don't have those types of bugs. And when I do have them, they are usually so obvious that the whole program crashes. And I know that I just go to the place where it crashed and I see, okay, I did something foolish. I forgot to, I passed the wrong arena or something like that. Mm-hmm. I don't know. But it's so obvious that it's just not a problem. I think that most of the stuff that caused crashes on File Pilot for other people were not due memory management. It reduced some silly stuff in the Win API that I didn't think true or something like that. But memory management, not so much. But the problem is, I'm not saying that C is the best fit. Other languages are not making substantial improvements in the area that I would want them to make. So I'd rather just use C, because why not? It's a simple language. It's old language. It's supported everywhere. And
we have in this audience, we have lovers of Zig, lovers of Odin, lovers of Jai, lovers of all these attempts to move beyond C. And I would be curious what they say in the chat, because even myself, for my own project, I'm also still using vanilla C for basically all the reasons that you've said too. Although for my next project, I might be willing to switch or experiment with a different language. I don't know if you have any appetite for trying a new language for a future project or not. What do you think?
It probably depends on the type of the project. As I said, for the File Explorer, I think it would only be the downsides. I don't know too much about these programming languages. I know about the Odin, obviously, because I know Bill, and it's probably one of the language that's the closest to the philosophy of C. I don't know too much about Zig. I haven't looked into it. The language that probably annoys me the most, but not the language, but the people who advocate for it is the Rust, because I think that
I didn't even mention Rust. I was like, oh, should I even mention Rust?
I probably don't want to go down that rabbit hole, but I think that a lot of people that use Rust actually are not aware what they are saying. Like they are trying to convince some of the people that have a lot more experience in the manual memory management and tell them how they should manage memory in different language. It's just like you haven't even figured out how to do it properly in C or C++, and you're telling other people how you should do it in another language. It's just, I don't know. It's when I see comments like that, I don't want to be part of it. And yeah.
I guess I have one more serious technical question about your project, and that has to do with rendering. I think about modern graphics API, and there's OpenGL, which is at this point, most people consider it deprecated, even though people still use it. But like, OpenGL is going the way of the dinosaur, the way of the dodo here. There is 11 and DirectX 12, which is more complex API, but it's what Microsoft is pushing right now. And then if you're going to do cross-platform for a file pilot, I know you're going to do Mac and Linux eventually, then you have to consider Vulkan, and you're going to have to consider Metal, potentially, right? Tell us your story about the graphics side of things.
Yeah, so first I will tell right away, I'm not a graphics guy. So this was actually one of the advantages for the File Explorer, because you actually don't need a lot of stuff in the shaders and from the graphics API to support what I currently draw in File Pilot. I'm using OpenGL, so I'm a bit of a dinosaur right now, but that's only because that's the code base I had when I started this, and I will probably on Windows switch it to, people told me I should probably switch to DirectX 11, but OpenGL will probably stay here, if not for anything else then for Linux, because I'm not sure if I'll have enough nerves to go down the Vulkan way, and for the macOS it will probably be Metal. As for the isolation, I think I've managed to isolate it pretty good. I think that my OpenGL renderer is around 1K lines of code, so it's not much. Replacing that with another renderer is probably 1 week of work, so it's not much.
Unless you use Vulkan, of course.
If you use Vulkan, you're like developing a new project. Yeah. But again, I'm not a graphics guy, and so if I'm gonna switch this to DirectX 11, I will probably ask for help. I know that there's a good guide on it from the guy on the Handmade Network. What's his name?
D7 Samurai. D7. Yeah.
D7 Samurai. Yeah, I know a lot of people pointed me to that, and yeah, I hope it will not be too much work. But I don't see any difficulties in performance with OpenGL right now. The only problem I see in the future is maybe a lack of the support for new graphic cards or something like that. One of the annoying things in OpenGL, but again, I've heard the same comments about DirectX 11, is the initial time it needs to load the OpenGL context and stuff like that. It's taking around 150 milliseconds on the startup, which is a lot more than I would want. But what I do to mitigate this problem is I just spawn a lot of threads at the startup, and I try to do as much work as I can while the OpenGL is initializing. So by the time the OpenGL is done, I have pretty much everything I need to display information to the user. So I load the directories, I load the thumbnails, I load the fonts, everything I need to load. The OpenGL is still initializing, but what can you do? Yeah.
Give me your, if you can, I know it's not easy to conjure this up right away, but what was your, let's say, one of your favorites, if not your favorite, aspect of programming this that you got more excited about, like, got you out of bed quickly to work on it, and then the opposite, right? Like, it's like, which part got you the most dread of, like, oh no, like I have to go back to caching and hash maps. So can you tell us, like, one of your favorite things to be motivated about building this, and one of your least favorite that you really didn't like?
Yeah, so I'll start with the easy one. So the least favorite is, I already answered that. It's anything related to COM, and usually anything relating to Windows. As soon as I know, since this is File Explorer, I need to interact with the Windows. I've made it I've made that code isolated enough, so I don't care. So I write that code once and I don't care. I just move forward. So anything related to Windows, I'm not happy. And for the part that I was most thrilled to work on, that would probably be the UI system. I remember when I started doing it in the beginning of 2023. By the end of 2022, I had a demo that was placed on YouTube, and I already had some really basic UI system, immediate mode UI system in place. And then I decided, okay, now I'm going to take a couple of months and I will just drill this in the most Spartan way I can. I just went on the internet and I explored everything there is about immediate mode UIs. I remember I digged up ancient forums from the Molly Rocket, which are not online anymore, where people like Jonathan Blow and Casey and famous people, they were like, so this is the time like we're talking about, and 5, something like that. So it's 20 years old information on the forums where people were discovering this kind of UIs in the context of games. And so this is probably the most fun part of this project. And the series from the Ryan Fleury I mentioned already were extremely motivating. They remain probably the main source of the architecture in place that it's in file palette right now. So that part took like maybe 3 or 4 months, but I really think it was worth it because at this point, I really think there isn't anything I'm not capable of displaying or moving around with various interactions and stuff like that. It's really liberating in a way that, I don't know, when I see other programs and I can see right away when they struggle with some basic interactions because I know that underneath they're using some heavy UI systems that just didn't think of stuff like that. They don't support it, and then they have to fake it. They have to overlay stuff on top of it to hide some glitches and stuff like that. And I'm just so happy I don't have to do that. If I need to move button in a very strange way and highlight it in a very strange way when mouse is hovering it or not, it's just so easy to do it when you control everything. And it's a great place to be in.
Forgive me if I may have missed it, but are you a traditional retained mode guy, or are you more on the IM GUI, firm on the IM GUI camp, or do you blur the lines between those two modes of UI programming?
Nowadays, I'm more on the immediate mode part of the UI building. But when I started programming, I remember a lot of places where I used the traditional retain mode. I remember a lot of APIs that were so complicated, lists that you need to populate to show only the things that are currently on the screen and stuff like that. And these things, just everything goes away when you just program the way, okay, I have an array of 1 million items and I need to render from 1,001st item plus 100 items. It's just like iterating a for loop and pushing a render commands. It's so easy, it cannot be easier than that. And it's just like, there's no API to that. It's just like iterate data and push render commands, and that's it. And it's so efficient. People think that's like the one of the main reasons why you shouldn't use it, that it's because inefficient, but that's really not true, I think.
One of the life-changing things for me, like I have really come to love the idea of issuing commands. Like basically having a message passing system. Like we're talking about, okay, let's just focus it on rendering here and drawing on the screen and stuff. Okay, I'm going to issue all these draw commands. I draw a rect here, have a scissor clip there, and push this quad, push this text, whatever. And that all becomes a series of commands that get queued up. And then I consume those, at the very end of the frame, I consume those queued up commands to then issue them to the backend renderer. That just seems such a beautiful concept to me. A very elegant solution to managing errors too. Did you find that groundbreaking and like very useful for you? Or did you do it for previous projects? You know what I'm talking about?
Yeah, I know. I haven't done it for the previous project that much because when you program in something like Unity, or before that I programmed in Flash, ActionScript, you are just not exposed to these parts of the program that make sense. But in this project, yeah, and as far as I can remember, those techniques are very old at this point. And to some of us, this comes as something really new and refreshing. But to the people who've been using it for like decades, it's so obvious you should use them because there's only benefits pretty much. And I use them in other places. I think you mentioned UI commands. When you do immediate mode UIs, you don't want to make any substantial changes while you're building the UI. So you want to queue up things that would potentially change how UI would look. And you don't want to do that while you're building the UI for the current frame. So what you do is you just push that change And on the end of the current frame or beginning of the next frame, you just go through those commands and apply them. And everything is clean and you don't have any disturbances.
I want to start wrapping this up because you've been such a gracious guest in showing us. I think we've lived up to the title of this podcast, going beyond the folders and going inside FilePilot here. So thank you, thank you. I want to start finishing this topic of this podcast with your attempts to turn this into a business. I know that things change over time as you figure out your business model, but what are your plans so far when you actually do ship this? Are you going to sell binaries? Are you going to sell subscriptions? What are your preferences for?
Yeah, I think I'm going to go very simple route. So obviously this will be a commercial product because I've poured 3 years of hard work and my own finances into it. But I want to really try to keep it very simple. I'm not too fond of monthly subscriptions. I think that this model is being abused right now. And so I wouldn't want to impose that on the users of FilePilot. I will have probably 2 licenses. First, the license will be perpetual. So it means when you purchase a program, you own it for life. The only limitation will be the duration of the updates. I plan to support 2 licenses. One will be more affordable, and it will probably offer something like 1 year of updates. And another will be slightly more expensive, and it will provide updates for potentially many years until a new major version is released, if ever. And yeah, I'm going to try to set the price that will be accessible to most users. I'm not 100% sure which prices will it be, but I'm considering something along the lines of maybe 20 for the basic option and 50 for the premium one. I think that's less than, I know that some products charge like $10 or $20 monthly. So I think that if you really think that this product is great and you want to use it, that $20 for a lifetime license with 1 year of updates is a pretty great deal.
You are an indie dev, right? And my personal recommendation is certainly you ship it and you do the proper charging that you believe you deserve 100%. But also you are an indie dev. Maybe I can give you some guidance on like how you can accept donations. And these are just, again, people who just really love what you're doing and they want to see you do it more. They might give you a donation, no strings attached, right? Like it could be through PayPal or donor box or things like that. I would ask the audience, would you donate to Yakoslav if he just has the option as an extra option? I think you should consider that because I do think you deserve it.
Yeah, I'm really not fond of subscriptions. I think that, I don't know, one of the way I'm trying to tell people, okay, if you want to support me, I will just clamp the duration of the updates for 1 year. So if you're really into this program and you want to use it, you will just buy another license in a year. So you can think of it as a yearly subscription of $20. So it's really not much. But yeah, as far for the donations, I'm not sure what to think about it, really. A couple of people already asked about those. Yeah, I'm just not sure. I'm not sure if it will put like a different paint on the overall branding of the pro if I suddenly start accepting donations. One of the ways I could, so if someone comes along and say, okay, I want to donate you $1,000 or something like that. The thing I can say to him, if one license costs $50, I can tell him, okay, can you just purchase 20 licenses and just share them around?
Yes.
Way you are both giving me the money and you're spreading the word. So I think I like that. I'm not sure.
Absolutely, absolutely. And it's, like I said, you're the creator and you're going to have a choice on that. But it's good to mention it because you never know if in the chat people can give you more ideas. But at the very end, it's going to be be your choice. Yeah. And I said it's rare, but there are still good examples of software out there that is trying to do it similar to you, right? Like there's this Photoshop replacement that is also pretty native and handmade, in my opinion, like Affinity Designer, for example. When we rebranded the Handmade Cities website, we just shipped a new website this year. My designer used Affinity Designer. That's, you buy it once and it's yours. There's this other software called for writers, like Scrivener, I think. People can correct me in the chat. I think it's called Scrivener. You can just buy it. And it's also, I believe it's native and it's fast and you just buy it. And they're successful. Like they have full-time people working on it and everything.
Yeah, there's also another thing, and that is it's probably dependent on the type of the program. Again, if you look at all the file alternatives out there currently, I don't think there's any of them that use a subscription. At least not that I am aware of. I think that most of them just use one-time purchase. But again, most of them are pretty old at this point, so they're that. Yeah.
Yes. Okay.
This has been an amazing conversation. I felt like a little kid again, like a little nerd. I do admire you. I admire what you've done. I use FilePilot every day, and I hope that people follow your progress somehow. So like how to keep up with your progress. How can the audience follow you and buy your software when it's ready?
Yeah, you can subscribe on the product webpage and you will receive an email when it's released. I also have a Discord server where we hang out. You can also follow me on Twitter called X now. I will occasionally post videos or just rant about technology. I also have a YouTube channel, but I only post longer videos there, and it's been some time since I post anything there. So probably the safest way would be just to join Discord server, because that's the most lively place among all of these places I mentioned.
And we'll make sure we put that information on the live stream, on the chat, on the video description when it goes up on our channels, so people can know how to follow you. So once again, thank you for this conversation. Best of luck with FilePilot. Thank you again for joining us.
Thanks, thanks for having me.
And cut.
Ladies and gentlemen, software is falling apart. But you already know this. No doubt it is why you are here at this conference. So let's assume you all agree on that. What some of you believe is that we can fix this. And I'm here to tell you to give up. It's not going to happen. And why is that? It's because you live here. You live on this ship that's on fire. These are the platforms in which you inhabit. This is Windows, this is Linux, this is Mac. This situation is not going to get better. In fact, it is getting worse. You can feel it every day as you use these systems. You could have fixed this problem a long time ago. You could have put out the fire when it was small. But that time has passed, and now the only correct option is to realize your fate, to abandon ship. But there's a sliver of hope here, because if we abandon ship, if we give up, we can realize the other card that we can play. We can realize that we can now build a new ship. Now, this ship here, what we could build, is small, not very useful, but notice how it is not on fire. If we got aboard this ship instead, this is now what our future looks like. The new ship is not on fire, and in fact, we're on it to improve it and make it better. And so clearly, in some period of time, we surpass the old ship and then are able to reach new heights that we were never able to see before. I am here today to tell you about my new ship. This is it. This is the physical hardware. I'm using it to give you this presentation right now. And of course, there's a software component as well. We have this primitive shell. I can run programs. Shouldn't be surprising. There's graphical functionality as well. You know, what you would expect. We can compile things as well, because of course there is a compiler. Otherwise, what would you do with a computer? There you go. There's a compile. But the specifics are more interesting. This system is entirely self-hosting. It is entirely written from scratch. But that does not mean written in C. That means from scratch in that I have made both the programming language and the tool chain that supports this system. The system has no drivers. To those of you who have watched Casey Muratori's 30 million lie problem talk, this is no surprise. This is the obvious correct action. I am solving the 30 million lie problem. Programs cannot access the file system by default on this operating system, because otherwise, if you live where we currently live, when you download a program off of the internet, it can read all your files and send them back to somebody else on the internet. It can encrypt all your files and demand ransom. This is a clear oversight. And by doing things very differently from how Unix does them, we can just fix this in one easy swoop. Now, in summary, the message I have to you today is to stop spending this effort trying to put out the fire. Give up and start forging your own path. And I invite you to join me on my new ship as I try to do exactly that. You can find more information about my project at samhsmith.com/Serenum. You can buy now at taberna.shop, gets you one of these, and access to updates that I put out weekly as I continue to improve the system. And you can, of course, come to my booth where we will have a system up and running that you can play around with and look at. And of course, I will answer all your questions in depth there. But now, I think it is time for audience questions.
Hello, my name is Daniel Hooper, and this is ShapeUp. It's a 3D modeler made in 6 days for the Wheel Reinvention Jam. You can use it to make models for games, 3D printing, or anything really. Unlike other 3D programs that use triangles to represent geometry, ShapeUp models are built by adding and subtracting basic shapes. You can add a cube, round the corners to get a sphere, and resize to get a capsule. If you turn up the blobby setting, you can get some fun shape blending. It even blends the colors. You can subtract shapes out from other shapes too. If you're working on a symmetrical model, you can turn on mirroring along any axis. Using just these operations, you can model mechanical shapes, or something more organic, like Mike here. In addition to the property inspector, 3D gizmo, and keyboard shortcuts, you can also use a game controller to edit models, which makes it super easy to move the camera around. Now that you know what ShapeUp is, let's talk about how it works. ShapeUp uses a technique called ray marching to render. Let's see how this works in 2D. Say we have a circle and we want to find how far a point is from the perimeter of that circle. We can use this function to find that distance. We'll visualize it with this ring. This is known as a signed distance field, because outside the object we get a positive distance, and inside the object we get a negative distance. If we have multiple shapes in our scene, we can find the distance to the nearest one by using the min function on all of their individual distances. Now that we have a scene represented by a distance field, let's imagine that this point is our camera and we want to see if it's looking at anything. We can do this by sampling the distance field at the camera's location and moving our point by that amount. If we repeat this process and eventually get a distance of 0, we know we've hit an object. If we sweep this line through each pixel on the screen, we'll form an image of the signed distance field. All of this happens in the pixel shader. Let's see how that works. On the left, we have ShapeUp, and on the right, we have the OpenGL shader code it generates. As soon as we add a shape, this function gets populated with its first lines of code. This code doesn't have to change while we move the camera or edit the shape, but as soon as we add a second shape, the shader gets regenerated. You can see here that the selected shape gets its values from uniforms, while the unselected shapes have hard-coded values. If we had to recompile on every edit, ShapeUp would feel very laggy. Let's talk about how mouse selection works, since blobby and cutout shapes make this a little bit complicated. When you click in the editor, we render the model off screen and give each shape its own color. That way, we can look at the color of the pixel at the mouse's location to determine which shape is being selected. The nice thing about doing selection this way is that mirrored and blobby shapes just work. When you're finished with your ShapeUp masterpiece, you can export it to an OBJ file that we can import into any 3D program, like Blender or even Cura for 3D printing. To do this, ShapeUp converts the signed distance field into a 3D mesh using an algorithm called marching cubes. Let's see this in 2D. We start by sampling the signed distance field on a regular grid, checking if each point is inside or outside the shape. Then for each grid cell, we add polygons based on how many points are inside the model. All 4 points is a solid square. This is 3 points, 2 points, and finally 1 point. We can make this look much better by using the distance field to weight the new vertex positions. We can also change the grid size to better capture detail. And this algorithm works the same way in 3D. Here's some numbers while you watch this animation that took forever to make. ShapeUp is 1,500 lines of C, 300 lines of GLSL, and the only library it uses is Raylib. You can try ShapeUp in your browser on my website, danielchasehooper.com. If you're a graphics fan, reach out on Twitter. I'm Daniel C. Hooper. Thanks for watching.
8 months ago, ChatGPT was starting to gain a lot of traction. They'd amassed a huge following of users, and it seemed like it actually had a little bit of intelligence. And then around that time, related to that, I had an idea for a game. But I had already been working on a game called Asterisk for many months at that point. It's a space game. And so I said to myself, okay, but this idea that has to do with ChatGPT, it's so potent, so powerful, I just have to take a week or two off of this project to just finish this game, because it could be really interesting. And so I temporarily shelved Asterisk, the space game, to be returned imminently, within the next week or two. And so I started working on this quick side project. What is it, might you ask? Well, it's trying to be an RPG where all the characters are controlled by a ChatGPT. So you can say anything to the characters and then they can do anything in response. A couple weeks later, and this is what I had. A few things to notice. There's no ChatGPT action happening at all after 2 weeks. It's basically just a tech demo. I read the commit history and it just took me a second to, figure out like the text wrapping and stuff. And, so this is what I have after a couple weeks. And so I was like, okay, it's been past when I thought it was, but I put all this work in. So, I might as well see it through. I should keep working on this just a couple more weeks and I'll get the AI stuff in, and the game will be really interesting. A couple more weeks later, and this is what we got. It's like, wow, there's combat, I can hit this guy. He's trying to hit me, I can dodge. There's real consequences to this game. And, I can actually talk to the characters. Let's see how smart they are. I'm a simple old man minding my business, that is until you came along. Wow, it seems like that this game is not a, failed project. And then, that's what I have after a couple more weeks. And so I said to myself, okay, there's not much depth to the conversations you have to the characters. It's usually pretty shallow and just kind of like, oh, haha, it's an old man, and it kind of autocompletes. It's what you'd expect from something that's kind of low effort. And then the actual gameplay is unrelated to the text generation. So, like, the old man shooting bullets at me is completely unrelated to his intelligence, text or story-wise. And so I'm like, okay, I need some more time to add depth to this game and to flesh it out and add more characters, add more enemies. It needs content and systems, right? It's lacking a lot for, like, being done. It's not really a game. And so at this point, it's already been delayed, twice. And so I'm thinking, like, all right, I'm a little ironic about this project. I'm like, okay, we're going to release on April 1st. And my thinking is like, okay, if I miss April 1st, then it's an April Fool's joke. But if I don't, then it's real, and, that's when it releases. But in any case, trying for April 1st, right? And again, this is just a side project. Once this is all over, we're going back to the space game that is, much less experimental, much more solid. Not, it's more high effort. It's trying to be a normal game. And so come April 1st, and this is what I've got. I remember the exciting thing about this version of the game, I could ask it what I'm holding, and it can see what I'm holding. You were holding the white square. It's a white square. So it's not that interesting still, kind of, right? But, maybe, certain characters can like certain items or not. That was supposed to be the interesting idea behind this. It's still kind of not done. Like, the art is really messy, and, like, the game is just still kind of meh, And a bigger thing is the combat has nothing to do with the talking still. And there's just this talking rock. This was the most interesting part of this game. But so now it's like, okay, this project is a disaster. It's running out of control. It's April 1st, and, like, it's still not done. And so I just need to work on it for even longer, I guess. I don't know. I didn't even have a release date at this point. I'm just going to be like, okay, it's going to be done in, like, a month from now or something. I'm just going to be like, okay, next month, it'll be done. And so, May passes, June passes. There's now all sorts of stuff in this game. The combat has been taken out because the AI didn't understand combat. There's like a million characters. There's like a king you're trying to go to. And still, unfortunately, it's just, there's a whole item system. It's just not that good of a game. It's just not that good. Like, you're just kind of talking to people doing like little fetch quests. And then it's kind of it. It's not that interesting. It would have been reasonable to stop by now. But instead I decided to write a 3D renderer from scratch because I couldn't get the pixel art aesthetic to work well, I decided. And I just continued to iterate on the AI. Yeah, at this point, the schedule is deleted. It's gone. There is no schedule. And that brings us to modern times. I'm working on a whole level editor that will be accessible by you, the player. There's a whole bunch of 3D art, a lot of stuff going on. There's shadows, by the way. And we're in the middle of a massive art migration right now that will be completed later this month. I think I found a way to make the characters interesting to talk to and get to know. And I hope you will find it interesting too, because you can play it right now on your phone at dantescowboy.com. And I hope to finish with this project in just a couple more weeks. I'm almost done. Actually, okay, I'm actually not doing it longer. There's a whole map and some more characters we're making, and then I want to make it so that you can edit your own characters, and then I'm actually done. Like, I can't work on this anymore. Unless it's like really good, I can't work on this anymore.
love 90-minute lunches. I don't know about you guys. That just gives you extra time. I'm seeing so many thumbs up. I love that. And welcome to Handmade Seattle once again. I know there are some new timers. I was just getting some emails, some DMs from people who were completely new to Handmade on the online track. Welcome to the conference. Welcome to Handmade Seattle. We are all about software quality. We are programmers. We care about building good software for users. And even if we disagree on that definition of good, that definition of quality, we all come together to care about that. And this morning we had a lot of interesting conversations, a lot of spicy takes, awesome stuff. But we also want to nerd out with actual demos and actual presentations, actual software projects that people are doing. And I want to start us off. This is going to feel almost like a movie theater. This was like a movie theater here. Okay, we're gonna be watching some demo presentations from some interesting software that people have been making. And we're gonna start. Our first demo is a text editor, which is interesting because in the Handmade community, I'm seeing some laughter, a very common project for a beginner at Handmade is to make their own text editor or IMGUI library for some reason. I still don't understand that, but like we have thousands, not thousands, but like dozens of IMGUI libraries and dozens of text editor projects. So I've always been a little hesitant to, I welcome every project, right? But it's like for the conference, I'm like, okay, this is the 37th text editor. Maybe I should try something. But this demo from Cameron, who attended a Seattle meetup recently, wow, okay, text editor it is. This is interesting. So let's give a round of applause and yeah, a whooping woo for Fred, the editor demo.
Hi, I want to take a couple of minutes here and talk to you about a text editor I've been working on named Fred. Fred is a text editor which aims to be good at one fundamental thing, editing text. Fred is designed to be a fully featured, friendly, and intuitive text editor with many familiar features present in other text editors, and a few which aren't, but we'll get to that later. I started on this editor with the goal of making it my daily driver for anything text editing related. Fred was birthed from an observation that I was using different text editors for various tasks. There was no real unification because each text editor independently had a feature I needed, but none of them had enough overlap for me to stop using one over another. Thus, my idea behind Fred was born, a text editor for me and potentially others too. One success metric I have for Fred is that it needs to be fast, very fast. From startup time to the point where a file is navigated to and loaded should be kept to a bare minimum. Syntax highlighting should also be as fast as possible, which is one reason I chose Tree Sitter as a syntax highlighting mechanism in Fred. Editing itself should be instantaneous anywhere in the file, and I'll talk a little bit more about how this is done later. Fred also has great support for UTF-8 and will actively attempt to load fonts capable of displaying a specific glyph requested. All of Fred's internal text encoding is UTF-8, and the system will simply convert the internal encoding to whatever the destination file encoding was on save. This is a design choice to make the editing experience more consistent and simple, no matter what the source encoding was. At my day job, I often work with files that are multiple megabytes in size, e.g. hundreds of thousands of lines long. Text editors like Notepad simply choke on files at this size, which really isn't even that big. Fred is capable of loading these types of files instantaneously and begin editing or searching for terms. The incremental searching mechanism in Fred is multi-threaded and capable of searching multi-million line files well within frame time. Jumping to the middle of this nearly 700,000 line file is no problem for Fred, and we can begin editing arbitrary text just as quickly. Suggestions for identifiers are a simple fuzzy text search algorithm for now, but it is fast enough for these million line files that I haven't ran into any problems. We can even go to the end of the file and start deleting large chunks without losing any syntax highlighting or frame drops. I think it's at this point where I need to take a step back and explain something about Fred and a journey I took which nearly broke me. Let's rewind the clock back to summer of 2023. At this point, Fred didn't have many features it does today, and, more importantly, the underlying buffer was simple. Too simple. In fact, if you opened up a file larger than 1 megabyte, it would almost certainly be a painful experience because the text was a single giant string, and editing required lots of byte shifts on each character insertion. It was a painful experience. What made the entire thing even worse is that I desperately needed a feature I was used to all the time in text editors: undo and redo. So I had a choice. Keep Fred as is and have it be a subpar editor, or do something entirely different and crazy. I think we all know which path I chose. Enter FredBuff, the culmination of a month-long research project for me into the perfect text buffer for Fred. I thought this buffer was so important that I even blogged about it on my personal blog, which you can go and read today. But let's talk more about what FredBuff buys Fred specifically. Let's say you start editing a text file, something like this. You make a mistake. Hit Control-Z, and you undo it, and now you want to go and write in what you wanted to write before. But that's actually wrong too, so let's try again. And that's actually wrong, so we actually wanted the first thing, but in order to get back to the first thing, you would have to re-edit the same text file, because traditional undo goes undo, and then if you try to redo, you just get Joanne back. But in Fred, you actually have a running history of all of the edits that you have made in the past. So we could navigate to any one of these branches. Because the data structure supporting Fred is purely functional, we can actually just store every possible state that we have made in the past. So every edit that you've ever made in Fred in that particular edit session is persisted due to the fact that it is a purely functional data structure. So we can navigate back to mistake, we can navigate back to Fred, and we can navigate back to Joanne, or just go back to our initial state. There are lots and lots of features I would like to dive further into. Features like spell checking, multi-cursor editing, config updating, Fred-specific shaders, but this is what I have time for now. But feel free to reach out to me on Twitter or Discord if you would like to talk more. And happy editing.
Fred is one of the few folks who may not be here with us in person. And as you know, fully hybrid conference, there's a storm, there's a lot going on. So what we're gonna do is play a little bit of music here, okay? And some of you who have been here in previous years, you know this is an unusual format for a conference, but it's fun. It's like a movie. You watch this demo, and then on the chat server we have Fred, the creator of Fred, just for 5 minutes. Just say your thanks if you're on the chat. Just ask any questions that you might have, and then we'll play the next demo because we have many more. Okay? Just 5 minutes, just chill. So much better than Matrix, by the way, right? The chat. You're welcome. Three minutes. 3 minutes. One minute. Remember, you can send a friend request to people. You can DM. All my presenters are very willing to talk to you in private as well. I haven't done a single Choco Vine or Majora's Mask reference today. Whoa. Gotta fix that. 30 seconds, and we're gonna move on to the next demo. 30 seconds. Okay, great. I would love to give one more round of applause to Fred. Yabba dabba undo, apparently. Guys have a knack for quips. I like that. Our next demo, who I believe might be also online, you let me know. I'm going to see if I can track the person down, but I do think it's online. It's also amazing. It's I'm not even sure how to present it. This is one of those demos that just rekindle your love of what's possible with computing. And not to sound too vague, but many of you, I'm sure, have grown up playing, I don't know, it depends on your age, but like retro consoles, PS1 and Sega Dreamcast and all of those things, and GameCube. And can you imagine what's possible, especially with the more you're into programming, the more you're into digging into how things work behind the scenes, low level, et cetera, you try to squeeze performance out of old stuff in a way that just shocks, right? And this is one of those shocking things that I just had to make sure there's a demo for it. So this is called the Meese engine, and I am just gonna leave it there early. Meese engine, like what's going on? The user, I think, has the name Meese on him. He loves moose, so that's also interesting. There he is. He just said Meese. Thank you. Round of applause for the Meese engine.
Hey everyone, today I'm excited to share an ambitious project I'm working on, remaking Minecraft for old consoles like the GameCube, Wii, and Dreamcast, as well as for PC. Now, you might be thinking this is just another Minecraft clone, but let me set the record straight. My goal is to go far beyond Minecraft. This is an entirely new experience in the making. Right now, I'm using Minecraft Beta 1.7.3 as a design reference, but once my engine's built, every Minecraft asset and mechanic will be replaced. If you're into modded Minecraft, like TerraFirmaCraft or Feed the Beast, there's a good chance you'll enjoy this game, but it's going to be something truly different. The challenge? Getting a Minecraft-style game to run on old hardware. Let's talk about the GameCube. This console came out in 2001 with a 485 megahertz CPU and just 24 megabytes of RAM. That's a fraction of the power you'd find in even low-end hardware today. Yet, I've managed to cram 25 million blocks into only 8 megabytes of that memory. And what's even more exciting? The GameCube version of my engine surpasses the render distance of Minecraft on newer consoles like the PS3, Xbox 360, and even the Nintendo Switch. Let's not forget the Wii. With my engine, the Wii version actually surpasses the render distance of Minecraft on much more powerful systems like the PS4 and Xbox One. Then there's the Dreamcast. Released even earlier in 1998, it runs at 200 megahertz with just 16 megabytes of RAM. That's an even bigger challenge. The Dreamcast CPU has to handle transforming every single vertex from world space to screen space and apply lighting in real time. And finally, there's the PC port. While this version is still unoptimized, it's already boasting an impressive render distance of 64. So even in its early stages, it's pushing some serious boundaries. And here's what will make this game special. It'll be a highly dynamic world with tons of combinatoric gameplay. Seasons will change, impacting things like plant growth, animal behavior, and resource availability. Weather won't just look different, it'll have lasting effects, shaping the environment over time. This world will evolve with you, so every action or change will have a ripple effect. As for a release date, well, That's still TBD. I'm only working on this in my free time, so development is moving at its own pace. But here's what I can promise. Once the game reaches a certain level of complexity, I'll release an early alpha or pre-alpha version for people to try out. That could happen as soon as next year, or maybe the year after that. I'm excited to share it with you when it's ready. My ultimate goal? To build a game that's unlike anything you've seen, pushing hardware to its limits and showing what's possible when we design with efficiency in mind. If this sounds exciting to you, stay tuned. This is just the beginning. Thanks for watching.
Woo! He's one of the few lucky handmade people where the algorithm overlords, right, were pleased with him and got millions of hits on social media and everything. So this is has a lot of mainstream appeal at the moment too. Well done. Same thing, 5 minutes on the chat server. Let's give a round of applause again on the chat to Meese. And just 5 minutes and we'll continue our presentation. 1 minute. All right, once again, both here in the audience and on the chat server, round of applause to Meese Engine. That was amazing. The music, oh my God, I had never heard that music before. I guess I'm not a Minecraft player. Apparently it's a Minecraft thing. So interesting reference there. Very cool project. And once again, you can DM these people, you can send them friend requests, you can talk to them some more. There's obviously multiple channels in the server. You can take the conversation wherever you'd like. That's awesome. And now it's time for our first talk of the afternoon. This is gonna be exciting. So how many of you, just as a curiosity, I'm gonna keep asking you questions to raise your hand, like we hosts like to do, 4Coder. Anybody who's heard of 4Coder or has used 4Coder, look at that. Look at that. Okay, so the creator of 4Coder is gonna be our speaker this afternoon. This is the text editor, as we call it, for the Handmade community. Handmade Hero, for example, used it as the official text editor for their series. It's just amazing. It was a wildly popular software that he sold for a long time and then open sourced it. He's also worked under Casey Moritori. I think he's the only community member that I know who actually worked under Casey, worked under the company behind Handmade Hero himself. And he also then worked for Rad Game Tools, which then got acquired by Epic. And shortly, for whatever reasons, I'm not going to disclose, that's his life, he left Epic and started his own business, just like me, like trying to run his own thing, his own little small thing, called Mr. Fourth Labs. So if you're interested, that's mrfourth.com. He did not ask me to promote this. I'm doing that he's a good friend. I want to promote that. Somebody can put it on the chat server. It's a great way to learn about low-level programming in a very different way. He has a lot of ways to generate content and education. That's really interesting. He's very creative too. How can you be creative because 4Coder is very customizable, it's very creative. He's done really creative projects on the side, but he's a low-level programmer, right? Like he's a systems programmer, and you don't usually consider a low-level person to be like super creative in that space because it just feels so hardcore rigorous, right? So like, how can you be creative while still staying low-level and care about quality in that way? When usually when you try to be super creative, you usually bring in huge packages and frameworks, and it just gets, wow, like how do you still stay like performing and all of these things, and lots of other questions. So this talk is titled Creative Exercises at the Low Level. And let's give a round of applause to Alan Webster. I'm gonna be using LH1 for this one. LH1, microphone 1. Testing.
Okay. Well, hello. Thank you, Abner, for the introduction. And yeah, I'm going to be talking about some really low-level stuff, so I hope you're ready to grind through some low-level details. But I think there's a payoff, which is when we do that, then we can play with it and we can imagine new things that we couldn't have done if we didn't equip ourselves. So let's get into it. First of all, why I wanted to give this talk. For one thing, this is a topic that, believe it or not, a lot of beginners to C ask about, which is what's the deal with the object files and the linker? It only ever shows up when something messes up and I don't know why it's there. I don't know what extern and static variables are. And so it's been on my mind a lot to figure out how to explain why some of these things are the way they are. But another big reason is I've been spending a lot of time on this at the Mr. Fourth Lab project. Since July, I've been deep diving into these formats, and I think they seem like things that are from the past, right? They're legacy, their new languages tend to obscure them or make them completely irrelevant. And so you don't have to know about them. And when you don't have to know about something, you usually get away with not knowing about it. And you might miss out on all the things you could have figured out or discovered if you did know about it. So I like diving into things that I don't need to know about because sometimes there's still things that are worth discovering. And the other reason I want to give this talk is that Handmade Hero, which brought all of this together in a lot of ways, it is a lot about low-level programming. But if you watched Handmade Hero, the other thing you'll notice that's really important about Handmade Hero, at least to me, is that Casey's playing around a lot. He's having a lot of fun, and a part of what's so inspiring about the series to me is that he's doing really intense low-level programming, and he's having fun and showing how to express himself, or how he expresses himself with those tools. And so I wanted to give a talk that keeps that part of Handmade alive. It's not just quality software, but we should also have fun while we're doing the work we do, right? So the talk is going to be in 3 parts. The first part, I want to give a high-level map, and in particular, it's a high-level map of the total interface that we use for constructing software if you just assume C. And again, there are lots of little tweaks that new languages or new ecosystems will have. The farther away you get from C, the less my high-level map will be relevant to what you're doing. But we need this high-level map as a tool for thinking about things without getting bogged down in low-level details. Then in part 2, we'll build a low-level map. The low-level map will be where we get into specific details about these file formats that I'm talking about. It's still going to be somewhat simplified. I'm not going to get into like reference spec stuff. We're just going to talk about the main concepts of how these file formats function and what they could be doing for us. And then we'll put all of those maps together, and we'll get to those creative exercises and see if we can generate some new ideas. Oops, did I skip one? There we go. So the high-level map part. First of all, we're going to start with some diagrams that look like this. The very first part of our interface for constructing software, in my opinion, is the text editor. It's where we spend almost all of our time. And I'm going to draw some diagrams that look like this, and I want to give you a little primer on what I mean by these diagrams. So these parts here are kind of like types, right? We have text in and text out. They could also be file formats or some sort of phase of the process. Something about the information that we have at a certain stage. The arrow represents a function or a program, the mapping of inputs to outputs, and that usually comes with a name as well. And I'm also, it's important to note, I'm hiding lots of details with this. This is not a UML diagram where I actually write every last detail that you need to reconstruct the code perfectly. It's just a doodle, it's a sketch, right? I'm throwing away things that I don't want to talk about because that's what the high-level map is for. So we can start chaining this little doodle together. I can have multiple steps of text modification, and this is how we get stuff done throughout our days. We're dealing with some text. We have tools that let us take in that text and modify it. Version control, text editor is both critical to the way we accumulate our work over time into a text file or a set of text files. Then we, at certain points, run a compiler on that. We get that object file. Now, usually, if you were thinking about how you think about this, you might just call that the build step, and out pops your program or your executable. But like I said, today we're going to talk about the part that we usually don't need to know anything about, which is the object file. So I'm putting it in my high-level map. And then a separate program, the linker, makes the executable. And of course, you can do that at any time you want. And that was a very high-level map. I can make it a little more detailed, so we can start really high and then drop down. And so I'll start by talking a little bit more about how that top level of the interface, the thing we actually spend most of our time using to modify text, is structured. There's a little bit that I hid that I want to pull out. So I put some screenshots here. The key idea in both of these is version control and text editors both deal with more than one text file. They deal with the entire file system or path system. There's a big data structure containing multiple of these, and I made it look like I was going to ignore that in the original picture, but that's because I'm willing to move between levels of abstraction somewhat loosely. So we can always just remember that in this doodle, we said text, but we really meant this more complex data structure that we're dealing with. And sometimes it becomes important to remember what data structure that we're dealing with. We can fill in more detail about the compiler. Importantly here are not the details of how we, I'm not going to go into compilation stages. Instead, the detail I want to fill in is that the object phase is actually a set of object files, right? At least that's the way it was set up for C. We call each of those a translation unit or a compilation unit. And something I learned from Handmade Hero, and that I think a lot of people adopted rightly, is the idea of not doing more than one of these. The Unity build makes a lot of things a lot simpler, but I don't want to study this subject and throw away the idea that was originally there of linking. And so I'm going to give you a couple of reasons why I think there are still good reasons to keep this around, even if you've shifted mostly to a Unity build approach to compilation. One is you can do different settings on different parts of your build if you split it up in this way. You can have your C compiler enable optimizations for a few key hot loops while you still want to debug everything else. You can also use completely different languages and link them together. And I'm really interested in that part because for once in a while, I'm usually writing in C. Sometimes I have to move to C++ or Objective-C. I'm dealing with system APIs that just want to be in a different language, or I want to hand roll some assembly, or mess around with a different programming language just to see how it works and not build my whole program that way. So I'm really interested in this idea of being able to build things in different ways. It's also sometimes just the case that you're depending on a giant library. You don't want to rebuild it every time, and so having this ability to cache portions and not other portions is a nice piece of this architecture that C gave us. So that's the set of object files, but the problem I have here is that the map I built only shows one compiler arrow. And so again, I want to think abstractly. I could try to fix the map by putting in multiple arrows, but instead, I'm just going to remember that my compiler arrow can stand for multiple applications of the compiler program, and that my object phase is like a set or a list of object files. And then we could try to do the same thing again on the linker. The problem with this one is there's not a whole lot to add. The thing that comes out of a linker is just an executable or a DLL dynamic library, which that's actually the same thing. So I can't do anything to illuminate what the linker is like unless I illuminate more about the internals of the object and executable type. So that's why we need the low-level map too. All right, so first of all, if you are interested in diving deep, like real deep into the subject, here are the formats I'm actually talking about. Each operating system has its own particular format that it uses for containing object data and linking it together to create executables. They're pretty much the same thing, objects and executables. They're roughly the same file types. I put an asterisk here because there's like goofy nonsense, but you can write one parser and generator that kind of handles one of these formats, and you're good to go. So the structure of these files is they start with this header. Pretty much every file format starts with a header, pointers to the other data structures you need to find, global variables. Then there are these data sections. These are the main payload, right? So if you have an executable file, one of these data sections will probably contain all of the executable code in that executable, and another data section needs to contain all your global variables or your read-only global variables. So these sections have names, they have access flags, and they deliver the main payload that makes your program and not something else, right? And then there's these other sections, or I shouldn't call them sections since that's the name we already give to the greener part, but the orange part here is just other data. Depending on which format you're in, different things may or may not live here, but it's there most of the time. And now I'm going to zoom in even more specifically on the object part of the object and executable structures. The object files have a couple of data structures in them that they use to link together. So the first one is there's this symbol table in an object file, And I want to teach you to think about a symbol as basically being a pointer. So specifically, like the low-level version is a symbol has a name, and then a section number, and then an offset into that section. So it's specifying some location within one of these sections, right? Again, a symbol is a pointer, it's got a name, and then it points to some section data. Or it can be external. It can say, I've got a name, and I point to something that isn't in this file at all. It's actually going to come to me from another file. And to emphasize again, these are pointers into the data. That last one, you might think of it as a pointer, but it doesn't exist. You can't point to it from within this file. There's a second structure we need to know about, and I kind of have to teach you both at the same time because they come together to create the whole system, and that's relocations. So relocations are also pointers, but they're pointers in a totally different way. So a relocation doesn't point into the data, it kind of points out of the data, right? So a pointer into the data gives us a location in the data. A relocation says, okay, there's a blank spot in my data. There's 4 bytes, 8 bytes. There's something here that needs to point somewhere else, but I don't know where that thing is going to be yet. So I have a blank spot, and there's a pointer coming out of the data that needs to point somewhere that isn't located anywhere yet. And so we store that as a relocation table. We can imagine the relocation table as being sort of similar, having section numbers and offsets. More accurately, it's usually each section has its own set of relocations, so you don't store the section number. But the relocations need to have a kind, because there are different ways we can make pointers. We can make 4-byte pointers or 8-byte pointers. They can be relative to the position in the file. They could be absolute offsets within the file. They could be actual virtual address pointers, right? They could be all kinds of different things. They can even be section numbers and things like that in special cases. So we're trying to reference something, and we need to encode how big is the thing we're trying to, how big is that blank we're going to try to fill, and how is this pointer being encoded. And then we need to know what symbol it points to. So the second column there is each of these relocations points to one of those symbols, and that's by a symbol index. And then the offset tells us where in the data section the blank spot that we need to fill is going to be found. So to make this a little clearer, because I think relocations are kind of confusing, we could imagine there's like a blank spot in my first section here, and it points to symbol number 2, and it's going to be 4 bytes, and it's going to be a relative offset from wherever the pointer is in the file, right? And same thing here, just a little further down. And so to put the two pieces together, relocations are pointers that come out of the section data. They point into the symbol table. And then the symbol table, again, it's a set of pointers pointing back into the data. So when you put the two together, you've got pointers that come out of the data and go back into the data. So why didn't we just have one data structure? Well, it's because that special external part, that lets us do something that we couldn't do if we were always trying to point back into the data. It lets us link, right? So that's what we're building towards here. The way the linker works is there's a relocation in one of my files. It's pointing to a symbol, but that symbol is external. And then there's another symbol in a different object file that it's linking to that isn't external. And so in this way, you can encode the idea that there's a pointer in the first file that points to something that is actually living in a different file. All right? So that's what the linker's job is to be able to do, is to use this combination of data structures to link pointers across multiple files. And with that, we can talk a little bit more specifically about what the linker's full job is. It's going to take in multiple object files. I'm going to show this to you with the picture diagrams now. These on the left are my object files, and their sections are going to be sort of glued together and rearranged to create a single executable. And then all of those relocations have to be resolved, right? They all have to be eliminated. The executable doesn't contain symbols and relocations. It just contains finally baked pointers. So if you ever ran your linker and you got the super helpful error message, unresolved external symbol, and you threw up your hands and went, I don't know, I gotta Google what this means. Well, at the low level, what it means is there was an external symbol that needed to point to something, and there's no destination for that pointer. You've got a pointer coming out of your data, going to, we don't know, because we don't actually have an endpoint for that pointer. It's an unresolved external symbol. Okay, so that's object files at the low level, and we have that big map of the way the whole system fits together. So we're going to start playing with it and generate some ideas with this, right? That's the goal. First of all, one way you could play with the high-level map is to start looking at it and making changes to the high-level map itself and saying, what if we programmed with a slightly different structure? What if the interface was different? If you know about some of the other work I've done on the interface for constructing software, one thing I spend a lot of time thinking about is, what if we didn't have text files at the top? What if we had something else? That's not what this talk is about, but that's one way that I like to play with the map, is imagining a different data structure that is that through line at the top accumulating my work. But today, I'm focusing on this part of the map, the way the object files work and what we have for constructing and using them, right? So we could take the reinvention approach. We could say, okay, so the object file plays this role of allowing us to piece together things from different languages or different configurations or caching things. We want to use that somehow. Could we reinvent the object file? Yes, we could sit and talk about what kind of thing could go here that would be better. And there's a lot of interesting stuff to discover playing with it that way. But whenever you do that reinvention approach, something that I run into over and over again is when you start reinventing it, there's so many things you have to rebuild. You have to rebuild a compiler and a linker as soon as you have a new type there, right? Just like if I want to replace text, I'd have to build new version control and new text editing and new everything else. If I want a better object file, I would also have to rebuild every single tool and every language that ever used the old system would just be incompatible. So an easier way to transition into finding new ideas that doesn't require rebuilding everything is to just extend the map without reinventing any of the pieces that are already in it. So then the question is, if I want new things going into and out of my object file, as in if I want to generate some or have some kind of input to a program that I haven't imagined yet, what would I want my input to be? How could I generate an object file from something new? And what would be useful about that? And similarly, could I ask the same question going the other way? Can I do anything with an object file other than generating executables? And so the playful part here is to just start filling in ideas and seeing if it sparks any new notions about what could be possible, right? So for starters, I could just ask, what about raw data, right? This is one I always like to start with, which is I don't want to think about a really, really strong data structure with lots of features that are perfect. What if I just start with the most simple thing ever, a raw data blob? Is there anything useful about putting a raw data blob in and getting an object file out? And this is happily something that I've actually already been able to build, and I'm using this right now. So if you have a modern language that's better than C, usually it has some kind of import command where you can take an external file and say, I want to use this as my shader code, or I want to use this as an asset file. C doesn't have that, or if it does, it's super new and not in my version of C. So the cool thing is it's actually really easy to build something that just takes in any file and makes an object file out of it. So on the left here, you've got my program. This is how my actual code base with my own graphics code is working right now. You've got your graphics code over here. It wants to link to a vertex shader and a fragment shader. And then somewhere I have those as actual text files, and I run my little tool. I call it obj from raw. So a raw file goes in and an obj comes out. And I can just bake that right into an object file and link it. So I don't need a language support. No matter what language you give me, if it can link with an object file, I can put my shaders in there now, which I think is cool. It's an option that was always there to solve this problem for C. And I never had a tool like this until a few weeks ago when I was playing with this exact creative exercise and decided to whip this thing up. And it's been fun. I included the link to it if anyone else wants to use it, but it's super not production ready yet. So, play with it if you want, but I wouldn't put it into anything too mission critical. So another interesting idea, again, we're plugging in blanks here, and where I'm getting the ideas for how to plug things into the blanks is, since I'm not trying to reinvent or come up with a whole new idea from scratch, I'm just taking stuff I already have. I already have raw data. I also already have object files, right? I have the ability to make a program with objects as inputs. So what if there was a program where the inputs were objects and the outputs were objects? First of all, I have to figure out what does that mean? Like, what is it doing? The first thing that comes to mind for me is that this maybe is merging object files or splitting them up or something, allowing me to piece them up in different ways. Maybe I could shrink down a piece of an object file that has too much code and just take out the couple of things I actually want from it. But the other thing is, anytime you have an arrow, and we saw this earlier, anytime you have an arrow with the same thing on this side as on that side in one of these doodles, that's kind of like an editor, right? That's the beginning of the editor structure. So we had the thing with text going across the top. I could imagine if I could build an object editor, just having my workflow look like this. And I'm not too excited about that idea because the object files would just be, it would be like a machine code editor or something. Like I'd have to disassemble it and reassemble it every time I wanted to edit with it. But I don't know, there's something interesting to me about the idea of being able to tweak the object file as my way of controlling code and getting entirely out of projecting text into the object file in the first place, sort of like directly making the program. And I don't know that there's anything that I've thought of yet that makes this something I want to build today, but it's on the back of my mind now since I saw this doodle on my whiteboard at one point. And then the last thing I can grab from my original map is executable. And again, I'm just filling in the blank with everything I've got to see what it makes me think of. I don't know if there's any useful way to reverse the process of linking and get something that I would want. But maybe this means something else and I haven't thought of it yet. So if you're looking at any of these and it makes you think, oh, wait, if you can build programs by linking objects together and then you can unlink one of your things, maybe you could do something like, I don't know, XYZ. There's another way you can fill this blank in, which is build your own map, right? I built a high-level map at the beginning of this talk about this particular subject. But if you have a game engine or any other tool or system that you've been working on, and you haven't ever built your own high-level map, I'd really recommend it, because when you build those high-level maps, you get a good picture of where the key pieces of information you have are, and you can start linking up new eras. Like I discovered the one where I can do raw data to an object file. Maybe your asset system could be baked into an object file and linked right in, and that would be useful for you. Or I don't know, you'd have to build your map and see what pops out to you as something that could be a direct interface for constructing software, rather than having to go through some kind of metaprogramming or whatever it is you're doing to link your data into your code right now. And then we can run the same experiment the other way around. I'm going to run through these faster because I haven't actually thought of very many useful ways to interpret the first two blanks yet. So the third one, though, is another example of how you can generate ideas. We already have object to executable and object to object. So if you want to keep generating ideas, another thing to keep in mind is you can always take types that you have and throw them into larger compound types. And this one, I think, is a little more interesting because a linker, as I said, is a tool that takes in multiple object files and spits out one executable. And the whole model of executables always seems a little strange to me because it contains all this code and it's got this one entry point. There's only one thing it can do, and we make it do more stuff by passing things in. But a lot of times my projects involve lots of executables with semi-overlapping pieces of code, and I kind of wish I could think about them a little differently. I wish I could say something like, hey, here are all the object files that I've got, and here are the set of entry points that I care about. And could you generate for me a bunch of files that I can use as endpoints for calling that, and then figure out how to split up a DLL so like we can remove redundancy, we can optimize out which pieces are duplicated and which pieces aren't right there in the linker, right? I'm not sure how important that is to me, but it seems a little more interesting than the other ideas that this particular process generated. And then there's the heavier duty approach. So far I was just doing the what if we stuck new stuff into the map. At some point, there's only so much you can do if you're not willing to get in and reinvent something. But we can do some amount of reinventing by incremental steps. So 3 ideas I have for reinventing object files that I either have explored a little bit or am really keen to see explored are, first of all, could we restructure this object file in some way while maintaining its spot in the high-level map, right? So the high-level map tells us how the object structure relates to everything else that we use, right? We know which programs create objects, we know which programs consume objects, and could we leave it there and not change the high-level map at all, but restructure the internal low-level details, right? Could we restructure the low-level map? And so looking at the structure of an object file, there's something up to me a little bit old school about this whole thing with data sections and then symbols pointing into them and relocations. It feels like not something I would have designed, right? It's just a little different than the way I think about things. It seems to me like sections and symbols could almost be redundant to each other because they both have names. The symbol is a pointer into the section, but the section can be relocated freely. What if each section was really small and just had one symbol pointing to the beginning? you'd end up with something where you just have a collection of symbols, little data blocks, and pointers between them. And that has the nice property that it simplifies things just a little bit. I'd no longer have to figure out, okay, is this symbol that I'm looking at overlapping with this one? Can they shift together? Is there a dependency that is, when you have a data section that you need to preserve because some of it's being used, but not all of it, there's no way to figure that out unless you were to split it up into a smaller granularity with something like this, right? So this is like a pitch for, I'm just sketching out an idea of like maybe an object file could have been like this all along. Little tiny data blocks called symbols. A pointer would be a thing that comes out of one source symbol and links up to a destination symbol. And then this file would be a lot closer to just a directed graph, right? There wouldn't be this third thing of there's a directed graph, but also there's a relationship between some of the nodes based on which section they're in. It would just be cleaned up like this. And once you have a directed graph, there's plenty of cool, easy to write computer science-y algorithms that you can use to process this graph. You can eliminate the parts you don't want. You can handle it yourself in all kinds of ways. It'd have to be simpler than what we have to get there. But there's also, whenever you're reinventing something, make sure to ask yourself, what am I breaking? Is there something that I don't know about that relies on that third data structure being separate? I spent enough time thinking about it that I think at worst, this idea, this one here, at worst this might complicate some weird edge cases, but I think that this would have been a better object file. Another way you can approach a reinvent it type of creative exercise is what's something that's broken about it. And I haven't dropped this yet, but now I will. The name mangling thing is totally busted. I don't know why we haven't bothered to do anything better than this. So if you don't know the history, C++ evolved out of C, and it used the same linking method as C. So all of this is still applying to C++. But C++ adds function overloading and namespacing and templates and all these things that make it possible for two symbols to have the same name from the language's perspective, but to actually be different pieces of the program. And so the linker needs some way to name them differently because its only way of linking up two symbols is for them to have the same identifier. So the way C++ solved the problem was to say, in a non-standard way, your compiler should generate some kind of mangling of the name that is unique for that particular namespaced, overloaded, templatized version of that symbol. And so if you ever ran your linker on C++ code and got an unresolved external symbol, it probably included this. And when I say it's broken, I want to clarify, I'm not saying that it doesn't get the job done. Because again, if you don't need to know about it, you usually don't have to, right? You never force yourself to know why this is happening. But this is such an unpleasant interface for constructing software that the first time you see it, you decide you never want to have to know what the linker is doing. And so if we care about being able to enjoy our jobs as programmers, if we want to be able to play, this needs to be better. And so the question is, how would you go about fixing it? I have a couple of ideas. There's ways you could fix it that are super hardcore. There's ways you could fix it that would just be like throw a display name on it that is separate from the linking name. Maybe it would also be nice if the language actually made a standard way to mangle the names instead of saying each I don't know if I said this part yet. The symbols on the left and the symbols on the right are generated from the same code. It's just two different compilers. So if you ever were to accidentally be using a mixed tool chain and not catch that you're doing this, you'd get failure to link just because two different tool chains decided to mangle your names in different ways. Another thing that's really unfortunate about doing things this way is if the symbol names were going to be useful, for instance, if you wanted to create a list of all the functions just so you could observe, say you're making something to load in an object file and list out the functions that are in it so that it can be used as sort of a plug-in generator, right? You might want to be able to say, all of my command functions are going to need to be listed so that I can know where they are at dynamically. Well, these symbol names are useless for that purpose. So fixing all of that would be an interesting way to reinvent the object file. And then there's my upgraded approach. So the upgraded approach is it's going to stay in the same spot in the high-level map, but we want it to do more than it did before. And there's a lot of things that seem possible. The first one I put on here is not so easy. It's could we change the object file so that it's good for direct editing? I've thrown that out there a couple times. There's the the chain of objects and editing them directly, I'm still puzzled about how I could make that useful if I don't change the object file. But if I allow myself to go into it and go, well, I want to make that work, I would need to be able to answer, how am I going to do version control, which requires diffing and merging, and could I edit something better than assembly in the process? Is there anything that I could do to make this format a little more amenable to making an editor for it? The next idea that I'm holding on to all the time is, what if I could just load my object files instead of having to link them in the first place? And the reason I might like something like that is actually something that was inspired by my work on 4Coder. So in 4Coder, one of the key feature, I think, was probably the customization system. And so there'd be code that you'd write in your custom layer that looked something like this. At the top, I'd have a macro for naming the function and another macro for putting a little documentation string, because this command, move right, and that documentation string are actually a part of the human-facing user interface, right? I'm going to have a list of commands that you can bind to your keys. I want you to be able to see the name of the command is move right and a description of the command, and I want to link all of that information together with the executable code that describes how that command is supposed to operate, right? And so the way I solved this was, well, so the problem is, how do I get all that metadata together? And metadata comes from a metaprogram, right? That's what I thought. So I wrote a metaprogram, and it makes the process of building your custom layer a little more complex. You have to use a script that I wrote that knows how to set up and invoke the metaprogram, and then it generates the extra data you need. And once you've done this extra build step, then you run a normal build on all of that code combined. And that works. It gets the job done. But it did take a while iterating on that, and it feels to me like the way we build software is not very amenable to making things like customization systems, plugin systems, dynamically piecing parts together just doesn't work at the low level. And that's not because low level doesn't work that way, it's because the object files don't work that way, right? We could have built object files that work a little differently. We could have said, what if I can just load that object file? I don't even link it, I just compile it. And now, at the very least, the symbol name will be preserved. There might still be something I have to reinvent, right? Because if I want to link in the documentation string, it's not clear that C gave me a way to do that. And so I might want to go further and say, maybe I should be able to take a symbol, and in addition to being able to load that in dynamically, I should also be able to tell the language that a symbol, in addition to its main purpose, is going to have other data attached, like documentation strings, or I might want to be able to just tag some functions as this one is a command and this one isn't, so that when it's going to make that lister of all of my commands, I can just load that out of the object file. That's something I always dreamed about having at that stage of 4Coder, and all of that would require a model where I can load the object file as if it were a DLL instead of linking it into a DLL. But to do that, I would either need to modify the object file a little bit, or at the very least, spend a lot of time building that loader. And then another interesting topic is, could you move compiler optimizations to the linker more easily if the objects were designed differently? So this is a topic that would move us in the direction of talking a little bit more about how the compiler works, right, and where optimizations in the compiler live. But a lot of the time, we don't stop to think about what our intermediate files are, what they represent. And so I get really puzzled by the fact that the compiler does a front-end pass that generates this sort of intermediate representation internally, and then a back-end pass that optimizes that. It figures out where to inline its functions, it figures out how to unroll certain loops, it does all the things the compiler does to optimize, and then it generates an object file. And then when we go to link things, we have these sort of boundaries where it's like, well, because this was a part of this library and that's a part of that library, the helpers that this thing is using from that thing can't ever really be optimized in that way very well. The most the linker can hope to do is to sort of walk that graph sort of structure that we saw earlier and eliminate some dead stuff, maybe remove some redundancies. But if the thing that came into the linker was actually the compiler's IR in the first place, we could start to imagine, or I like to imagine, that we could get to a place where I could use multiple low-level programming languages with different strengths and weaknesses and link them together, knowing fully well that it's also going to optimize all of them together correctly, right? But in order to do that, the object file would have had to be a little more high level. It shouldn't have been machine code. It should have been the compiler's IR that I'm linking together. And just as a final note, this, if you do chase this down, is not a new idea. This is the beginning of like a JIT-based system. And JIT-based systems are probably the right way to solve a lot of the gripes I have. with low level in general, except that you'd have to talk to someone who spent more time studying the compiler part of this to understand why we still use languages all the time that aren't super jitty. So that's the bulk of my talk. I want to conclude with returning to this high-level map and encourage you, I already did it once, but I want to encourage you to draw these for your programs. This is something that I've only been doing for a couple years, and I never regret doing it. I always spot new things. I always discover that I have a little bit more cruft in the design than I thought, or a little bit overcomplicating how it works in my head than it really is. And this map here is exactly what I'm thinking about all the time now for whatever problem I'm working on. And the other nice thing about these maps is they scale really well in terms of abstraction, right? I gave you a very abstract map with tools, whole programs as the arrows and phases of the interface there, which are sort of collections of files as the endpoints. But these arrows and the things between them can be as specific types in your particular algorithm or in a architecture for a game engine or whatever you're building. If you can identify the types and the main maps between them, and then you can ask yourself, well, what are the details I hid here, and elaborate on them, you'll start to build up a different perspective on what your code and what your architecture is. And similarly, if you're not doing this, I find a lot of value in drawing these kinds of diagrams as well. A low-level map like this that isn't literally getting into the spec, right? I haven't gone into the PE-COF spec and told you about all the little enums and structs that need to exist, but I've figured out what the main data structure is that I need to think about, and I've figured out how to visualize that for myself. And every time I do that, I discover more possibilities, like the idea of sticking a chunk of data into my program by putting it in a separate object, which pops out of looking at things like this and looking at the high-level map at the same time. So I guess what I'm saying is, if you are doing a lot of programming and not drawing pictures of your program, I'd recommend looking at it sometimes. I get a lot out of it. And finally, thank you. Thank you to Abner for letting me come and talk about what I've been researching for the last 5 months, and to all of you for listening. That's everything.
I'm going to use LH1 and LH4 microphones. I loved the chat as you were talking, lots of questions that came through. I'm going to have to kindly request people to pose your questions again, because the questions were going through commentary as well. I don't want to get too lost. But I want to ask you the first question here. Okay. So, because one of the things you did while you were at Rad Game Tools is, you have to do this kind of thinking a lot, because you worked on the Rad debugger, for example.
Yep.
And so linking is bread and butter, and so many other things. And by the way, for those who don't know, Rad is one of these companies. You guys know that the PlayStation 5 has instant loading speeds right now. That's thanks to Rad Technology, the company that he was a part of. Right. Do your coworkers also think deeply about these things as part of their day-to-day?
They think deeply in their own very unique and interesting ways that I couldn't comment on. But they're very smart people, yeah.
Okay, so let's look at the questions here. By the way, chat server, please. I'm trying to give the online audience, especially many people because of the storm couldn't make it, I'm trying to do it through the chat as much as possible. I appreciate the people here allowing that. So, first question. From Professor Sil Taylor, hi. Do you have a name for these diagramming systems?
Yeah, so I didn't spend a whole lot of time besides just the intro about the idea of types and the arrows between them. I call that an information flow diagram because I'm specifically trying to map out where information starts and what paths it takes to get to wherever it goes. So I call that information flow. There aren't a lot of rules to it. Like I said, it's kind of a doodle. It's the beginning of a creative exercise trying to comprehend how things work. So when you ask what this diagram system, it's very much not a system. It's more of an art style.
Love it. A question from Caleb Barg. Thank you, Caleb. Where did you get the idea for drawing high-level maps?
Okay, I'll answer that. The idea is it's a combination of a bunch of little things that were sort of going on in the back of my head over a long time, but a couple of key things are a more low-level and rigorous version of what I showed you is called a data flow diagram. And in a data flow diagram, you would take what I did and you'd get very specific. You wouldn't be throwing together loosey-goosey like, here's a program, here's a function, but you'd start from the level of instructions that your machine can run, or an abstract model of your machine can run. And then you're assigning the cost of computation along the way. And I learned this from Fabian Giesen, one of the Brad employees. Yep. He has a blog post, something, a whirlwind introduction to data flow, something, or something. I'm forgetting the name of it, unfortunately, but it's a way of thinking about performance in asynchronous computing. And he shows how to apply it at the very low level of out-of-order CPUs. It also works for multi-threaded asynchronicity and stuff like that as a way to figure out how long things take when some stuff can run in parallel, but some things need to join up later, and especially when they need to happen in loops and things like that. And so that's a part of the inspiration. Another part of it is category theory, which I'm not...
oh boy.
Yeah, I'm not
highfalutin math there.
Yeah, it's a math subject, and they draw these diagrams that look like mine with the names of not types, but essentially like sets or types or something like that, and arrows between them. And this isn't really the same as that because I'm not talking about the math of it. I'm just using it as a doodling mechanism because when I learned a little bit of category theory, I really liked the way they turned their math into these doodles that were useful for them to comprehend what they were talking about. And I found that there was a sort of correspondence to what I do as a programmer and needing to map out what I'm thinking in a visual way. So I think those are the two main influences.
Absolutely awesome. Oh, this comes from the creator of Fred, who I think was inspired by 4Coder too. The question is, how does debug information factor into this whole process?
Yeah, I left that out from the main talk on purpose because it's very different depending on which operating system you're in, how that part of the information flows through. Ultimately, what happens is those object files that the compiler generates, they have to carry the debug information too, and then the linker has to repackage the debug information, and so the whole system of relocations actually applies to that information too, because weird stuff happens, like you want to have debug information say, okay, we're going to tell you where your global variable foo lives in your final program so that the debugger can actually read that variable and display it to you. Well, we don't know where it's going to live until the linking process happens, so all the debug information has to be encoded and then patched up the same way everything else does. So some of it flows through the same thing of relocations and symbol pointers. Some of it is a totally separately encoded thing that lives in the files, and then the linker has to, depending on what system you're in, you package it into a different data structure or into the same one. It's a lot of stuff. But yeah, the debug information is flowing through those object files and handled by the linker too.
Awesome. Next question from Mr. Colin. Oh, Colin, hi. What's next in tool chain tinkering?
Thanks for that question. I have a lot of hopes to get into other things that I could compile besides text files, as I've talked about. Some of it I don't want to comment on because I know someone who's working on the exact thing, and I'm kind of helping them along in their project. So there's cool stuff like that coming along. There's another big thing I've been working on personally, which is a more useful way to visualize these files in detail. So I did a Handmade Network Wheel Reinvention Jam project on that subject, and I'm still working on it. The basic idea, though, is to be able to make some kind of library of visualization primitives that are not just visualizations, not just for making a picture, but for making it searchable and indexable and all of that kind of stuff, so you can browse through what's in these files. And then, since there are so many different formats that are opaque that I need to be able to see, some kind of plug-in system for parsing these data structures and turning them into that sort of indexed visualization of the same data.
From AXN JaxN, username. Since everything along those arrows is effectively a sort of compilation, why do you think compilers are so crummy? They should be central.
Okay, so I'm going to pick that apart in a couple of ways. I'm not sure.
He did say, I also recognize you may not think they're so crummy, but I do.
Yeah. I'm not sure that all of the arrows are compilers. If you think that everything that takes in input and sends out output is a compiler, that's fine. That's a renaming of the thing. I think of a compiler as something a little more specific, especially a text editor which takes in, like, has a live UI loop and user input. That's not very compiler-like. I also don't know why, if you think compilers are crummy, I don't know why the particular shape of the map I gave you would lead to them not being crummy. Like, the map is just the main architecture. You could put anything you want in the compiler. And the third thing I want to say is, I didn't go into the compiler part today, partly because I don't want to talk about programming languages. I don't find it, it's just not something I've spent a lot of time like learning about. Like, you know, obviously languages are an important part of the interface we have, and I feel like everyone else who's worked on our interface has mostly done it by coming up with new language designs and improving the compiler part. And I wanted to show that whole high-level map to show the compiler isn't the only piece we could tinker with in the interface that we use for constructing software. The compiler plays an important role since it defines the mapping from text down to execution, like executable models. But I kind of want to find a way to build software with an interface that doesn't work like that. So I don't spend a lot of time thinking about that part.
And there's a podcast by you and the creator of Odin and the creator of Zig that you had this podcast conversation that kind of blew up in our niche circles on YouTube that you can check out. I hope somebody can link it. So you can go dig deeper into this thought process that he has about the boundaries of language design. Mm-hmm. Yes. Next question we're running out of time, I'm sorry, but try to get through a couple more. From Voran, thank you for your question. Let's hope you drink a little in, it's a long question. The flow along the top from text to text is what people work with all the time, like that flow along, yeah. And it's what you looked into reinventing wholesale at one point. Mm-hmm. I know that going straight from a text workflow to a non-text workflow, you lose a lot and have a lot of friction. Have you considered sticking another parallel line above that, which converts your non-text representation into text, which is then compiled? Like, would that make it easier to transition from a text workflow to a better than text workflow?
Okay, I'm gonna restate that question in two parts the way I understand it. So the first part is, not really a question, just a statement about some of the work I did before, and I mentioned this in the talk, is about what if I wanted some data structure that was that through line that accumulates my work over time to be anything other than a text file system, right? And they mentioned, which is true, that any time you try to switch to something like that, you run into friction. And I think a part of what I was hoping to get at here is that there is actually already a solution for how to put multiple computing models together. That's what the linker can do. When I write my C code or my C++ code for certain, you know, those little parts where I'm dealing with an operating system API that I don't want to use the C version of, I can put those two languages together through the linker. I can also take a non-language, which is just any raw data block, and put that into my program through the linker. So I think the linker has, even though it's in a lot of ways this untouched, old, almost redundant and uninteresting part of the system, it has the seed idea for how to program without being locked into one language or one model, which means that the friction you're talking about that I myself ran into when I tried to go to a wholesale, let's ditch text and do all 100% of the programming somewhere else, that didn't really seem very practical. Right. And I think that the key to making a transition like that more practical might lie in doing it in small steps. So the first time you take a step there, 90% of your program will be compiling from text, and the 10% will be in the new model, and the linker solves the problem of how you make that come together. And then the more of your code that you look at, you go, hey, I'm doing a lot of arithmetic here, and I'd rather think about this as a diagram of some kind. Well, then you can go and take the couple years it requires to figure out how to make an editor suite for that particular data structure and link it in with everything else you have. You don't need to find a new data structure that does everything text does, but better, which might also be interesting and possible, but I think that the lock-in, the difficulty of coming up with a version control for every format you come up with, all of that might be easier to solve if you don't force yourself to do it wholesale, but instead use a mixed set of computing models.
We have time for one more question. There's plenty more in the chat that you want to peruse later at your leisure. From Anne, I missed that one earlier. Sorry, Anne. How do you justify doing these creative exercises when you're time constrained? for example, programming is not your day job?
Okay, so like I said, whenever you don't need to explore something, the incentives will always be not to. So the way I justify it is like someone's got to do it or it'll never get done. But there's like stuff there to discover, and it also I think implicit in the question is like justify to whom? Are you talking about justifying it to yourself? If you're working by yourself and you feel the pressure to get your thing out on time, how do you justify stopping the forward progress, doing what you know how to do to go and explore the maybe that there will be something cool to discover? And if you're talking about justifying it to someone else, and it depends on who you're talking about, I guess. For me, how I justify it, if that's what you're asking, is that I want to have fun programming, and this is how I do it.
Can we learn more about everything, your thought process, how you even got to this creative point by going to MrForth.com, right? That's your place.
Right. What's your question?
Oh, it's not really a question. It's more like people can go to MrForth.com for this kind of content.
Yeah.
Okay.
MrForth.com has like blog posts. I have old blog posts about information flow diagrams and solving some like number theory problems with them and stuff. And also my YouTube channel, Mr. Forth Programming, where I don't really show those kinds of diagrams super often, but that's just because I haven't made new videos since I've become more and more fond of those. But other similar kinds of thinking are there. Yeah.
I think he's taken a very inspiring risk to, and especially in this economy, to like go indie and to try and make this work. So please support him at MrForth.com, and a round of applause to Alan Webster. You've done really well, Alan.
Thank you.
Thank you so much. This is great. All right, we're on a roll here. We are going to do one more talk. It's also going to be really fun, I promise. And then we're going to do a little break, actually. We're still on schedule. After the talk, I'll let you guys, grab a coffee or like go to the bathroom, and then we can finish with the last round, which is going to be some demos again. So I'm just doing demos, talks, demos. You see what I'm doing? It's like back and forth. So don't worry. After this talk, just hold on to your butt. Sorry. hold on to your seat a while longer, and after this talk, you can take a quick bathroom break, okay? So yes, our next talk is a recurring character in the Handmade community. I absolutely love working with him. He's a good friend too, Meese Remaley, who is an independent game developer and who actually shipped, which in Handmade sometimes we have a shipping problem because we spend so much time lower level. He did actually ship this year, and I'll have him talk about that. Fantastic. It's like a hard puzzler game for those who love like the Braids of the world and like the indie puzzlers, but with forgiving mechanics. And we're actually even going to demo that tomorrow. But for now, he had to work on a lot of with APIs and graphic stuff and like Vulkan, and like we have lots of I tried to use Vulkan for my own projects. Remember, I'm a programmer too, and so I'm writing out my own terminal emulator. I don't mean to digress too much, but a terminal emulator, which is at the end of the day just pushing 2D quads, submitting that to some GPU. But I decided to use Vulkan anyway, but it was going really well after my 1,000 lines of code. I got my first quad up there, and I tried to turn it into a 2D helper library. And after that, I was like, I'm getting some flickering bugs. And I went another month into memory barrier synchronization, and I felt lost. It was rough. I was like, I can't do this anymore. I've been working those of you who remember this, 5 to 6 months, just Vulkan. And I gave it up. I was like, you know what? Soko's fine. SDO works, so I'm using Soko now and just pushing 2D quads around. I'm happier. But there's something about, this title that got me really intrigued myself. It says it's not about the API. And I want to get your thoughts on that, Mason. We all want to know. Give us a round of applause. You're going to have your timer, no problem. Would you like this podium mic or more freeform?
I'll take this.
More freeform. And then,
does this go backwards and forward?
Yes. So this is the big fat green button for next. The red one is back. Awesome. And if you want a podium, you can also do that.
Awesome.
Okay. I'll get this for you. Yeah, enjoy.
Hey, thanks for the introduction, Abner. Thanks for having me again. Always look forward to Handmade. It's one of my favorite conferences. So yeah, let me get this started for you guys. I'm Meese Remaley. I'm an independent game developer, a board member on the Zig Software Foundation. And in the past, I taught grad and undergrad students to make games and game engines. Like Abner mentioned, I shipped my game Way of Rhea in May, and I learned a lot from making it. Talk more about that in a talk at Sickle you can look up on YouTube, but one of the kind of outcomes there is I decided I want to build a new engine for my next game. Way of Raya was built in OpenGL, and as many of you are probably aware, there's a bunch of new APIs that are replacing kind of the old style graphics APIs. And so I decided if I'm making a new engine, it's time to take a look into these new APIs and see if it's time for me to upgrade. So that's what we're going to talk about today, graphics APIs. How many of you also know OpenGL? How many of you are comfortable with the new modern APIs? Okay, so we got like, that's good. So we got a bunch of people, for the people online who maybe can't see the hands raised, a bunch of people used to the old APIs, maybe not as many with the new APIs. I hope this will be maybe informative to people working with the old APIs, thinking about trying out the new APIs. This is my, I don't know, maybe it's my 5 or 6 month journey looking into them. So yeah, let's start off with, I think we all have a sense for this, but let's talk about what a graphics API is. It's supposed to be a picture of a graphics card there, but it's not really a big deal. You all know what they look like, and if you don't, it's that box in your computer that makes it go fast. Yeah, this is what it looks like when it doesn't do its job, when you're not good enough at Vulkan. So yeah, I mean, a graphics API is a way to talk to your GPU, right? You can't just go run x64 on it. You can't well, there are actually ways you could run C on your GPU, but not in the normal way. You're not going to compile a Windows executable file and run it on your GPU. So a graphics API is essentially just a protocol that you use to talk to the GPU. Now, the thing is, there's a few different GPU vendors, right? And since there's a few different GPU vendors, you get a few different graphics APIs. Well, are you telling me those aren't GPU vendors on the screen? Wait, are you telling me that there's 3 different graphics APIs and 3 different GPU vendors, and all 3 GPUs support all 3 APIs, but which ones you get to use depends on the operating system you're running? That's a fundamentally silly situation to be in. Unfortunately, we live in a fundamentally silly world. So yeah, you could have your MacBook, and you could reboot it into Linux, and now you need to use a different graphics API to talk to the same graphics card. And also, all of these APIs are exactly the same as each other. Like, if you're worried about which one to use, it doesn't matter. They're like, details are a little different, the windowing system integration is different. They do all the same stuff because it's the same hardware. So today, we're going to be talking about Vulkan because it runs the most places and it's managed by a nonprofit. But if you're not working in Vulkan, all the same stuff's going to apply. It's literally like these APIs are almost identical. In particular, I'm interested in, for my game, I want it to run everywhere. I mean, that's not true. I want it to run on PC platforms, and I want it to run on consoles. And as part of that, I'm building like a GPU abstraction library, like everyone ends up doing, because you need to support all these APIs. And so whenever I'm adding a new feature, I'm checking like, okay, what would it look like in DirectX? And the answer is exactly the same almost every time. So yeah, if you're doing DirectX, no problem. We're going to do a brief history of graphics APIs here. I wasn't around for most of this, very hazy details, but I just kind of want to build to like why we have the modern APIs we have today and what's different about them. So in the early days, we had vendor-specific APIs. If you wanted to run a certain graphics card, you'd use the API for that card. Makes enough sense. But there's a downside, which is kind of familiar, where you have to use a bunch of different APIs, right? If you want to support multiple cards, you end up writing multiple APIs, and that's kind of a pain. Around 92, one of those APIs, RSGL, became OpenGL. It was released as an open standard that other graphics card vendors could implement, which is a really great idea, right? Because now you can write one API and run it everywhere. But this idea has one fatal flaw, and the fatal flaw is that it's a good idea. And you know who doesn't like good ideas? Yep, Microsoft. So Microsoft, of course, had to make their own OpenGL and call it DirectX. So you still end up with 2 APIs that are the same as each other. Around 2004, we started moving away from fixed function to the shader model. The idea here is that you could write, with the fixed function model, you're kind of just like configuring your GPU to do specific things. With the shader model, you get to actually start running. I think you could do this before, maybe with some kind of like assembly or something. But with the shader model, you can actually write like a text program that runs on your GPU and does nice special effects and stuff. Maybe you want to make a shiny object or a bumpy object. You can just like write the code for your game to do that. Gives you a lot more control. Of course, it also like makes things more complicated, right? Like every time we step to the right on this graph, things are going to get a little bit more involved. If you're just doing fixed function, you just kind of tell the graphics API to draw some stuff, and it does it, and that's it. Here, you have to write a bunch more code. Around 2014, we started getting the modern APIs, and they become increasingly relevant. The idea is that, people are doing more and more stuff with GPUs, and it's not necessarily just graphics. In a way, GPUs are just kind of giant SIMD machines. Single instruction, multiple data set. You have maybe a multiply operation, and you want to do it on a bajillion inputs on the same time. It's the same operation, but there's a lot of different data. And graphics is really amenable to that kind of optimization, but there's lots of other things that can be done quickly that way. And people want to use GPUs to do all kind of cool stuff. So GPUs, the GPU APIs got a lot lower level. You got a lot more control. You got the ability to do way more with them, but as such, they got more complicated, harder to work with. So let's look at this triangle here. We're going to start in a fixed function OpenGL sample I found online. So I know you all probably can't read this from there, but it's about 40 lines of code, and the gist of it is it says here are some vertices, here are some colors, and then let's just loop and draw that triangle. And even if you're not a graphics programmer, if you pull this up at home, you can look at it in a couple minutes, understand what's going on. It's not too complicated. Now, what I'm interested in here is, should I move to Vulkan for my next game? So let's look at the same code, but for Vulkan. Okay, so it's a little bit longer, but a lot of it's comments and white space. So, it's not really a big deal. Oh, sorry, there's another slide. Okay, so it's a little bit longer, but most of it's comments and white space. So it's not really a big deal. It's a little more complicated. Sorry, wait, how many pages of this are there? Okay, geez. Okay, maybe I see why people are complaining. Okay, so we took 40 lines and we turned it into, what's that, 1,180 lines? There are some more comments in white space, but not almost any in this last whole 2 pages. Yeah, so it's a lot more code. There's a lot more going on here. And remember, that's just for this, right? This is not what my game's gonna look like. It's gonna do a little bit more than that. So if that's how much code it is just to make this, imagine what the full game's gonna be like. And also I'm an indie and I'm making an engine, and understandably most indies aren't making engines. I'm the only programmer on the team. So it's I have to build the game, I have to build the engine, and the renderer is not the whole engine, it's just a part of it. I have to build the renderer, build the engine, and build the game, and I'm supposed to do all that just to get a triangle on the screen. I kind of get why people feel like this. So, okay, here's the thing though. You may not like it, but this is what peak performance looks like. Also, it's simpler. All right, what are you talking about? It's simpler? I actually think Vulkan's great. I was not sure that I would think that when I started. And so if you're coming at this and you're thinking, really, 1,100 lines for something that could have been 40? Ridiculous. I'm just going to go use OpenGL forever. That's fine, do whatever you want, but I want to maybe make a pitch to you that it's worth looking into these new APIs, and that it's actually not as goofy as it maybe seems at first glance. But I understand that I have my work cut out for me here, and I'm also claiming it's simpler. It's kind of how is more code simpler? So we're gonna start out with some Vulkan concepts. I'm gonna walk through I'm not gonna go line by line. We don't really have time for that, and I don't think it would be particularly engaging. But we're gonna go through just the core concepts that are kind of going on that are making it longer. Not gonna super deep dive on each of them. There's other talks for introductions to writing Vulkan, but just why is it longer? What's happening in all that extra code? Once we have a kind of rough understanding of what's actually going on, I'm going to go over a way of doing fast, flexible, and simple rendering in Vulkan that I'm using in my new engine. It's not the only way to do good rendering in Vulkan, but I want to show you that it is possible to keep things simple while using these new APIs and still benefit from them. And then lastly, this has kind of maybe shifted my thinking a little bit about APIs and what makes an API good or bad, or how to evaluate one, how to design one, and maybe there'll be some takeaways even if you're not actually a graphics programmer. Okay, so let's start out with some Vulkan concepts. And we're going to kind of compare them to OpenGL, and it seems like a lot of the audience is familiar with OpenGL, so I think that'll be helpful. So first things first, you look at a Vulkan sample, you're going to run into this thing called a physical device and a logical device. The physical device is just the GPU that you're using, and the logical device is kind of like an instance of it that you configured a little bit. And if you think about like OpenGL, it doesn't really have this concept, right? Like when you're writing an OpenGL app, you just kind of you create a context and then you just like write some code, and you don't get control over what device it runs on, which is kind of a problem, right? Like I got a picture of my laptop there. If you have a laptop, it probably has 2 GPUs. It probably has your integrated GPU on the CPU, and it has a separate discrete GPU, which is going to be way faster. If you're running a game, you really want it to go on the fast GPU, not the slow GPU. Like, you know, the gamers probably spent a bunch of money on their GPU. If they buy your game and then it runs slow because it didn't run on the fancy GPU, they're not going to know that's why. They're just going to think your game's slow. And that's a pretty sad outcome, right? Like you wrote something that was fast enough and it just ran on the wrong hardware. Well, OpenGL doesn't really have an answer for you. And it's kind of Microsoft's fault. Like I believe DirectX, old DirectX still had a solution for this, but Microsoft didn't want you to use OpenGL, so they never updated their window integration code. But regardless, you couldn't do this in OpenGL, so the sample code's shorter, right? The sample code's shorter because you just literally skip this step. There was a way to do it. OpenGL doesn't have an answer. To be clear, OpenGL games do have a solution for this. The solution is you like declare a weird symbol and set it to a specific value, and then like the driver looks for it. Like there's a way to do it, but it's like mega jank, and like good luck figuring it out if you don't already happen to know about how to do it. It's probably it's not in the speaker notes. Anyway, ask me after if you're like, how do I make that work in OpenGL? I have an OpenGL game. I can show you the line of code. But yeah, so you're gonna get a few lines of code just to like pick the right GPU. But like, I mean, you want to do that anyway, don't you? Next concept, command buffers. So in Vulkan, when you want to tell the GPU what to do, instead of giving it one, you have to remember like GPUs are asynchronous, right? Like it's a separate device. It's not like you're running the code on the CPU. So you're going to have to send a command to the GPU to tell it to do some stuff. At some point, it's going to do it and complete. You don't send one command at a time. You send commands in buffers of commands. And OpenGL under the hood, that's presumably the same thing that's happening. But OpenGL doesn't expose the command buffers to you. So in Vulkan, it's like you have to actually pick like a queue, which is a port on the GPU essentially. Like each port maybe is like better at doing different operations. Like maybe you have a port for transfers, a port for compute, a port for graphics. Maybe you just have one for everything. I think the graphics ones always do everything. And then you have a command buffer allocator, and you allocate your command buffers from there. You fill them up, you send them to the GPU. So it's some extra stuff you're doing to get the commands there, as compared to OpenGL, where you just like send a command, and it makes it more code. And in the triangle example, it definitely inflates the size of our code. But if how many people have shipped something in OpenGL? How many of you reinvented command buffers in your OpenGL app? Like, okay, yeah, almost all of you. Like only like 2 hands went down. So like, yeah, our triangle example is shorter because we didn't need to reinvent command buffers in it. But the reality is command buffers are a super useful structure when you're like, building a more complicated graphics app, and everyone writing OpenGL code is reinventing them anyway. So your actual Vulkan app like didn't have to reinvent them because they already existed in the API. I mean, maybe you have a software command buffer abstraction, but you don't need it. So yeah, I don't need to dwell on command buffers. It seems like you all made your own command buffers anyway, so you should be pretty familiar with the concept. Now you don't need to make them anymore, unless you want to. Okay, we got pipelines. So the idea of a pipeline is you're gonna have the GPU render some stuff, and there's a bunch of ways the GPU can be configured, right? There's a bunch of like fixed function options that you can change. You can also decide like what shader you're going to run. In something like OpenGL, you just kind of say like, turn this option. You have function calls to turn options on and off. So you can be like, I want to set my blend mode to additive because I want to make a lightsaber and it's going to be all glowy. And then I want to turn it back to normal to render something that's not supposed to be glowy. You just have a bunch of different functions you call to toggle all of these things. And then eventually you call draw. And it's just like a giant state machine. Everything's global. It's kind of hard to manage. In Vulkan, all of these options get baked into a pipeline, and then you bind the pipeline. So say that you have a bunch of particle effects that all are glowy and they're all additively blended, and they have, I don't know, some of these other settings are set to specific values. You put them in one pipeline, and then you can switch to a different pipeline for your other objects. What's nice about this is you kind of know where the cost is, right? In OpenGL, you're writing a little bit less code because you can just, at the time you're going to draw the object, set the configuration options. But it's a little bit hard to understand which options are expensive to change and which options are cheap to change. Sometimes you find your game running really slow and you realize, oh, I wasn't really supposed to change that one a bajillion times per frame, and the other option, it was fine to change a bunch of times per frame. And if you really know how GPUs work, I imagine that you would kind of understand implicitly which ones are slow and fast. But me, when I was starting out with OpenGL, I had no idea. I would just have to experiment and ask people online which options are fast, which ones are slow. In Vulkan, you just build this all into a pipeline. So yeah, it's more code, but you're also kind of being a little bit more honest about what the computer's actually doing. We got a few other concepts here. We got the pipeline layout, which is just kind of saying the structure of the data that you send into the shaders. Relates to the descriptor sets, which is like the actual kind of like the uniform data and stuff, like the options you pass into your shader. And the layout is just the layout of that data. I'm glossing over the details because I think all that stuff you can find online, but the point is that this is a useful concept. It's more code you're writing, but often you actually, maybe not as common as command buffers, but it's often that in OpenGL you'd end up creating something like this anyway, just to get away from the mass amount of global state that OpenGL has. Okay, another one we got. Some of the older APIs maybe would have this if they had better window system integration, but OpenGL doesn't really have a concept of it as the swap chain. The idea here is that long gone are the days of rendering pixels straight to the screen. You're going to be rendering pixels into a buffer somewhere that the window manager is going to display on the screen at some point. And as such, there's different strategies that could be used to display your images. For example, you could be using a kind of standard vsync setup. There's details even within that, but you could be using like triple buffering. There's lots of different ways to configure how the images you render are showed on screen, how often they're showed on screen, what order, how deep the buffer is, which is going to affect input latency, and all of these things are going to affect how smooth your animation is, what the cutoff is. Like if you miss your frame, do you have to wait until the next vsync, or like does it show right away but have tearing? There's lots of reasonable trade-offs you can make, but the point is you probably really care about this stuff if you're making games. You probably really care about when your frames are presented, and with exactly what parameters. And a swap chain is just how you configure that. In something like OpenGL, there's some extensions for controlling vsync, but they're never implemented correctly on any of the vendors I've tried them. Like they work, the basics work, but the details never really work correctly, and the user can always override it, and you just don't get a lot of control. I would argue that even in Vulkan, the main swap chain extension, I would like it to be lower level than it actually is. So it's more code that you're writing, but you probably want your animations to be smooth if you're making a game, right? So you probably want to know how your images are being presented. We got synchronization. So I'm not going to lie, synchronization in Vulkan's complicated, right? But like we all know that multi-threaded programming is hard, right? Like everyone's aware this is a difficult thing to do, right? And this is not, when you're doing graphics programming, not only are you doing multi-threaded programming, you're doing multi-threaded programming on a separate device from the main device. So like, of course it's hard, right? There's complicated stuff going on. It's going to be a challenge, but like someone had to do the same work to make your OpenGL code work. It just wasn't you. Like the complexity's still there, but like OpenGL had to assume the worst case because OpenGL pretends to be synchronous, right? Like there's like sync and flush, but for the most part, you just kind of write your code and it all just works, which it doesn't, and it doesn't know what you're going to do, which means it's assuming the worst case, and you're giving up a lot of performance. So yeah, you got to spend some time figuring out this, and it is going to result in more code that you wouldn't have had to write in OpenGL, but like you have control over your multi-threading, which you probably want. You're trying to go fast, right? So it's hard for me to complain about that. A big one that I see a lot of people complain about is memory management, and it's worth mentioning here, like I am glossing, like I'm just kind of flying past a lot of details. I have like stuff in the speaker notes that if you're like going home and you're writing, and you're like writing Vulkan, that might be useful to you that I'm not going to read here because it's just like quotes from the specification and stuff, but there's like, I'll have a link to the slides at the end and you're welcome to like look at them on your own devices and reference them. But yeah, the gist of it is that when you use something like OpenGL, it basically just gives you a heap allocator and it's like reference counted memory. And so it is like very easy to get started because it's all automatic. But like, most of you are not writing your game engines in garbage collected languages. So why would you want your GPU API to be garbage collected, right? Like that's probably not, if you really think about it, like you're used to it, but like, is that really a choice you would have made for yourself? Probably not, right? You'd probably just use like an arena allocator or do stuff per level or something. We'll talk more about that later. Furthermore, GPUs have many different types of memory that are like good for different things. And you do have some flags in OpenGL that control this stuff, but it's kind of hard to understand what exactly they're for, and you only have so much control, and you can't really query like, what does this GPU actually support? You just kind of hint at what you want, and maybe you get that, maybe you don't. In Vulkan, it's very, very manual. You essentially get a page allocator. I don't know if it's exactly correct to call it that, but the gist of it is that you are not really supposed to allocate small amounts of memory. You're supposed to just say, give me a bunch of memory, and I will deal with dividing it up. And on the surface, this is a lot more work, and a lot of people will recommend using something like a Vulkan memory allocator, which is a totally legitimate way to do this. I'm going to kind of make an argument for a simple approach later on, but if you were just kind of to come at this for the first time, you probably would end up with something pretty complicated. But we'll come back on how I think you can do this pretty simply. CPU side, it's not really too different from something like OpenGL. The driver objects, or the driver is going to allocate them how it wants to allocate them. So there are other features. I think those are the main ones that I'm interested in today. The takeaway here is that like the complexity that you see in Vulkan like existed when you were writing OpenGL. It's just that you weren't the one writing it, right? It was a graphics driver implementing most of it. And I think a lot of people, I've seen a lot of people online saying things like, you know, Vulkan's not good for indies. Like, you know, maybe if you're a big AAA studio, it's good, but for indies, it's too much work. And I honestly kind of feel the other way around in that, like, it is a bunch of work, but, you know, you only have to do this stuff once. And, you know, NVIDIA isn't going to meet with me to optimize my game for their new GPU. You know, like, I don't have that kind of mass audience. It's not going to affect their bottom line. So I don't want to be at the whim of the GPU drivers, right? Like if I write it in Vulkan, I get to decide much more like what's actually happening. Whereas if I was to write it in OpenGL, the GPU is making all these judgment calls about how to interpret my intentions and to try to optimize them. And if you're a big studio, they'll work with you directly. And I just don't really think that's realistic for an indie. So like, I actually think as an indie, having this low-level control is it's almost like an equalizing force, right? Like we all have the option to fully take advantage of the GPU if we can use the GPU at a low level. Whereas if you're writing this high-level API and you're just dependent on making a deal with the company that made the GPU, I don't know, that feels less fair to me. So yeah, I mean, the complexity's there either way. Someone has to write this code. In the new APIs, it's you. It's more work, but you get to go faster. And you don't have these issues where like your shader worked on one person's GPU and not another because you're the one compiling the shader. All right, so let's get into actually using some Vulkan. So we talk about fast, flexible, and simple rendering in Vulkan. This is, like I said, not the only way to use Vulkan, but this is what I'm doing right now in my engine. Maybe I'll adjust it as I progress on my next game, but it's working for me for now, and I think it is a much easier way than I see a lot of people get started with Vulkan. So we're going to go over my high-level strategy. I'm going to talk about like two lenses through which you could look at this kind of stuff. So one is you could look at like writing your renderer as like programming the API, right? You could say, okay, what is Vulkan capable of, and how do I use that to accomplish my goals? And you could write your renderer that way, but the lens that I'm preferring is what is the hardware capable of? How can I use it to accomplish my goals? And then, okay, great. How does Vulkan let me tell the hardware to do that? It's not that different, right? But I think it results in some better decisions and simpler outcomes, and we'll probably see why in these next few stages. So first, let's talk about memory management. So let's think about, you know, instead of looking at it like, okay, what functions does Vulkan have for memory management, and when should I call which? Let's think about like, well, why are we doing memory management on the GPU? What are we even using VRAM for, right? And probably we're using it to store things like level data, right? We probably have a bunch of meshes and textures and stuff for a level that are, say we're doing a level-based game. We might not be. We can apply this wherever. But you know, we probably have a bunch of meshes and textures and stuff for a level that we need to be on the GPU so we can render them quickly. Well, we could just do one big allocation at the start of the level when you load it, or one per memory type that we need, and then just stick all of the data in that allocation, right? And then when you leave the level, you just free it. Oops. Go back here. And you know, it's it's what you're probably doing in your engine anyway, right? Like probably your actual CPU code isn't like loading individual files and dropping them all the time. You probably, when the level loads, like put a bunch of, I mean, hopefully you put a bunch of data into one big contiguous buffer because it's all gonna be cache coherent. It's gonna be easy. You don't have to worry about like constructing and destructing individual objects. You're just like, look, that's the memory for the level and it's gone when the level's over. There's no reason the GPU has to be any different. So yeah, I mean, I think if you were to look at this from an API perspective, it would be, you know, and you're used to OpenGL, it would be really tempting to sort of recreate OpenGL, right? You'd be tempted to say, okay, geez, you know, it's really tough that there's no heap allocator. I'm going to make my own heap allocator for Vulkan. Now that I've made my heap allocator for Vulkan, let me add the reference counting in like OpenGL had. Now you've just kind of remade and worse OpenGL, right? And you've kept all the complexity. On the flip side, you could just take advantage of the fact that it's low level. You say, great, I only really wanted to load stuff when the level started, so put it all in one big buffer. Very small amount of code, easy to debug, easy to maintain. And you can adapt this to other style games. You know, maybe if an open world game, great, divide it into chunks. Each chunk is a buffer, load the chunk when it appears on screen and free it when you no longer need it. So yeah, memory management doesn't have to be complicated. There are a lot of details you gotta get right. I think the speaker notes where I first mentioned memory management have some interesting stuff. A lot of the tutorials cover this stuff. So yeah, you definitely gotta like learn what all the different flags do. You know, you get the stuff right once, and then you can just stick all your memory in a buffer, and you're good to go. Let's talk about vertex data. It's pretty common in OpenGL, right, to have a bunch of different models with different like vertex layouts. Maybe you have some models that are completely static, and all they have are, you know, you have per vertex, you have positions for the vertex, and maybe UV coordinates. Maybe you're doing some like skinned models, and you pass in some extra data to help with the skinning. And you end up having to tell the API about all these different vertex layouts, and you have to change them in and out. And you could do all of that in Vulkan. You know, vertices is just data. We could just put them all in a giant buffer and read from that buffer in the shader. And you could do this in OpenGL too, actually. There's nothing stopping you. So the point, though, is that we could completely sidestep that entire part of the Vulkan API. We just say, look, every single model on this level goes in one giant buffer, all in a row, and the vertex shader just indexes that buffer when it's time to draw stuff. This is called vertex polling. You might think that that would be slow. It turns out that, you know, do your own research, profile and stuff, but my understanding is that on desktop hardware, this is basically what's happening under the hood anyway, and there's not really any advantage to the vertex buffers in most cases. You do still want to use index buffers because they allow for some optimizations that wouldn't be possible otherwise. But you don't need to create all these different vertex object types and stuff. You can just put them all in a buffer and you're good. Also, on top of sidestepping dealing with that whole part of the API, you get a lot of flexibility in potential performance because now you have the option to pack your vertex data in creative ways or even just to generate it, right? Because if your vertex shader just gets a vertex instance, it could go index into your buffer to get the vertex positions and data. It could also just generate them, right? Like really, you just tell it like draw 100 vertices and then it could just do some math and decide where they are. You don't even need a model in the first place sometimes. So by using vertex polling, you just get a lot of flexibility to kind of just be creative with where your vertex data is coming from. Okay, uniforms. In OpenGL, right, you often are calling like GL uniform postfix to set basically a shader parameter. You know, maybe you're drawing an object and you want to make it red, so you first call GL uniform color, comma, you know, your red color, and then like you draw the object, and then when you draw it again, when you make it green, you call it GL uniform to change it to green. You can do this sort of thing in Vulkan too. It's a little bit more complicated. You got to learn about descriptor sets, descriptor set layouts, pipeline layouts, and if you're writing Vulkan, you should learn how this stuff works. It's worth understanding the details. And you could end up building a system that is very similar to OpenGL. It's going to be more code, it's going to be more complicated, but you can do it and it'll be fast. Alternatively, though, you could just put all of your uniforms for the entire scene into one big buffer and then index it in your shader, just like we did with the vertices. And turns out that's like, you know, pretty fast and really simple, and now you don't need to use a lot of the API. I mean, you still need a descriptor set, but you just need one. And this is going to also let us do a bunch of cool stuff on the following slides that wouldn't be possible otherwise. This is called bindless rendering. The idea is that instead of having to bind a bunch of stuff in between each draw, you just say like, look, here's all my parameters for the entire scene in one big buffer. And now you don't need to bind things all the time. You don't need to call into the driver, which means that you don't have this point of potentially variable performance, right? Because when you call into the driver, that's not your code. You don't know exactly what it's going to do, and it might be slow. If you just put everything into a buffer, then that's all your code. You have a memory mapped buffer. You just write to it in your language of choice. And if you're working with other people, they don't even need to be graphics people. You just tell them, look, this is the layout for the buffer. You don't need to know Vulkan. You don't need to know rendering. You just need to know what type of data is supposed to go in this buffer that's going to be rendered, and then any code in your engine can just write to that buffer. And so, yeah, I mean, all of your per object configuration, just stick it in a buffer, and it sidesteps all of that complexity as well. Let's look at draw call generation. So a common thing when you're writing older APIs is to try to kind of optimize for less draw calls, right? It's like you can only draw so many things. Every time you do a new draw call, it takes some more performance. I forget how I laid this slide out. So what you used to do in the older APIs, what you had to do, I think they got extensions for this stuff too, but what you used to do is just one draw call per object. Maybe you use instancing if you have a bunch of the same object. But you can actually use a feature called draw indirect to also avoid this. You're going to see a pattern here. It seems like almost always my answer to everything is fill a buffer with data and send it to the GPU, because that's what we're trying to do, right? Like that's what the job of the GPU API is. It's to communicate stuff to the GPU. So yeah, for draw call generation, we aren't going to draw individual objects. We are, again, going to put all of the draw arguments into one big buffer and then tell the GPU that's what we want you to draw. This is called draw indirect. So the idea is when you draw an object, you typically pass in a few arguments like what vertex to start at, what vertex index to end at, a couple other things. You just put all of the arguments that would go into that function into one big buffer, and then you call draw once, and it will just iterate through the buffer and draw all of those things. This is great in terms of, again, you can just, any part of your code can do this. It doesn't need to interact with the GPU API. If you're supporting multiple different GPU APIs, this part's the same. You don't need to abstract anything away, but also like you can do this from multiple threads. You can even do this from the GPU. So there's cool fancy things people do where they'll do like occlusion calling on the GPU, and then they'll emit like which objects they want to draw into this list from a compute shader. This is like a super flexible way to do rendering, and in my opinion, it's a lot easier. You just put all the data in a buffer, send it to the GPU, hit draw. Okay, let's get to materials. So again, this is a source of potential complexity, right? We could say, okay, every new material is going to get a new pipeline object, right? So we're going to have like a new shader that has new logic for that material, and then a bunch of new configuration options. And then we're also going to have to like sort our draw calls, right? Because we don't want to be changing shaders all the time. So okay, we sort all our draw calls by material type, and then we like issue one draw indirect call for every material. And then, like, you can totally do that. There's nothing like wrong with it. But there's another option because we already sort of have materials with what we've described so far, right? We were just talking about uniforms and how you can put all of your arguments for like a shader into a buffer. There's no reason we can't use that for materials. You can just put a giant switch statement in your shader where you switch on a material index, and then you just run different code depending on which material you're on. So if you're on a shiny object, you put the shiny index and it runs that function. And if you're on a matte object, it runs the matte function. And I know what you're thinking. Conditionals in my shaders, Stack Overflow told me that was slow. This guy doesn't know what he's talking about. I'm not going to pay attention to the rest of this talk. But it's important to understand like why are conditionals slow. And the gist of it is that GPUs are giant SIMD machines, and they want to run the same instruction on multiple data sets. If you have a conditional, and this pixel runs this side of the conditional, and the pixel next to it runs the other side of the conditional, well, that's not really a thing it can do. So it's going to end up stalling while it like waits for one of them to finish. And then if it's like an else, maybe also have to stall again while it waits for the other one to finish. That's slow. You don't want that. But we're talking about materials, right? And materials, we're talking about like per object materials, which means you're always taking the same side of the conditional within an object, which means you never have to stall. So in the case of this approach, this Uber shader approach, which is what people typically call it. It's not, a conditional is just a conditional. Like, is there a cost to it? Yeah, there's a cost to a conditional, but like, it's not when you read people saying, don't put conditionals in your shader, they're gonna make everything slow. This is not what, well, it's either not what they're talking about or they're just wrong. So yeah, you can totally just put a giant switch statement in your shader and switch on the materials, and now you just have a single pipeline for your entire game, which also sidesteps all the complexity of having to like cache pipeline objects so that you do like, you know, between runs so that your load times are faster because you just got the one anyway. So yeah. Some details here on how I do materials. Don't have to do it this way, there's many ways to do it. So this is a little bit of pseudocode because GLSL doesn't actually have U16s, unfortunately. I packed the U16s into a U32, but the gist of it is that each object that I draw has a material index, that's the thing we're going to switch on to decide which function to run. It has 16 bits of just miscellaneous material data that's interpreted per material. So it might be that one material uses it for a completely different thing than another. It's just up to the function that draws that material to decide what to do with it. And then it has a second piece of miscellaneous data that's 32 bits, which could have whatever in it, but often you're going to need more data, like a matrix or something, in which case this will actually be treated as an index into a separate area of memory that has larger data. And the reason I do that is because you want to pack all this data tightly. If you tried to put all of your material data in a single material instance struct, you'd have to make it big enough for the worst possible case. And then all of your simple objects that need very few configuration parameters would still take up all of that space with padding, which would be a little goofy. So the idea, this is just like stuff from Andrew's data-oriented, practical data-oriented design talk. It's like the same sorts of ideas here. You can do all that stuff on the GPU too. So yeah, the idea is you put some data per object in a list of these material instance structs, and then whenever you need more data that doesn't fit, you just treat one of these as a pointer into some other buffer where you store that extra data. Those two lines at the bottom there are just a little useful trick if you happen to be writing GLSL. GLSL doesn't actually support unions, but you can kind of accomplish the similar thing by binding multiple variables to the same binding number, and then they'll just get reinterpreted as whatever type you list them as. My understanding is this is like fully allowed. It's very, very convenient. You do have to make sure you do your math right so that the index is actually the correct index, right? Or to store byte offsets or something. But yeah, this lets you store all of your data very compactly and get it to the GPU very, very efficiently. So yeah, I mean, that's the summary of my rendering approach. It's pretty straightforward, right? You generate a buffer of all of your which vertices you want to draw, just like the start and end indices. You generate a buffer of all of the per object configuration, and then you generate that separate buffer for data that didn't fit in the previous one for bigger material data. And then you issue one draw call for your entire scene that then just goes through and draws all of the objects. So yeah, we just fill up a few buffers, memory map buffers, and then we tell the GPU go, and it does. And it's really not that much code. I should have maybe counted before I came here so I could tell you the number, but that triangle example was maybe it was 1,100 lines or whatever. I'm pretty sure my renderer with all of these features is, I don't know, it's like 2,000 or 3,000 lines of code, and it has all this flexibility, right? Like it has a full material system. You can fill in different logic for different objects. I didn't mention it. There's a few things I skipped. But it has instancing, it has all kinds of stuff, and it's just not really that much code because ultimately all we're doing is filling buffers, sending them to the GPU, and drawing them. So what does this get us? Minimal driver overhead for one. All the binding of resources has a cost. All of the individual draw calls have a cost. Minimal API surface area, which just makes my life easier as one person writing a renderer. And when I want to port to other APIs, it makes my life easier, right? Because when I want to port to DirectX, or if I want to port to whatever the NVIDIA API on Switch is or something, right? There's less stuff I have to implement. I just have to make sure I can get my buffers to the other device. It gives us the flexibility to generate draw data from multiple threads or from the GPU. So I didn't really go over it, but in my engine right now, I actually do issue more than one draw call, but only because I have a thread pool, and I do this work simultaneously in all threads. So each thread pool task issues a draw call just because, hey, why not? Why not do it all in parallel? And if you're working with OpenGL, trying to do stuff in a like multi-threaded fashion is like a little tricky sometimes. OpenGL isn't really exactly designed with that in mind, or at least wasn't from the beginning. There's some ways to make it work. Here, it's just like not a big deal. You're not even, don't get me wrong, Vulkan does let you do multi-threaded stuff. You could use a more like API-centric approach where you're like working with more parts of the API and do it multi-threaded in Vulkan. It is very well designed to allow for that. But like, you don't even need to think about any of that. Like, it's just all the normal rules you're used to for multi-threading because you're just filling up your own buffers with data and then kind of all in one go telling it what to do with them. So yeah, we did skip over a few things. I didn't talk about instancing. And like, yeah, in your actual game, you might have extra passes for post-processing and stuff. And so yeah, you probably end up with a couple more pipelines than just the one. But none of this stuff really changes the overall strategy. Like you can use this approach and kind of add on these extra features. So okay, this all sounds great. Is it actually fast though, right? Like, am I just pitching you a simpler way to use Vulkan that is also slower and means you should have just used OpenGL to begin with? I'm going to show you a little demo here. Start out with just a screenshot, nothing impressive here, but I want to explain what's happening. So here we have a bunch of individual game objects on the screen. It's not like a particle system demo. If I was going to do a particle system, I would just do it fully on the GPU and put 100 bajillion particles and it would go fast. But the point of this here is that I have a bunch of different like game objects. So if you have an entity component system, these are your entities. Whatever your way of organizing your game objects are, this is them. And they exist on the CPU, and I'm going to send them from the CPU to the GPU every frame. So all of the, I'm not caching any data. All of the colors, the positions, and everything getting sent every time. And I'm running this on like a 6-year-old laptop or something. And so I want to see like how many objects can I render using this approach and still hit 60 hertz on this 6-year-old laptop I'm testing on. And they all potentially have different materials and everything too. Okay, so we started out with 100. This is it? It's not showing up there for some reason. I'm supposed to have a slide with a picture with some more dots. Ah, there it is. So okay, I think this is 1,000. Still getting 60 hertz. Okay, we got 10,000. Here, I got a question. How many pixels do you think there are on like a 1080p screen? It's like what, like 2 million? Okay, fuck it. Let's do 2 million. Can we get that video on here? Okay, yeah. So I mean, I don't know. Does your game need to render more objects than there are pixels on the screen? No? I didn't think so. So obviously this is like a goofy demo. The objects are all very simple, but the point is that the cost of getting the data to the GPU is cheap. Obviously, if there was 2 million objects with fancy reflections on them, sure, it wouldn't run 60 FPS. But that's fine. That's your shader code that's responsible for like the fancy effects. The point is that like we're trying to figure out today, how do we use Vulkan to get the data to the GPU so that we can run it? And clearly, if this approach can draw 2 million objects at 60 FPS on a 6-year-old laptop, then yes, it's totally fine. This is a totally realistic, pragmatic way to get to the data to the GPU, and then you can do all the normal optimizations you would do on the shader side to make your shaders fast. And also, like, you can just not draw 2 million objects, and you can cache data. And like, if you're doing a particle system, don't do it this way. Just do it in a compute shader. But the point is, that's possible. So this works. This is a totally viable way to render your entire game, and lots of games do use this kind of approach. Okay, so what makes a good API? Well, lots of people have different opinions about this. I'm not trying to say mine is the only correct way of looking at it, but I think that like going through writing this graphics API abstraction and learning Vulkan has kind of made me think of APIs as just a way of communicating with an underlying system. As a low-level person, often that underlying system is hardware, but it doesn't have to be. The underlying system could be another software system. And I think, it's not the only way to look at it, but I think that it's useful to think of APIs as being like well-designed when they facilitate communication with an underlying system and poorly designed when they obstruct it. And as a consequence of that, if you have an API that's doing a good job at like letting you communicate to the underlying system, but you're still having trouble completing your goals, then it's probably not the API that's at fault, right? It's probably either the underlying system or it's that your goals aren't meshing well with that underlying system. So Vulkan definitely isn't a perfect API. I have nitpicks and criticisms, but I don't think being low level is an imperfection. I think the low levelness of Vulkan is a huge improvement, and I think that going forward, my renderers, despite having many more lines of code, are going to be much simpler. So yeah, that's kind of my takeaway. Maybe think about designing for hardware instead of for APIs. So I got some useful links here. If you are doing Vulkan, you probably often will need to look up info on different GPUs. VulkanGPUinfo.org is a super useful resource. The QR code here also links to the slides, so if you want to go back and look at those speaker notes for anything, you can. VulkanGPUinfo.org lets you look up like how many GPUs support such and such feature that I'm considering using, what type of memory does this GPU have, what type of memory does that GPU have. The Steam hardware survey linked below that is also great. It's a good way of figuring out like which GPUs are players using in practice if you're shipping games on desktop. Some Vulkan tutorials. I wouldn't necessarily ship the tutorial code, but they're great ways to get started understanding the APIs. And then some useful tools, probably all know about them, but if you don't, you should try out RenderDoc. You should try out Tracy. DRM GUI is great. And if you're using Zig, the Snectron's Vulkan Zig wrapper is really nice. So that's it for me. If you want to support me, a great way to do that is picking up my game Way of Rhea, which is on sale right now on Steam. I also have copies in person. If you're interested in more of this kind of stuff from me, I have some talks online at that address, newsletter, stuff like that. Got a GitHub linked there where the graphics API abstraction I'm working on will be public soon. And then I have a bunch of other little game tools and stuff, or wrappers for existing game tools that I'm putting up there. That's all I got for now. Happy to, I think we got a bunch of time for questions.
You can sit down on that chair right there. Get comfortable. All right. I take privilege for the first question.
Sounds good.
Wow, I have a lot of thoughts on this. I might have to ping you even after this talk, but because I told you I'm writing my own terminal emulator, and I started using Vulkan, then switched to Soko once I met these barriers about barriers.
Yeah, once you literally met the barriers, and you're like, geez, what the heck is that?
Yes, but you mentioned uniforms, which is true. I always had that feeling of if I'm updating shaders by calling GL uniform once per frame, like I'm updating a color, yeah, exactly, some value, and I'm doing this matrix transforms or whatever. I always felt like that was doing that one per frame felt like a lot of overhead. It felt a little wasteful. So I did like that about Vulkan, that you have this uniform. I never even went to descriptor sets. I went to uniform buffer objects right away. It's just a large addressable memory, huge byte arrays. Love that, right? And you can do even partial memory writes, and you can decide when to flush it. I think you told me you can decide when to allocate. Even I love that control. For sure, and that's simple for the driver, for sure, because now it's all passed to you. I like that simplicity. But what would you say about, even then though, would you recommend somebody like myself on the just 2D side? Because terminal is just text, right? It's just some text and some icons. I'm pushing 2D quads. Would you still recommend I try and give Vulkan a chance again, or what's your judgment call on that? Because I would still have to do some work to grok everything, right?
Yeah, so it's tricky. I would say you have a project you're trying to ship, and if what you're doing is working for you, then no reason to burn a bunch of time undoing it and trying something else.
Fair.
But I would say to someone in the game space, I might be a little not that you couldn't benefit from Vulkan.
Sure.
But I might kind of push someone doing games a little more strongly to try using the modern APIs, and the reason being that I worked with OpenGL for a long time, and a lot of these techniques I'm describing, you could do in OpenGL, but I never realized because it's very hard to learn what's actually going on. When it's kind of like if you learn programming using Python, and hey, no shade to anyone learning programming using Python.
I'll give you shade.
In fact, it's probably a good way to learn. But there comes a time when you're okay, I kind of want to know what the computer's doing, and you're not going to be able to figure it out. It's even though it's a easier language to do some things in, you're not going to understand what's happening under the hood because it's not exposed to you. And like, and then the thing is, if you ask a low-level programmer to write Python, they can actually probably make it pretty fast because they know how it's actually working. And so if you asked me to write OpenGL right now, I probably could make that demo like the same speed in OpenGL. But if you had asked me to make that demo in OpenGL with no compute shaders or anything prior to messing with Vulkan, I don't think I would have succeeded at it because I just really had no idea what was happening. So if you're someone who like GPU programming is going to be important to you going forward, then I would say like I really recommend giving this stuff a shot because it'll make stuff make more sense. In your case, like you have a thing that you need to get done and it's just a piece of the puzzle. So like, you know, whatever. If it seems like fun and you have the time to kill on it, I'm happy to answer your Vulkan questions. If you decide, look,
if I have an ear with you, then I might give it a shot again. Yeah, cool. I would like the chat to answer this question for me too, and I know you can answer it, but I want to ask other questions from the audience. I'm curious about Vulkan extensions, and I know ever since I did this Vulkan attempt, there's been a lot more extensions that to the point that almost feels like OpenGL if you really want to, with all these layers of there's validation layers, there's extensions. Like, is that really true, and is that worth it? Right, like to even sounds like you want to say something about that. Yeah.
Okay,
go for it. Yeah.
So I would say like first of all, like a few different things. One thing, it's only slightly tangential, but I forgot to mention it earlier. If you're doing Vulkan, like turn on the validation layers. You know, like in OpenGL, if you make a mistake, you can call like GL get error and like kind of find out about it. In Vulkan, it's like you can turn on these layers where it'll just like take all your Vulkan calls when you're in like a debug build and filter them through a separate layer which like will check it'll check like, you know, you pass the right parameters and stuff, but also like it'll check like, you know, for like just common mistakes that are easy to make that like would be maybe hard to, I can't think of a good example right now, but they're going to catch problems and they're going to tell you exactly what you did wrong, and then you're going to go, oh wow, I'm really glad I turned that validation layer on.
Right.
I was going to end up with crazy flickering bugs I couldn't figure out, but the validation layer said, hey, don't do that, you know, your synchronization's wrong, and you're like, oh yeah, you're right, actually it is. But yeah, in terms of like extensions and stuff, there's two things I'd recommend. There are a bunch of useful extensions. If you're trying to ship something that'll like work on a bunch of computers, I recommend looking at that database that I linked, because it'll tell you like, you know, what the support is like, though consider that some entries in the database may just be from before the extension was released or something, so it might say they don't support it, but then if you look at like a newer sample from the same GPU, maybe it will support it, so the percentages might be a little wonky. But you look at what's supported, and then another trick is that I just look at what DirectX can do, even though I'm writing Vulkan, because DirectX is like Vulkan is trying to support a lot more devices than DirectX, so there's a lot of features that are optional or that are only available through extensions, whereas DirectX is like, okay, it's like Windows and Xbox. So if I look at something and I'm like, DirectX has that capability built in, then I pretty much just assume, okay, you know, probably all of my target machines have the Vulkan extension too. That's not 100%, but like it's a good jumping off, like a good way to make a judgment call of like, is it worth looking into? Because if you look into like DirectX doesn't have it, then you're like, okay, well maybe this is like a new fancy thing that I can't really use.
Let's try and do 5 minutes of chat questions before we do the bathroom break, okay? So first question, these approaches like, you know, make one buffer and send it to the GPU, that implies that there is now special logic on the GPU to unpack these buffers.
Yeah.
Is that unpacking code hard to optimize? Like, if it's arbitrary shader code, how does the GPU do these things quickly when it can't have hardware built specifically for these operations?
Yeah. So I'm definitely not like an expert on like low-level workings of GPU, and I meant to thank Martin for I can't see because of the lights all right up there because he answers all my GPU questions, but. My understanding when it comes to, and maybe someone who's an expert can correct me if I'm wrong, but my understanding when it comes to like unpacking like vertex data is that like when you do it manually in your shader, it ends up being basically what the GPU would have done anyway. Like it's sure you told it to do that from the API, but I don't think it's actually like taking a different path on desktop. Maybe that may not be true everywhere. In terms of other data, like you know, uniform data and stuff. I think it just like it depends so much on like exactly what you're doing that I don't have like a general answer. But I would say that like if you're taking a 32-bit integer and you're splitting it into two 16-bit integers, like that's not an expensive operation. And like so yeah, like, you know, the more clever your encoding gets, the more complicated it's going to be. But none of the encodings I'm using so far are really all that involved.
In the interest of time, I'm curating some questions in case you see that I'm going out of order. This question is from...
One other
please,
piece.
please. Yeah.
One thing to consider when you're doing this stuff is whether or not it would be trivially possible for the GPU to prove that what you're doing is consistent across the whole object. So for example, if you're using something to like index an array, but you're deriving it from like the base instance of like the what is it, GL base instance or something, it's like the GPU knows, or that cannot vary within like the draw. And so presumably it would be trivial for it to figure out, okay, we can reuse that result for the entire draw. I don't know enough about the low level details to know like when that is and isn't done. I'm under the impression it's done sometimes. So yeah, like I design all of the unpacking to be presumably trivial for it to figure out that yes, the entire object will get the same result here. So yeah, that's not hard to do though, because you're usually doing it based on your instance index, which
Next question by Rez Mason. Do you have any thoughts on WebGPU or the WebGPU implementation for indie development? These techniques you showed look as feasible on WebGPU as Vulkan or the others.
Oh, fellow Mason. Yeah, I mean, it seems fine. I'm not like, it wasn't like, I'm trying to figure out how to put this. All these APIs seem really similar. I think that when I was looking at it, there was like, maybe it was like indirect drawing or something that like wasn't fully supported, or I feel like there was like one of these features that like wasn't fully supported there, and it felt a little silly because I was pretty sure that the underlying hardware all supported it.
Yeah.
I'm personally not using WebGPU just because I don't ship on web, and I understand that WebGPU works on desktop, but like every platform that WebGPU works on desktop, Vulkan also works on, and it's like what the like all of my graphics debuggers work with Vulkan. It's what the like graphics card vendors are like giving advice about directly, and I don't know. I don't want to go through Google stuff, and I don't want to do text shaders. I don't understand why they had to do text shaders. I think maybe you don't have to anymore. Maybe they walk that back, but I think it's perfectly viable. Like all these APIs are very, very similar to each other. It's just I do get a lot of people asking me like, why make an abstraction layer when you could just use WebGPU? And I think that's a little misguided because it doesn't like, I need to work on PC and console. If I just needed PC, I would just do Vulkan, and then I would use Molten VK for Mac. I'm not even shipping on Mac anyway, actually. And if I want to do consoles, then, well, I'm gonna need to do something else besides WebGPU or Vulkan or whatever. So, but it works. You could totally just use it and do most of the same stuff.
This one comes from Redline. Is there a Vulkan tutorial that isn't an object-oriented monstrosity?
Yeah, not that I'm aware of, unfortunately. It's a little frustrating because I think that half the time I spend when I'm reading like a tutorial for like a new Vulkan feature I don't know is just trying to untangle they built like abstractions for it like up front that aren't the abstractions that I want, and I have to like undo them to understand what's happening, and then so yes, sorry, I don't have any good recommendations there.
I personally rewrote every example from vulkan-tutorial.com into vanilla C from C++ and C++ 17. Not easy.
My recommendation would be yeah, undo all the object-oriented stuff, but don't try to replace it right away because it's too hard at the beginning to understand. Like, it's too hard to see the forest for the trees until you've like gotten the triangle working. So like I would build like 0 abstractions, and I would like just get even when they tell you like you should build an abstraction for this, like don't do it. Get to the point where you have the triangle, and then that's your time to go, okay, I have all of the parts. Now I can sit down and think like, how can I actually chunk this up in a meaningful way? And I think you'll do a much better job at that point than if you try to do it from the beginning.
The final lesson in a tutorial, one of the final lessons I think is to import some 3D model, like some OBJ model. And I remember I was like, oh, it's just, some OBJ models have duplicate vertices in the data, so you can just deduplicate by doing a memcompare. You loop, memcompare, and discard. I was like, oh, that's exactly what they're going to do, right? No. They import an unordered map. They do custom template specializations with hash functions, so you can index into vertices as an array.
No, what kills me,
I just want to render it. Sorry, go ahead.
Oh, no. Well, what kills me is like, I don't know, your game shouldn't even be doing any of that, right? Like convert the data to a format that you can just upload and do no processing. And don't get me wrong, like you do need to, at some point, do the deduplication. And yes, it should be in an offline tool, and no, the beginner trying to learn the API for the first time doesn't need to learn how to write that tool, but that's exactly my point. Like, if I was to write a tutorial for Vulkan, and I'm not like hating on the people who write tutorials, I'm very grateful for that to them because, hey, that's how I learned Vulkan. But if I was gonna write a Vulkan tutorial, what I would do is I would give a model file in a format, like in a binary format, where it's just literally the list of positions with no header and nothing else, and be like, look, for the purposes of this tutorial, just load this into memory as is and do zero processing, and then maybe have a separate stage later where I show the code for how I made that file. And then, yeah, don't do it with hash maps and stuff.
Couple more questions and we'll conclude. And there are still more questions that I hope you can answer in the chat later. So from Seth, thank you for your question. Have you used Soko? Can you do bindless rendering and vertex pulling there?
I haven't used Soko. It looks great. At the time that I looked at it, and this may not be true anymore, at the time I looked at it, it was like, maybe not the last generation of APIs, but like the in-between one, and I wanted to be on like the absolute latest thing, so I was like, okay, I'm just gonna do it myself. But it looks really great. I do not know whether or not you can use these techniques there. I would not be surprised in either
Question from Mige. What was the alternative for the, I think he's asking for something. What was the alternative for the Vulkan memory allocator library?
Oh, yeah. Yeah, and another place where like that library looks great. Yeah, I just make like one big allocation like up front. So it's like, well, one per memory type. So, okay, the simple version is I make one big allocation, for example, on level load, and then I just bump allocate into that, because you never really like free stuff, right? Like,
interesting.
Like, how often do you need to remove a texture from the GPU, right? Like an individual texture, right? Like, you probably remove the whole level. Now, if you're doing some kind of streaming thing, then you do need to remove stuff, but you could just remove a whole chunk or add a whole chunk. If you really are doing something fancy where you're like, you know, having like streaming in higher resolution versions of textures, you could just like leave room for them in that buffer. So the idea is that you don't need a heap allocator because you know, I really don't like heap allocators, like in general. Like, it's almost, it's in a high level language it makes sense, but when you're doing low level stuff, you almost always know more about the lifetime of your objects than a heap allocator does, so you can almost always do better. And it sounds like you're like doing more work then, but like the answer is almost always like a bump allocator, where you just like add stuff, like you say here, the first object starts here, and then you just add the next one after, and then the next one, and they're all just next to each other. And as long as you get the alignment right and stuff, like that's fine. And it's so simple and it's so fast. So that's what I do. The wrinkles come in when, first of all, like the alignment restrictions can be different per GPU. So you do have to do some work to get this right the first time. So you got to read about like what the alignment rules are, and there are also different memory types. So it's not really just one allocation. You need to make a few allocation based on the different types of memory. What I recommend here is look at the memory types that DirectX exposes, because it's a simpler way to kind of understand. Like Vulkan will give you like 10 different flags. And essentially what I ended up doing was just re-implementing the same ones DirectX gives. So I have like an upload buffer, a readback buffer, and then like a static buffer. Mm-hmm. And then also like a base address register upload buffer for like smaller, faster uploads, or big ones if it's resizable base address. Anyway, there's like 3 or 4 different like memory types. And then within that, you might need different stuff for like vertexes versus images and stuff. So there's like details to get right, but the point is that you make your big allocations up front, and then you just bump allocate into them, and then you don't have to worry about heap allocation and garbage collection and everything.
In the middle of your talk, there was one comment, I think it was from Ruben, who said, your talk is a great high-level introduction to boneless rendering. And now there's a whole running gag there that I hope you enjoy after this talk. Well done, Mason. Round of applause. Round of applause. Nobody but you could probably
I was
tempt
clapping
me
for the boneless joke, not for myself. Yeah, boneless rendering is when you do like the ollie, but you put your foot on the ground while rendering the triangle.
I wanna. Oh yes, you can make yourself back in the theater, and
thank you again for having me.
Of course, always a pleasure. The only person who could probably motivate me to try Vulkan again. Here's your jacket back. Why am
Let me know if you do.
Holding it in mine? Okay, cool. For the staff room in the back, if it's okay to put up a little video, the same video as always, with the start coming back again soon, so that we can give the audience here a bit of a bathroom break, okay? So I know we're a little behind the official schedule, but I promise you, my organizer magic will still be done by 5, okay? So 5 to 10 minutes, no more. please, 5 to 10 minutes. Go to the bathroom, go drink some water, talk in the lobby. If you want to stay here chilling in the chair, no problem, okay? We'll be back very soon with our final presentations for day 1. 5 to 10 minutes, no more than 10, please. 1 minute? Quickly, quickly, so we can finish at 5 o'clock on the dot. 1 minute. All that's left are cool demos. No more talks today. Got some cool demos coming up. "30 seconds, giving you a hard countdown here. 30 seconds, and I'm gonna start talking. The last couple of stragglers settling down. Very good, very good. I'm happy. I am happy. Excellent audience. Okay, let's begin. This is the last bit of the day. By the way, thank you so much. There's many people who couldn't make it today, like I said, many times today. I'm just trying to be grateful to them anyway, because they bought a ticket, plane tickets, everything. Hopefully they'll be here tomorrow. We even have even more people. But awesome for those who are here. Thank you for making it. And this is it. This is the last couple of demos we have for day one of the conference. And I saw some people with luggages coming in today even, like just straight from their plane to make it to this conference. So I hope that I can let you go early at 5 so you can get some well-deserved sleep tonight. So the last couple of demos. One is an interesting project. It's called ARC. And I think it's also online. I think the next demo is going to be the person's here in person. But so ARC is an interesting project. It is a version control system, which you would think interesting because everybody uses GitHub and things like that. So a handmade person is taking on version control. Why? What does that mean? Interesting demo for us. So a round of applause to the creator of ARC. I think he's on the chat, hopefully. So if you're on the chat, Nuno Afonso, please say hello on the chat so we can take a look at what you've done today.
Hello, my name is Nuno Afonso, and today I'd like to present to you ARC. It is a small binary that holds a centralized version control system, containing both server and client, including a built-in GUI. Throughout my career as a game developer, I was often frustrated by the available version control options. We have solutions that are a mix of too complicated, too expensive, with bad performance, not suited for binaries, can't properly track local changes, and try to hook you to their cloud service. So I decided to take my experience and build an alternative that tackles all of these issues. ARC takes a different approach to the other solutions, focusing first on the GUI version. This tightly coupled approach enables it to take performance very seriously. In this example, we're importing Unreal Engine 5, which has over 200,000 files and folders. And as you can see, it handles it quite fast, always trying to maintain responsiveness and giving you appropriate feedback. And although performance is nice, the actual main goal is being simple and easy to use, so that any team, no matter how small, can use it with confidence, while still having a breadth of features needed for bigger projects. Arc takes concepts from other solutions, but always tries to see how they can be taken to the next level. One such example are shelves. With other implementations, shelves are a one-way street, which prevents people from using them to their full potential. With Arc, shelves are bidirectional. This means that you can now work collaboratively in situations where you're still not ready to commit, and without going through the friction of having everybody involved jumping back and forth between branches. As everybody in games is aware, handling binaries is quite important, and Arc has its own approach called soft locking. In this approach, instead of having a single lock owner, it has a lock queue, where the next in queue will automatically receive the lock whenever it is released. And if you really need it, you can always request the lock from the current owner, bypassing the queue altogether. Arc's philosophy stems from trunk-based development, in which branching is a less common operation, used mostly for stabilization. That being said, it doesn't do anything to prevent you from working with a more branch-oriented approach, and as such tries to make it as simple as possible to handle branches. In the history panel, you can create a branch from any change list. To merge, you also select any change list and choose if you want to cherry pick or merge all up to that point. The approach to make it easy to use also extends to managing the server itself. Migrating your server is as straightforward as moving a folder to a new location. Arc has no external dependencies, doesn't require complex setups, and you can run it on Windows, Linux, or Mac. This is Arc, and if you like what you see, please give it a try at arc-vcs.com. Oh, and by the way, while this whole demo happened, Git was doing its best to import Unreal Engine.
Isn't it amazing how this started with, Handmade Hero, a series about making a video game from scratch, and now it's just spilled out everywhere, not just in video games. It's really, really cool. So 5 minutes, like before, just for a quick Q&A, just to honor his demo and to honor what he's done. For 5 minutes, quick Q&A on the chat server, and we'll move on to our next and final demo, whose presenter could make it in person today. So we can do a Q&A here in the fireside chat to wrap up the conference. So yeah, 5 minutes. You can put music in again too if you want to. Couple of minutes, couple more minutes. One more minute. All right. Obviously, questions can keep coming and being answered on the chat server. No problem. But I think we should give a round of applause to ARC, the version control system trying to take on the incumbents. It's amazing. They always remind you that you can DM these folks. You can continue asking questions on the chat, no problem. Okay, I want to close out the conference with another demo. And what better demo than a video game? You know, we're celebrating the 10-year anniversary of Handmade. We might as well. And I had a chance, by the way, I always review every submission, and this year, and I had an interview with this creator, and I was like, wow, this is quite a love letter to the genre that he's doing. I don't want to spoiler or anything. So this is called Project Salarybot, and I know for a fact that he's here in person and that it took some effort to get here, given the circumstances. So a huge round of applause to this demo, Project Salarybot.
Welcome to your first day on the job at the company in the crater of innovation. Established in 5842, when Bargain Technology Weapons and the Clownfish Technology Company merged to form the Technology Weapons and Technology Company. As part of the Digital Inclusion and Compliance team, you'll be responsible for the forced repossession of contaminated company assets from our chronic customers. Your contract says 9 months, but the clock says 90 seconds. Get ready! All restrictions on force have been lifted for this assignment. Investigate strange shit. Barter with the Meownager. Take what you can. Learn! Competition drives us to do better. Salarybot Shuffle.
Hello, and thank you everyone for sitting through that. My name is Shib Duman, and I'm the creator of Salarybot Shuffle. I spent the last few years working on this game in my spare time, and I'm a mixture of nervous and excited to share it with all of you. Before going into some technical details, I would like to state off the bat that this game absolutely would not exist without the Handmade Network community. So while I have everyone's attention for a brief moment, I would like to say thank you so much for all the blog posts, discussions, and repeat answering of silly questions. I'm not even done with this thing, and I can already safely say that I couldn't have made it this far without being fortunate enough to have found the Handmade Network community online. This project started out originally as a desire to make something that resembled a fighting game. Capcom was a big influence on my taste when it comes to video games, so I thought it would be a good learning experience to make something I'm familiar with. I spent a few weeks getting a really simple prototype up and running with Raylib and Box 2D. This early version served as a test bed to see if a few of the things I was hoping to achieve were possible. Specifically, there were two major goals that I had from the outset for this prototype. The player should, quote-unquote, feel good, whatever that means, to control and move around even in a relatively empty environment. Playing the game with multiple people over the internet should also feel good and not be a miserable experience. The initial prototype showed me that getting Box 2D to behave nicely with non-realistic physics was possible. Additionally, getting Box 2D to serialize the state of just one game world was also possible. I soon realized I was, in fact, writing more code to work around some of the limitations of the physics engine I had chosen than I would have if I had just decided to write my own very small but very focused physics code instead. After a few weeks of more prototyping that involved shelving a lot of my existing code, I managed to painstakingly type out a not a physics engine. This iteration of the game code went on to become the basis for the Salarybot Shuffle demo that's being released today. I've made the joke a few times in the Handmade Network Discord that what handmade means is mostly just branding confusion about what constitutes handmade software. I would say that the biggest takeaway for me, at least, is that handmade software is mostly about saving time for everyone, and not just in terms of CPU cycles. Handmade software is purpose-built, which necessarily means that compromises need to be made to ensure its quality along dimensions that are important to the end user. For me, this meant that I didn't actually want a physics engine, because nothing about this game about juggling crazed consumer zombies in the air to take their toxic junk products away from them resembles anything that looks like real physics. This applies to more than just physics code. There's a deferred lighting engine within the game, and at the same time there's a hard cap on the number of shaders that the game client can utilize. It's currently capped at 5, by the way, if anyone's interested. For anyone that's new to the handmade scene that might be watching this, I encourage you to try your hand at some of the harder stuff. Whether it's just native programming, assembly, OpenGL, or becoming another abuse victim of the CMake build system, I can promise you it's not that bad. Except CMake. CMake is in fact that bad. Fair warning. Thank you all for listening to my ramblings, and please check out the Salarybot Shuffle demo if you have time. Enjoy the rest of the conference.
Bravo. Yes, come down here, sir. Just let's wrap up this conference with some interesting questions. So anybody who has questions for him, it'll be just like any other presentation where we have our little fireside chat here.
Testing. Okay.
Awesome. Okay, so this is such, like I said, it really is a love letter to this genre. And how long, what's the timeline here? You said a couple of years, right? Hard work?
Yeah. I want to say maybe like 2.5 to 3 years of just like really focused work once I knew like the direction that I was taking it in. A lot of that was spent like, I don't know, like going through the learning process of being like, okay, like Box 2D gets you up and running pretty fast, but then like there's a lot of pain points associated with it because like the physics engine doesn't like the fact that you're randomly deleting and adding physics colliders to the scene at the drop of a hat, right? So Yeah, a lot of it was just like, a learning process during that period. But yeah, about 2.5 to 3 years, I would say.
Oh, the first question is a hard-hitting technical question from Ruven. Does it have co-op mode? And if not, can you add one?
No, and yes, I will add one. I did kind of run out of time. A lot of it is just like, I'm a little embarrassed to say this, but it's like I have to like get the screen up there for co-op mode, and that takes a little bit. So I kind of ran out of time during the demo because like I don't know if anyone saw me, but I pushed this like an hour ago out. like it went live like an hour ago. So like yeah, I do want to add a co-op mode. I do like the idea of just being able to drop in and play with friends kind of thing. That is the main reason I spent all the effort building the rollback netcode in there, because I just wanted to be able to play with like my friends on the East Coast without feeling like the connection sucked or I hated the game or something.
The professor asks, how big is the game now? Like, lines of code, the developers, etc.
I want to say it's around 30,000 lines, I think. I mean, it's a little bit tough to say. So like, for example, I'm using Raylib, right? Like it's another handmade like project, which I'm like, I mean, it had some friction points, but I'm largely happy with. So like, I mean, if you include the Raylib dependency, like God knows, like, I don't know, like to like however big GLFW is. But yeah, I would say about like 25,000 to 30,000 lines is my guess.
Question from Margaret. Thank you for your question. Have you tested it on Linux with Proton?
I have not yet. I don't think there would be anything that would prevent it from running on Linux. The networking stuff actually runs all through Steam. Like that's like, I know we spent a lot of time like trashing large companies at this conference, which they justifiably had coming, but like Steam actually like handles all of that stuff for you. Like if you like, all of my network traffic runs through Steam's backbone, and like all of the like lobby system is like just done through Steam. It's honestly kind of been really nice to just have that handled for me, as opposed to like, okay, well now I have to set up a server, because like you still need to orchestrate that. Like even though it's like a peer-to-peer game, you still have to like orchestrate all that stuff somehow. But yeah, sorry, I'm getting a little off track. Yes, I think I could get it running on Proton, or just on Linux natively, frankly. But I don't want to make any promises.
Have you tried it on Steam Deck?
I have not, because I did not bring my Steam Deck with me, because I didn't want to be tempted to play anything as opposed to try and finishing the demo.
Spoken like a true gamer. From AXN Jackson. If you were starting this project today, having learned the lessons that you did throughout development so far, what would you change about your process, your code base, etc.?
I think the biggest one would be I would try to come up with a much simpler solver for the physics code. Like anyone that's written either like a character controller or like a physics engine, like dude, slopes suck. Like just get it. Like I want you to like move up this slope is like a nightmare. And like
you just gotta fix the sinking speed, dude.
The what? Yeah.
Like some got the reference.
Yeah. But like, yeah, just like stuff like that is really honestly kind of rough. So I don't know. I would try to start out with like a really, really simple, like even just like dumb brute force kind of physics solver before doing anything fancy. Because like right now, like it is a custom physics engine and it does crazy stuff like, shape casting the player down to make sure he doesn't clip through anything, but then also does like simultaneous ray cast to make sure that like, okay, if he's at like the edge of a cliff, the player's capsule collider doesn't like hug the edge of the cliff as he, as he approaches like the fall off point or whatever. So like there's kind of a lot of like I don't want to call it spaghetti code, but I don't really have a better word for it. It's just like there's a lot of code preventing the physics engine from getting into a bad state while like maintaining responsiveness for the player. So I definitely would suggest like figuring out how to write a really simple like solver that doesn't, that handles things like tunneling and slopes kind of nicely, right? And I would just like start from there. And if you could minimize the amount of like stuff that you need, like if you could do your whole game with axis aligned bounding boxes, for example, do that. That'd be great. Like I would, like if you can get away with it, like I'm not saying it'll work for every game, but if you could just be like, yeah, I'm only using AABVs, like cool. Yeah, do that.
From Area Success Dev, thank you for your question. Advice for breaking down a big project like a game into smaller chunks as a beginner.
I don't think I have any advice here. This was a slog. Like there were so many games. Like for like how long I've been working on this. Like every time there was like a Handmade Network like jam that came up, I'm like, no, you would suck if you abandoned this project to go work on this game jam. You should just keep working on this. And like that's yeah. I'm sorry, I don't have any great advice for that. It's just kind of a slog, unfortunately.
Yeah, there's no straight path as always. It's just this huge. Yeah, more or less. Not a question, but from Cloyne says, hey, no questions, just cheers. I didn't realize you were making a game that's so exciting. Thank you for the
Thanks,
comment,
man.
Cloyne. Yeah. Looks absolutely fantastic. Gives me Mega Man X vibes. Look at that. What do you think?
Yeah, that's... I mean, it's hard to cover up that influence. Yeah, it's like all over that thing. Yeah. Capcom's gross stink is just all over this product.
From Starfreak Clone, thank you for your question. Since you built your own physics engine, would there be a gravity gun?
I don't want to say
He's
no.
pondering.
To this.
He's pondering.
Yeah, it's a reasonable question. Maybe. Like, if I can think of like how the gravity... Yeah, all right, I'll go with maybe is the best answer I can give there. I don't want to say no to any potentially fun ideas. That sounds fun. I don't know.
Next question from Edu. What's happening to the fighting game? You plan making it next?
So I probably not. I think this is like this is what I think I took what I liked from fighting games and I just like jammed it in here. I don't know, maybe a little thoughtlessly, but it's in there now. But yeah, I don't think I want to make a classic like straight down the road like fighting game. I played Marvel vs. Capcom 3 at my wedding. Like that's how much I like these things. But at the same time, like at the high level of those games, I'm like, cool, man. You just hit this dude for like a combo that went on for 170 hits, and he didn't get to click a button. He just died. Like it was just watching somebody die to somebody else who memorized a 170 hit combo. And I was like, that's, I mean, kind of cool, I guess. It's cool to watch, but it's also like I don't want I don't want to create a fighting game that's so straight down the straight down the traditional path that the genre's gone, that that's where the end result of the game is, right? Like you can definitely do some degenerate stuff to people in this game. Like I let you cancel into a lot of things, but at the same time, I want the game to be more about there's this fun fighting game stuff, but there's no health in this game. You're only punished if you get hit because you fail to meet your quota. Like it's all about time management and decision making, or at least that's what I'm hoping comes across. But I don't think I'd want to make a traditional just straight down the straight by the book, whatever, traditional fighting.
Yes. Can you give the cat? You can tell the conference is almost ending here. Can you give the cat a hat?
I could. They're based on my. I should have put that in the thing. The cat sprites are based on me and my wife's actual cats.
Oh no way!
Now I'm regretting not putting in there. I'll post it in the chat, but yeah, I'll put hats on them. I'll do it.
Is the cat considered a physics object?
The cat has there's no concept of physics object in my game. There's just you have an entity and you have associated colliders with it. So it doesn't have any in the traditional sense of it has a rigid body associated with it. If that's I'm guessing that's sort of what the question was. But it doesn't have any it's not a physics body, but it has a collision box. And if you ever hit it, it parries projectiles too. I should have put that in the trailer too. But if you shoot it, the projectile fires back. So yeah, it has a collision box, but it's not it doesn't have any forces being applied to it, if that makes sense.
We can do one more interesting question, I think, and wrap it up. So, what about? I'm ignoring all the cat questions now. Sorry. What about a co-op mode where people need to work together to meet the quota?
That kind of goes back to the original one. That is going to be basically the co-op mode. It's just like I didn't add the filter in time to make it so that your hits don't get checked against other players, because I was like, well, I need to get this demo up. I'll like add that in like later on. But yeah, I co-op is going to be one of the modes, but it's like also I had to like right now the online mode just defaults to versus, because I didn't want to build a menu that let you pick the mode because I was like, that's kind of a minor, like, I don't know, that's just not what I wanted to focus on just before getting the demo out. Like, I kind of like the fact that it's like goofy, beat your friends up kind of thing. But yeah, the goal is to make this difficult enough that the co-op mode is like calling in like help, essentially, right? Like, I really like that idea of making something so absurdly difficult for you individually that if you want, you can sit there and grind it out, or you could just be like, I'm gonna call 4 people and we're gonna all beat up this one dude carrying a pile of stuff. Like, that also sounds really fun to me. So yeah.
I want to say you represent one of the best things in the community, where out of a love for video games, out of a love of programming, out of a love of software quality, you have braved bad flights and storms, and you have a wife and a family, and you're gonna be a father soon. Like you still worked and like did this, right? Beautiful demo, beautiful game. A round of applause for Shib. You deserved it.
Thank you guys.
Well done. Well done. It was awesome. Everybody's amazing, by the way. Everybody today has been great, and you can go back to the theater if you'd like, and I'll mention my closing notes. I'm tired. Like, look at the conference is almost over. What's going on with me? I would like the Kagi folks and Tomas Diaz to come downstairs here so they can see your faces. So because of the year, we couldn't do a trade show floor like previous years, just so we can survive this economy, right? Don't leave yet. Sorry, the people I mentioned should come down here. I'm saying the others, please don't leave yet. So I want to say that there are still job booths, and so for those of you who are looking to maybe have a job, find a job, whether it's with these companies or maybe they help you find other companies, they might help you network and stuff like that. They're all in the private chat server here, but they're also in person here. So for those who are on the online track, there's literally dedicated channels on the chat server for these companies. You can talk to them, you can send them DMs and ask questions and try to apply. Don't be afraid, even if you think you're not gonna get it, apply anyway, okay? And break the ice. So let's just start with Kagi real quick. So the tech lead over here. Yeah, all of you. We got a bunch of Kagi people. So here we go. This is the tech lead and the team. Yeah, Margaret and let me know your name. Jacob. Seth. Okay. So this is awesome. So when we have hangouts, whether there's tonight or tomorrow or Friday. Remember Friday, for those here in person, we have hangouts all day. Hopefully you can make it to some of those. Right? Hopefully you can do hangouts and things like that. So if you feel like you want to like shoot the breeze with you guys, you won't feel, hopefully too harassed or anything like that. You guys are willing to talk to people, and whether it's for job or not, right? Like, you're cool with talking about Kagi, cool. And I hope it's the same thing for Tomas. So you can come down here too as well for KCSE. You've been in the job booth before, and you're going to be also a speaker tomorrow. So I'm excited about that. So these are the folks for you guys to talk today, tomorrow, and Friday, okay? So give it a shot. I know it's a bad economy, but it's bouncing back. I gotta tell you, I keep track of these things a lot because I'm a business owner. Hey, Kagi! I'm a business owner. As you know, I run a business. This is a business at the end of the day. And yeah, the Fed, at least in the United States, the Fed interest rate was cut because inflation is cooling down, and now it's projected to be cut every quarter after this. I've already seen many of my friends receiving recruiting offers again. It's going to be a lagging effect. There's still going to be some pain right now, but starting in 2025, it's going to keep, going up and up. So the fact that we already have some people here, like, willing to talk about roles and jobs, it's going to get better and better. So it's been rough. Okay, you can be honest. You can complain a little bit. It's okay, and it's going to get better. All right. Thank you, guys. A round of applause for our job booths this year. Thank you. Sorry for making you come down here. You can go back upstairs. Perfect. And then tomorrow is the same thing. Copy paste of today. 9 a.m. we start scanning tickets and then 10 a.m. we open shop and we start the presentation. Talks and demos again. Once again, excited stuff. And then lunch hour, as 90 minutes. Copy paste. Okay. So I hope you guys enjoy yourselves tonight. You are on your own. I need to sleep, but But the chat server, remember, there's a meetups channel. There's a meetups spreadsheet in the rules channel. There's meetup spreadsheet, there's a meetups channel. Talk to people, hang out tonight if you still have the energy, okay? Go do stuff, go socialize. You know, you spend money on a ticket, you should make the most of it. Make friends, okay? And then, I mean motherly, make friends. And then tomorrow after the conference, I will announce official dinner plans, and I'm hoping to do a reservation so we can all have, you know, a nice little restaurant dinner together tomorrow. And then Friday, for those in here in person, I'm gonna be running Hangouts, official Hangouts. It's on the website, okay? Conference website, Handmade Seattle, click on day 3. Friday is just for Hangouts. Friday, we're not gonna be here. Tomorrow, yes. Tomorrow's copy-paste of today in terms of format. Friday, gonna be Hangouts organized by yours truly. You know, I always have help, but I'm gonna be there. And I like working on that, so I hope to have a good time with you, even if I can't talk to you a lot tonight, but tomorrow for sure, and then Friday for sure. So for all the speakers today who have made the trek to make it here, for all the demoers today, I am so grateful. For you guys sticking here all day, for the online track, it means the world to me that even in a year like 2024, we've survived and we're thriving once again. So round of applause to all of the speakers, all the presenters, all the audience. I have officially reserved this venue. I literally paid until 7 p.m. So if you guys, we're done with the conference for today, but like you can still hang out here and talk to people. You can go to the auditorium, into the hallway and talk to people. Just network. I'm calling it networking here, okay? The scary, dreaded word for low-level programmers, networking. Please try to do it, though. Please try to do it, okay? I encourage you so much. You have no idea how many lives have changed by some random conversation that you had in a conference, and then months later you got like a job offer, or you found your best friend or partner. I hear so many of these stories, okay? So take a chance, do it. Until 7 p.m. So like 6 o'clock, I feel like people are gonna probably start vacating premises, but it's officially all the way until 7 p.m. And then I'm gonna literally kick you out, okay? After 7 p.m., I'm gonna kick you out. So yeah, see you tomorrow, guys. See you tomorrow, same time, same place. Same time, same place.